travel beyond Earth and settle into 11 plus continuous hours of cosmic calm. This stellar compilation draws on the soothing frequencies of the universe, using concepts from astrophysics to create the ultimate backdrop for deep sleep. Tune into the void, let the celestial science wash over you, and sleep soundly through the night. And we'll keep drifting, floating together through the mysteries. 100 Big Bang mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the first heartbeat of creation, so brief it almost never happened, carrying hints of a universe that came before. The cosmic background glow, a faint ancient lullaby still humming from the dawn of time, and space-time itself stretching softly outward, raising the quiet, impossible question of what waits just beyond the edge of everything. There's nothing you need to do now, just let your body sink heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into Big Bang. In the beginning, before beginning had meaning, there was something smaller than small, tinier than the tip of a pin, a cosmic singularity, infinitely dense, infinitely hot, all of space, all of time, all of everything, compressed into a point with no dimension, no direction, no yesterday, no tomorrow, just potential, pure potential, breathing, waiting, and your breath now, soft, shallow, matching that ancient rhythm, in, out, feeling yourself compress, condense into this moment, this bed, this darkness. Scientists call it the primeval atom. Georges Lemaitre whispered this idea first in 1931, imagining all of creation as a cosmic egg, cracking open, spilling forth reality. He saw the mathematics, the way galaxies drift apart, and traced them backward through time, through eons, until they converged, thump, thump, into a singular point of origin. Let your thoughts converge now, narrowing, focusing on the weight of your head on the pillow, the gentle pressure, pulling you down, down. Before that first moment, before the clock of time began ticking, perhaps there was quantum foam, a seething soup of possibility, where the laws of physics as we know them dissolved into something stranger, something we can barely whisper about. Planck time, the smallest possible tick of the cosmic clock, 10 to the negative 43 seconds. That's when our story can truly begin. But before that, silence, unknowable silence. Let that silence fill you now, the quiet between your heartbeats, thump, thump, the pause between breaths, and then expansion. Not an explosion outward into space, but space itself, unfurling, stretching, growing, carrying everything with it. The inflationary epoch, a fraction of a second, when the universe doubled and doubled and doubled again, faster than light, because it wasn't things moving through space, it was space itself, inflating like a balloon, smooth, endless, your chest rising now, like that cosmic inflation, slow, expanding and falling, contracting, in perfect rhythm. This inflation, so brief, solving mysteries we hadn't even asked yet. The horizon problem. Why distant parts of the universe, parts that should never have touched, never have shared information, look so remarkably similar, so uniform, because they were once together, pressed close, sharing temperature, sharing energy, before inflation tore them apart, stretched them beyond each other's cosmic horizons. Now they're strangers, separated by the expanding gulf of space. But they remember being one, just as your body remembering how to relax, how to let go, muscle memory of sleep, ancient, instinctive, and the flatness problem, why our universe is so perfectly balanced, so geometrically flat, not curved into a sphere, not curved into a saddle, but flat, stretched flat by that incredible inflation, like pulling wrinkles from a bed sheet, smooth, even. The curvature density parameter, omega sub k, so close to zero, so precisely balanced, that we float in this flat geometry. You too, floating now in your flat bed, in your flat darkness, weightless, drifting, in those first moments when the universe was smaller than an atom, hotter than imagination. Energy and matter were indistinguishable. A quark gluon plasma, quarks swimming free, not yet bound into protons and neutrons, gluons zipping between them, carrying the strong force, everything fluid, everything connected, temperature beyond billions of degrees, where particles collide and transform, matter becoming energy, energy becoming matter, in an endless dance. Feel the fluidity now in your limbs, no longer solid, but liquid, melting into the mattress, boundaries dissolving. As the universe expanded, it cooled. Thump, thump, like a breath exhaled into winter air, and the quarks began to find each other, binding into triplets, making protons, making neutrons, the strong force pulling them together, holding them tight. This happened when the universe was perhaps a microsecond old, 1/1,000,000th of a second. And already it was growing, changing, and cooling into complexity. Your own cooling now, body temperature dropping slightly as sleep approaches, as metabolism slows. Thump, thump, slower, slower. Big Bang nucleosynthesis, the forging of the first atomic nuclei, in the first 3 minutes, 3 precious minutes, when temperatures were just right, not too hot, not too cold, protons and neutrons fused, making deuterium, making helium, a little lithium, the universe's first chemistry, 3/4 hydrogen, 1/4 helium, by mass, a ratio we still see today, written in the stars, in the gas between galaxies, in the very breath of cosmos. Breathe that ancient ratio now. 3/4 in, 1/4 out. No, just breathe, naturally, easily. No counting, no trying. But there's a puzzle, the lithium problem. We predict more lithium than we observe. Where did it go? This primordial lithium. Did stars destroy it? Did we miscalculate? Or is there something deeper? Some physics we don't yet understand, whispering to us from the first minutes of time. Puzzles are okay. Mysteries are okay. Not knowing is okay. Let the not knowing wash over you. Release the need to understand, to grasp. Just drift. Drift. For 380,000 years, the universe was opaque, a fog of plasma, photons scattering off free electrons, light trapped, unable to travel, like trying to see through a cloud, everything glowing, everything connected, no shadows, no darkness, just endless, just dazzling, fog. But you're in darkness now, blessed darkness, the darkness of rest, of safety, of sleep approaching. Then came decoupling. The moment matter and radiation parted ways. Electrons combined with nuclei, forming the first neutral atoms, mostly hydrogen, and suddenly, photons were free to travel. The universe became transparent, and light, ancient light, began its journey. That light is still traveling, stretched by expansion, cooled from visible fire to microwave whisper, the cosmic microwave background, a baby picture of the universe, showing us how it looked, smooth, nearly uniform, with the tiniest ripples, seeds of everything to come. Those ripples, quantum fluctuations from inflation, stretched to cosmic size, tiny differences in density. Some regions slightly denser, some slightly less. And gravity, patient gravity, and began to amplify them. Dense regions pulling matter inward, thump, thump, like your heart pulling blood, rhythmic, persistent, growing denser, growing stronger, until the first stars forming in the darkness, the cosmic dark ages ending, 300 million years after the beginning, maybe 400 million, clouds of hydrogen, collapsing under their own weight, compressing, heating, until nuclear fusion ignited in their cores, and they shone, the first stars, massive, bright, burning hot and fast. Population 3 stars, made only of primordial hydrogen and helium, no heavier elements yet, no carbon, no oxygen, no iron, just the pure ingredients from the Big Bang, burning, fusing, creating the first heavy elements in their cores. These first stars, they died young, exploding as supernovae, scattering their new elements, carbon, oxygen, nitrogen, into space, enriching the universe, making future stars, making planets, making life possible. You are made of star stuff, Carl Sagan whispered, and he was right. The iron in your blood, the calcium in your bones, forged in stellar cores, billions of years ago. You are ancient, you are cosmic, you are drifting, and as stars formed, they gathered, drawn by dark matter's gentle pull. Dark matter, the invisible scaffolding, 5 times more abundant than ordinary matter. We cannot see it, cannot touch it, but we feel its gravity, bending light, holding galaxies together. It was there from the beginning, perhaps WIMPs, weakly interacting massive particles, perhaps sterile neutrinos, perhaps something stranger, drifting through space, through stars, through planets, through you, right now, invisible, unfelt, but present, always present. Dark matter formed halos, invisible wombs where galaxies could birth. Its gravity pulled normal matter inward, gas falling, swirling, forming disks, forming spirals, forming ellipticals. The first galaxies, small, irregular, chaotic, they merged, combined, grew, building bigger galaxies like the Milky Way, like Andromeda. Beautiful islands of stars, hundreds of billions of stars each, floating in the dark matter sea, and your thoughts like galaxies, distant, separate, slowly merging into the unified darkness of sleep. The cosmic web began to emerge, filaments of galaxies, strung like pearls on dark matter threads, connecting clusters, connecting superclusters, and between them, voids, vast empty spaces where few galaxies dwell. The universe is not uniform, but structured, like a sponge, like foam, like neural networks, patterns repeating at every scale, your own neural network, quieting now, connections dimming, thoughts scattering, dispersing into void. Baryon acoustic oscillations, sound waves in the early plasma, frozen into the distribution of galaxies, a cosmic ruler, showing us how far pressure waves could travel before decoupling, before the fog cleared. We measure this, and it tells us about dark energy, about the composition of cosmos, about how fast space is stretching, carrying galaxies apart, your own oscillations, your breathing, your heartbeat, thump, thump, slowing, deepening, becoming the only rhythm that matters. After the first stars came reionization, their ultraviolet light, so energetic, splitting hydrogen atoms back into protons and electrons, turning neutral gas back into plasma, in bubbles around each star. Bubbles growing, touching, merging, until the entire universe was reionized, transparent in a new way. This happened gradually, over hundreds of millions of years, a slow dawn, washing across creation. And your own dawn is hours away, hours of rest, of darkness, of restoration ahead. Photons, everywhere photons. In the early universe, the photon epoch, radiation dominated over matter. There were billions of photons for every baryon, every proton and neutron. That ratio remains. The universe is full of relic photons, from the CMB, from starlight, from everywhere, washing over us, through us, unnoticed, like sleep washing over you. Inevitable, natural. You don't have to invite it, just allow it. Cosmic neutrinos, even more elusive than photons, created in the first second, when the universe was hot enough for weak interactions to transform particles freely. These neutrinos decoupled early, when the universe was just 1 second old. They've been free streaming ever since, passing through everything. A cosmic neutrino background, colder even than the microwave background. We've never detected it, but it must be there. A whisper beneath a whisper, like the quiet beneath your thoughts, the stillness beneath sensation, always there, waiting. The universe has a thermal history, a story of cooling. In the beginning, all forces were one, unified. As it cooled, forces separated. First gravity, pulling away at the Planck scale. Then the strong force, separating at the grand unification epoch, when the universe was 10 to the negative 35 seconds old, leaving electroweak force, which itself split into electromagnetism and weak force at electroweak symmetry breaking, when the universe was a picosecond old. Each transition a cosmic phase change, like water freezing, suddenly, completely, changing the rules, changing reality. These phase transitions, they may have created topological defects, cosmic strings, domain walls, monopoles, exotic structures, predicted by theory, perhaps scattered through space, perhaps long decayed. We search for them in the polarization of the CMB, in gravitational wave signals, in the distribution of galaxies, searching, always searching for evidence of the universe's violent youth. But you're not searching now, you're releasing, letting go, allowing the search to end. For tonight, matter and antimatter, born equally in the Big Bang, every particle with its antiparticle, but they annihilate on contact, releasing energy. And yet, we exist. We are made of matter. Where did all the antimatter go? Leptogenesis, perhaps, or baryogenesis, processes in the first second that created a tinier symmetry, one extra matter particle for every billion matter-antimatter pairs. And when the rest annihilated, that tiny excess remained, became stars, became planets, became you, 1 in a billion, surviving, persisting, like your consciousness, that tiny flame, flickering, dimming, soon to rest. Friedman equations, derived by Alexander Friedman, describing how the universe expands, relating the expansion rate, the Hubble parameter, to the density of everything, matter, radiation, dark energy, curvature. These equations, they tell us the universe's fate, whether it will expand forever or collapse back. They use the density parameter, omega, comparing actual density to critical density, the threshold between eternal expansion and eventual collapse. Our universe, it seems, is right at critical, flat, balanced on a knife's edge, expanding forever, but ever more slowly. Or perhaps not, because there's dark energy, discovered in 1998, when astronomers measured distant supernovae, standard candles, and found them dimmer than expected, farther than expected. The universe's expansion, accelerating, not slowing as gravity should dictate, but speeding up. Some energy, fills empty space, pushing space apart. We call it the cosmological constant, lambda, Einstein's old friend, the term he called his greatest blunder. But perhaps it was his greatest insight. Empty space has energy, has pressure, negative pressure, pushing outward, dominant now, shaping the universe's future. 3/4 of the universe is dark energy, less than a quarter dark matter. About 5% normal matter, atoms, stars, planets. We are the minority, living in a cosmos we barely understand, shaped by forces we cannot see, like sleeping, entering a realm we don't control, don't fully understand, but trust, must trust, because we've done it 1,000 times and awakened whole. The equation of state, relating pressure to density. For matter, U equals 0, no pressure. For radiation, U equals 1/3. For dark energy, if it's truly a cosmological constant, equals -1, negative pressure, pushing space apart. But perhaps W is different. Perhaps it changes. Early dark energy models, phantom energy, quintessence, fields that evolve, that shift, changing the universe's fate, changing everything. If W is more negative than -1, phantom energy, the universe ends in a big rip, expansion accelerating, faster, faster, until space tears apart. First galaxy clusters, then galaxies, then stars, then planets, then atoms. Everything ripped to shreds in perhaps 20 billion years. But if U is -1 exactly, heat death, the universe expanding, cooling, forever, stars burning out, black holes evaporating, until nothing remains but thin soup of particles, cold, dark, entropic, in 10 to the 100 years, or more. Either way, so far, so impossibly far, that tonight, tomorrow, your lifetime remains precious, remains real. But let's not drift to endings, not yet. There's so much more to whisper about. The Lambda CDM model, our standard model of cosmology. Lambda for dark energy, CDM for cold dark matter. Cold meaning slow moving, not hot, not zipping around at nearly light speed, but sluggish, allowing structure to form. This model, it fits observations beautifully. The CMB, galaxy distributions, supernova distances, all fitting, all consistent, with 6 parameters, just 6 numbers, describing everything. The age of the universe, 13.8 billion years. The Hubble constant, how fast space expands, about 70 kilometers per second per megaparsec, meaning galaxies 1 megaparsec apart drift apart at 70 kilometers per second. Farther galaxies, faster, linearly. Hubble's law, the whisper of expansion, cosmic redshift, light stretched, reddened by the growth of space itself. Your body stretching now, not literally, but sensation stretching, time stretching, each moment becoming elastic, soft, longer than the last. Thump, thump, seconds feeling like minutes, minutes dissolving into the eternal present. You might notice how heavy your eyelids have become, how far away sounds seem, how little you care about staying awake. It's okay. It's more than okay. This is exactly where you should be. The observable universe has a horizon, not because space ends, but because light from farther away hasn't had time to reach us. The universe is 13.8 billion years old, but because space expanded, the horizon is 46 billion light years away, in all directions, making the observable universe 93 billion light years across. Beyond that, more universe, probably infinite universe, forever, but forever invisible, beyond the light horizon, beyond causality, forever unknown. Let the unknown be unknown. Release the need to see beyond, to understand beyond. Just be here, in this small sphere, this bed, this body, this moment. Structure in the universe. It grew from quantum seeds, tiny fluctuations in the inflation field, stretched to cosmic size, giving different regions slightly different densities, and gravity, working on those seeds, pulled matter into the regions that were slightly denser, making them denser still through gravitational instability, the Jeans instability, named after Sir James Jeans. When a region becomes dense enough, its own gravity overcomes pressure, and it collapses, forming stars, forming galaxies, forming clusters. Everything we see, everything, grew from quantum uncertainty, from the universe's inability to decide exactly how to begin, and from that uncertainty, beauty, structure, life emerges. The power spectrum of the CMB, showing us those initial fluctuations, plotting temperature variations against angular scale. It has peaks, acoustic peaks, from sound waves in the plasma, waves that compressed and rarefied the gas. The first peak, at about 1 degree, tells us the universe is flat. The second peak, the third peak, they tell us about dark matter, about baryons, about the composition of everything, written in the sky, in microwave whispers, a cosmic code waiting to be read. And maybe that's what consciousness is, the universe reading itself, noticing itself. And you're the universe, noticing what it feels like to drift towards sleep. The Sachs-Wolf effect, photons climbing out of gravitational wells, losing energy, appearing cooler in the CMB. The integrated Sachs-Wolf effect, photons passing through evolving structures, gaining or losing energy, as dark energy changes the depth of gravitational wells. These effects, they create patterns, cold spots, hot spots in the cosmic background, telling us about dark energy's history, about how structure grew, all of it recorded, all of it preserved in that ancient light from 380,000 years after the beginning, the Sunyaev-Zeldovich effect, where galaxy clusters scatter CMB photons, shifting their frequency. This tells us about the hot gas in clusters, about cluster distances, independent of redshift, a cosmic ruler, another tool for measuring the universe, for weighing dark energy. And all these tools, all these methods, they agree. They tell the same story. The universe emerged from a hot, dense state, expanded, cooled, formed stars, formed galaxies, and now accelerates apart and will continue for eons, for eternity. Perhaps, but not tonight. Tonight you're still centered here. Gravitational lensing, mass-bending light, predicted by Einstein, confirmed in 1919 during a solar eclipse, and now we see it everywhere. Galaxies lensing background galaxies, dark matter halos, lensing distant quasars, even the CMB, weakly lensed by foreground structures. The patterns it creates, they tell us about mass distribution, dark matter distribution, about everything between us and that ancient light, seeing through gravity, seeing the invisible, made visible through its effects, like sleep's approach. You can't see it, but you feel its effect, pulling at consciousness, bending awareness, until primordial gravitational waves, ripples in space-time itself, created during inflation. We search for them in the polarization of the CMB, B modes, the telltale spiral pattern they would create, found, maybe, hints, controversies. The bicep 2 result, excitement, then doubt, dust, galactic dust, mimicking the signal. We're still searching, still listening to the vibrations of creation, gravitational waves. They've been detected from merging black holes, from merging neutron stars, LIGO, Virgo, hearing the universe, but primordial waves from inflation itself, they remain whispers beneath noise, maybe. The stochastic gravitational wave background, a hum pervading space from countless sources, primordial waves, cosmic strings, phase transitions in the early universe, bubble collisions, all contributing just to a background chorus. We listen with pulsar timing arrays, watching pulsars, nature's perfect clocks, looking for coordinated variations in their timing, signs of space-time rippling between us and them. And maybe we've heard it, maybe the data suggests something, a background detected, perhaps in 2023. Scientists still analyzing, still confirming, the universe humming, always humming, like the hum of blood in your ears when everything else is quiet. Thump, thump, the sound of being alive. Axions, hypothetical particles, proposed to solve problems in particle physics, but also possible dark matter candidates, light, ghostly, filling space, oscillating in cosmic magnetic fields, creating tiny signals we might detect. Axion cosmology, exploring how these particles, if they exist, shape the early universe, how they cluster, how they behave, different from WIMPs, different from sterile neutrinos. Another possibility, another whisper of the invisible. The universe offers us mysteries, not to frustrate, but to invite, to welcome us into deeper looking. But tonight, no more looking. Tonight, closing, softening, releasing. 21 centimeter cosmology, using hydrogen's signature wavelength, to map the Dark Ages, the time before first stars, when the universe was neutral, dark, hydrogen everywhere, not yet ionized. This signal, red-shifted now, stretched to meters, to tens of meters, wavelength. We build radio telescopes, arrays of antennas, listening to those ancient whispers, trying to map how the first stars turned on, how bubbles of ionization grew, merged, flooded the universe with light, the cosmic dawn, happening gradually across hundreds of millions of years, like your personal dawn, still hours away, protected by darkness, by rest. Neutrinos, they free stream, meaning once they decouple, they travel unimpeded, not colliding, not interacting, just drifting. This affects structure formation because neutrinos smooth out small-scale density fluctuations. They were moving too fast to collect in small halos. Only later, as the universe expanded, did they slow enough to contribute to gravity's pull. Their mass, tiny but not zero, affects the growth of structure, affects the universe's evolution. We weigh neutrinos by studying galaxies, by studying the CMB, by seeing how structure grows differently when neutrinos have mass versus massless. The universe transitioned from radiation-dominated to matter-dominated. This happened about 50,000 years after the Big Bang. Before that, radiation, photons and neutrinos dominated the energy density, dictated expansion. After that, matter, both dark and ordinary, took control, gravity working differently, pulling structure together more efficiently. This transition, it left marks in the CMB, in how galaxies cluster, telling us when it happened and what the universe contained. Early universe, so many particles created and destroyed in thermal equilibrium. As the universe cooled, particles froze out, their creation rate fell below expansion rate, and their abundance fixed, locked in, relic density. Dark matter froze out, perhaps when the universe was a microsecond old, a nanosecond old, depending on its mass, its interactions, leaving the density we observe today. Neutrinos froze out at 1 second, their abundance predicted, confirmed by Big Bang nucleosynthesis, by the CMB, everything connected, everything consistent, one story, told in many voices. The GZK cutoff for ultra-high energy cosmic rays, protons so energetic, they collide with CMB photons, creating particles, losing energy. This means cosmic rays above a certain energy cannot travel far. They're absorbed by the CMB within about 50 megaparsecs. This cutoff, predicted in 1966 by Griesen, Zatsepin and Kuzmin, it's observed, mostly, though there are hints of particles beyond it, mysteries, always mysteries, inviting us deeper. The dipole anisotropy of the CMB, we see it slightly hotter in one direction, slightly cooler in the opposite direction. This is because we're moving our solar system, our galaxy, moving through space, about 600 kilometers per second, toward the constellation Hydra, toward something called the Great Attractor, a concentration of mass pulling us, pulling our local group, pulling thousands of galaxies, something huge behind the zone of avoidance where the Milky Way's dust blocks our view. We're being pulled, everything's being pulled by local mass concentrations, by peculiar velocities, deviations from pure Hubble flow. The universe is not just expanding, it's flowing, swirling on local scales, like your thoughts, flowing, swirling, slowing into the drift, adiabatic fluctuations in the early universe, where all components, matter, radiation, dark matter, fluctuated together in the same phase. This is what inflation predicts and what we observe. But there could have been isocurvature fluctuations, where different components fluctuated out of phase. These would create different patterns in this CMB in galaxy clustering. We search for them, find none, or almost none, confirming inflation's prediction. The universe, following rules, even in its birth, eternal inflation. The idea that inflation, once it starts, never completely ends. In some regions, it stops, creating pocket universes like ours. But in other regions, it continues, inflating, spawning more pockets, more universes, forever. An infinite multiverse of bubble universes, each with potentially different physics, different constants, different everything. We'd be in one bubble, unable to see, unable to touch the others, separated by eternally inflating space. This is speculation, untestable, maybe, but it emerges naturally from inflation theory, from the mathematics, whispering possibilities, endless possibilities, bubble collisions. If eternal inflation is true, if our universe is one bubble among many, perhaps bubbles collided before our inflation ended. This would leave a mark, a cold or hot spot in the CMB, a breaking of symmetry in one direction. We look, we search. Some claim to see patterns, others disagree. Controversy, as always, at the edges of knowledge. But that's okay. Uncertainty at the frontier is where science lives, is where wonder lives. And you live in certainty, in the certainty of this moment, this darkness, this rest, cosmological redshift, light stretched by expansion, different from Doppler shift, though they look similar. This is space itself, growing, carrying galaxies apart, stretching wavelengths, shifting light toward red, toward infrared, toward radio waves. The farther away, the more redshift. The faster recession, more redshift. Hubble's law connects them linearly for nearby galaxies, but at great distances, the relationship curves, affected by dark energy, by how expansion has changed over cosmic time. We measure distances with standard candles, objects of known luminosity like Typeia supernovae or Cepheid variables, and standard rulers, objects of known size like baryon acoustic oscillation or galaxy clusters. Luminosity distance relates apparent brightness to true brightness. Angular diameter distance relates apparent size to true size. In an expanding universe, these distances just differ. They're not the same as they would be in static space. Another sign, another confirmation that space is dynamic, living, growing. The deceleration parameter, Q sub-zero, tells us if expansion is slowing or speeding, negative Q, acceleration, positive Q, deceleration. For most of cosmic history, Q was positive, gravity winning, slowing expansion. But about 5 billion years ago, dark energy took over. Q went negative. Expansion began accelerating and will accelerate forever. Perhaps the universe entering a dark energy dominated era. Now, right now, in cosmic history, and you're entering a sleep dominated era. Consciousness fading, dreams approaching, perhaps curvature, the shape of space, positive curvature, a closed universe like a sphere, finite but unbounded, negative curvature, an open universe like a saddle, infinite, flat curvature, zero curvature, also infinite, perfectly balanced. The curvature density parameter, omega sub k, measures this. A universe, omega sub k equals 0, within measurement error. Space is flat, stretched flat by inflation. This means if you travelled far enough, in a straight line, you'd never return. Space goes on forever. Parallel lines stay parallel forever. The familiar geometry of Euclid on cosmic scales. The observable universe has structure. The cosmic web, filaments and voids, superclusters, clusters of clusters, like the Virgo supercluster, are a dress, or the much larger Laniakea supercluster, Hawaiian for immeasurable heaven. 100,000 galaxies pulled together by gravity, by dark matter flowing toward the great attractor, and voids, vast empties like the Bhuta's void, 330 million light years across, containing few galaxies. Supervoids, regions where dark energy might dominate even more, creating cold spots in the CMB. Possibly, the cosmic web formed from those tiny quantum fluctuations. Dark matter collected first along filaments into halos, then normal matter falling in, forming galaxies in the densest nodes where filaments meet. This is structure formation, gravitational instability, collapse, cooling, star formation. All from those tiny seeds, amplified by time, by gravity, by the patient accumulation of mass attracting mass, like sleep accumulating, yes, in your body, hour by hour, deepening, deepening, until thought becomes dream, becomes nothing. Void boundaries are sculpted by expansion, by gravity's pull, draining matter from voids into filaments. The universe empties here, fills there, creating the foam-like structure we observe. Galaxies in voids, they're different, often isolated, evolving slowly. Galaxies in clusters, crowded, colliding, merging, transforming. Environment matters in the cosmos as it matters in life. But here, in bed, in darkness, environment is perfect for rest, for restoration. Hidden sector particles in the early universe, particles that barely interact with normal matter, only through gravity or extremely weak forces. Dark matter might be a hidden sector, an entire shadow physics, parallel to ours, undetectable except by gravity. These particles, if they exist, were created in the Big Bang, exist now, passing through us, unnoticed. A universe within the universe, invisible, untouchable, forever separate, except for the gentle tug of gravity, binding everything, binding you to this bed, to this earth, pulling you down, down, heavier, heavier. Pre-inflation quantum states, before inflation began. What was the universe's quantum state? Was it in the ground state, the vacuum, or in an excited state, full of energy, about to inflate? This affects predictions, affects what we should see in the CMB, in gravitational waves. The Hartle-Hawking no-boundary proposal suggests the universe emerged from nothing in a quantum tunneling event, time itself beginning not from a singularity, but from quantum foam, smoothly, naturally. Or perhaps there was something before, another universe, collapsing, bouncing into ours. Ekpyrotic models, cyclic models, where Big Bangs repeat forever, endless cycles of expansion and contraction. String gas cosmology, from string theory, imagines the early universe as a gas of strings, vibrating, wrapping around extra dimensions. As the universe expanded, some dimensions grew large, the three we live in. Others remained tiny, curled up, Planck scale. The strings collided, annihilated, decayed, leaving particles, leaving energy, leaving the hot dense state from which our universe emerged. This is speculation, mathematics, beauty, perhaps, but we don't know. String theory remains unproven, elegant, but silent on experimental tests. The Planck era, the first 10 to the negative 43 seconds, is mystery. Quantum mechanics and gravity both dominate. They must merge into quantum gravity, but we don't have that theory. General relativity breaks down at the singularity, at infinite density. Physics as we know it stops. We need new physics, new mathematics, new ideas to describe that moment, that emergence, that beginning. But we can't test it, can't observe it, can only speculate, calculate, dream like you, drifting beyond the testable, beyond memory, into the quantum foam of dreams, leptogenesis, creating the matter-antimatter asymmetry through lepton interactions, heavy right-handed neutrinos, decaying, preferring leptons over antileptons, slightly. This created a net lepton number, which later, through Sphaleron processes, converted to net baryon number, and thus matter survived, and we exist. One possible pathway among many, explaining why the universe is not 50% matter, 50% antimatter annihilating eternally, but instead is almost entirely matter, with antimatter rare, fleeting, created in collisions, in cosmic rays, but not primordial, not abundant. Cosmic strings, if they exist, are topological defects, lines of trapped energy. From phase transitions, they'd be incredibly thin, Planck scale width, but incredibly dense, stretching across the universe, perhaps forming loops, oscillating, emitting gravitational waves. We search for them in CMB polarization, in pulsar timing, in gravitational wave detectors. No clear detection, yet limits tightening. Perhaps they don't exist. Perhaps they decayed long ago or never formed, but they remain possible, theoretically allowed, waiting in the shadows of maybe domain walls, another type of defect, two-dimensional surfaces where different vacuum states meet, like cosmic strings, but walls, planes. They dominate the universe. If they were stable, overweighting everything, pulling everything into chaos. So either they're not stable, they decayed, they annihilated, or they never formed, or our theories need adjustment. Physics is full of predictions, some realized, some not, and that's okay. That's how we learn what's real and what's just mathematics, dreaming. Primordial black holes formed in the early universe from overdense regions, collapsing directly without becoming stars first. These would be small, maybe asteroid mass, maybe mountain mass, maybe larger. They could constitute some or all of dark matter. We search for them through gravitational lensing, through the gravitational waves they'd emit when they merge. Some candidate events, maybe. Or maybe primordial black holes are rare or don't exist. Another possibility among many. The age of the universe, 13.8 billion years. We calculate this from expansion rate, from the CMB, from the oldest stars, from radioactive dating of meteorites. All methods agree within error. The universe has a birthday, a beginning, and it's aged gracefully, cooling, complexifying, life arising, at least once, on a pale blue dot, orbiting a medium star in an ordinary galaxy. In all that vastness, in all that time, we exist briefly, improbably, miraculously. And tonight, you rest in that miracle, held by gravity, warmed by starlight, stored in ancient atoms from an ancient explosion that continues. The cosmic opacity barrier before recombination. The universe was opaque. We cannot see directly farther back than 380,000 years. The CMB is our horizon in light. But gravitational waves can pass through. Neutrinos can pass through. In principle, we could detect primordial gravitational waves from inflation, primordial neutrinos from the first second, seeing, feeling, back to the very beginning. But we haven't, not yet, our instruments, not yet sensitive enough. But someday, maybe, we'll hear the first moment itself. The anthropic principle observes that the universe must be compatible with our existence. We're here, so conditions allowed for galaxies, stars, planets, chemistry, life. The weak anthropic principle just says, we observe a universe compatible with observers, because, obviously, the strong anthropic principle suggests the universe is fine-tuned for life. The constants of physics, just right, change them slightly, and stars don't form, or atoms don't form, or chemistry is impossible. Is this design? Is this luck? Or is this one universe among infinite others in a multiverse, most unable to create observers, but some, like ours, just right, and we exist in a compatible one because we must. The steady-state theory, proposed by Hoyle, Bondi, and Gould in 1948, suggested the universe is eternal, unchanging on large scales, always expanding, but new matter, continuously created, maintaining constant density, no Big Bang, no beginning, an elegant idea, philosophically appealing, but observations killed it. The CMB, discovered in 1965, showed the universe was hotter, denser in the past. Galaxy evolution showed the universe changes, quasars, abundant long ago, rare today. The steady state could not explain, and faded into history, a beautiful idea disproven. This is science, testing, learning, correcting. Horizons in cosmology mark limits. The particle horizon, how far light could have travelled since the Big Bang, defines the observable universe. The event horizon, more subtle, marks the farthest events we will ever see, even if we wait forever, even as light reaches us from farther and farther. There's a limit. Events beyond will never affect us, because space expands faster than light, separating us eternally in a dark energy-dominated universe. This horizon is finite. There are galaxies we see now whose future we'll never see. Already, they're slipping beyond the horizon, dimming, redshifting, fading into cosmic isolation. But that's okay. We have each other here, now, on this pale blue dot, sharing this moment. Magnetic fields in the early universe might have been seeded by phase transitions, by turbulence in the plasma, by battery mechanisms creating tiny seed fields. These grew through dynamos, in galaxies, in clusters, amplifying, organizing. We observe magnetic fields everywhere, in galaxies, in galaxy clusters, even in intergalactic space, possibly primordial magnetism, or generated later. We're still learning, still measuring, still wondering. The universe surprises, always. Plasma turbulence in the early universe, from inflation, from phase transitions, would create chaotic flows, eddies, vortices in the hot plasma, energy cascading from large scales to small, dissipating, heating. This turbulence might affect structure formation, might seed magnetic fields, might create non-Gaussian features. In the CMB, we find mostly Gaussian, mostly smooth, but hints, tiny hints of something more, something complex, hiding in the data. Cosmic shear, gravitational lensing of distant galaxies by foreground matter distorts their shapes slightly. We measure these distortions, map dark matter statistically. Weak lensing because it's subtle, statistical, not obvious, like strong lensing, where galaxies are clearly multiply imaged, Einstein rings, but weak lensing tells us about all mass between us and distant galaxies, dark and luminous, a cosmic tomography, slicing the universe, mapping how structure grew, how dark energy influenced that growth. Vacuum energy fluctuations, even empty space, is not empty. Quantum fields fluctuate, creating and destroying virtual particles. This gives vacuum energy, the cosmological constant. Perhaps, but we calculate vacuum energy from quantum field theory and get a number vastly larger, 10 to the 120 times larger than observed dark energy. The worst prediction in physics. The cosmological constant problem. Why is vacuum energy so small, so precisely balanced against gravity that the universe can form structure, can exist at all? We don't know. It's a crisis or a clue, pointing to new physics beyond the standard model, beyond general relativity, beyond what we understand. Protogalactic clouds collapsing in dark matter halos, cooling, fragmenting. The first generation of galaxy formation, chaotic, violent, small galaxies merging hierarchically, building bigger ones, feedback from supernovae, from black holes, regulating, pushing gas out, stopping star formation temporarily, then gas falling back, stars forming again, cycles of activity and quiescence. This is how galaxies grew, how they evolved from small to large, from irregular to spiral and elliptical, over billions of years. Patient processes working, the subtle drift of fundamental constants. Are the constants truly constant, or do they change over cosmic time? We measure carefully, looking at distant quasars, at spectral lines from billions of years ago, comparing to laboratory value today. Most measurements show no change, but some hint at tiny drifts in the fine structure constant, controversial, debated. If real, it would revolutionize physics, constants, evolving with the universe, but probably they're constant as far as we can tell, and deeper still into the mathematics, into the formalism that describes all of this. The scale factor, A of t, a simple function describing how space grows at the Big Bang that equals 0 today by convention. A equals 1 in the future, a grows forever. Perhaps This single function as contains the universe's expansion history. Its derivative tells us expansion rate. Its second derivative tells us acceleration. Everything encoded in this curve, this growth, this patient unfolding, like you're breathing, expanding, contracting, following its own scale factor, rising, falling, naturally. Cosmic time, the time we experience, tick, tock, forward, always forward, but there's another time, conformal time, a mathematical construct where light rays become straight lines, easier to calculate. It's related to cosmic time by the scale factor, stretching and compressing, making geometry simpler, making calculations tractable. Both times, both coordinates, describing the same universe, the same events, just different perspectives, like how you can measure your day in hours or heartbeats. Thump, thump, same day, different counting. Comoving coordinates, they expand with space, a galaxy, sitting still in comoving coordinates, even as it recedes from us in physical coordinates. This separation helps us distinguish motion through space from motion of space. Comoving distance stays constant for objects moving with Hubble flow. Physical distance grows with the scale factor. Multiply them and you convert one to the other. Simple, elegant, like your body, comoving with Earth. As Earth moves through space, you feel still, but you're traveling thousands of kilometers per second through the cosmos, orbiting, rotating, drifting, unnoticed. The particle horizon marks how far light could have traveled since the Big Bang reaching us. It defines the observable universe, what we can see, what can affect us. But there's another horizon, the future horizon, marking events we will ever see, even waiting forever, in a universe with dark energy, accelerating. These differ. The future horizon is smaller, finite. Some events happening now, beyond it, will never reach us. They're light, fighting against expansion, losing, fading, disappearing, beyond reach, forever. Let them go. What's beyond is beyond. Rest here, in what's knowable, in what's present. The Hubble horizon is different still. It's the distance, where recession velocity equals light speed. Objects beyond it recede faster than light, but we can still see them if their light was emitted when they were closer. The Hubble horizon marks causal structure in a different way. Regions within it can exchange information. Currently, regions beyond cannot. Currently. But this changes as the universe evolves. Horizons shift, grow, or shrink, depending on acceleration. Nothing stays the same. Everything flows, changes, like consciousness, flowing now towards sleep, beyond the horizon of waking awareness. During inflation, space expanded faster than light, exponentially. Super Hubble modes were created, quantum fluctuations stretched beyond. The Hubble horizon frozen, unable to oscillate. These became the seeds of cosmic structure. As inflation ended and expansion slowed, these modes re-entered the horizon, becoming density fluctuations, sound waves, galaxies. Eventually, everything we see came from super Hubble modes, from quantum whispers, stretched to cosmic scales, then falling back into causality. Patience, cosmic patience, creating everything. Curvature perturbations, described by zeta, z, the gauge invariant measure of density fluctuations on super Hubble scales. This formalism, elegant, powerful, tells us how fluctuations evolved from inflation through radiation era to matter era, conserved on large scales, growing on small scales. Zeta, nearly scale invariant, meaning similar amplitude at all scales. Almost. This is inflation's prediction, confirmed by observations. The tilt, the spectral index, slightly less than 1, tells us inflation was not exactly exponential, but close, so close. The tensor to scalar ratio, R, compares gravitational waves to density fluctuations from inflation. Large R means strong gravitational waves detectable in B-mode polarization. Smaller R means weak waves, harder to find. Current limits are less than 0.036 at certain scales. Still room for detection, still hope. Experiments running, searching, listening for those primordial ripples in space-time itself. Each measurement tightening limits, narrowing possibilities, approaching truth, or approaching the realization that R is too small to ever detect. Another mystery, quiet, subtle, hiding. Not Gaussianity, measuring deviations from perfect randomness in primordial fluctuations, FNL, GNL, parameters, quantifying how much 3-point, 4-point correlations exceed what random Gaussian fields would give. Simple inflation models predict nearly Gaussian, FNL near zero, but alternatives, multi-field inflation, non-standard scenarios could produce large non-Gaussianity, detectable in the CMB in galaxy clustering. We measure, find FNL, consistent with zero, within errors, but still, we search for any deviation, any signal of something more complex in the beginning, just as you search softly for sleep signal in the noise of waking thoughts, waiting, quieting, releasing. Isocurvature perturbations, where different components fluctuate differently, out of phase, unlike adiabatic modes, where everything fluctuates together. These would create different patterns in the CMB at small scales. We constrain them, find mostly adiabatic, but allow some mixture, perhaps 10% or less. Another confirmation of simple inflation, which predict purely adiabatic. Simplicity emerging from observations, the universe, following the simplest path, perhaps, or perhaps hiding complexity, beneath measurement precision, waiting for better instruments, better eyes, cosmic variance, the unavoidable uncertainty. We have only one universe, one sky, one CMB to observe. At large scales, few independent samples, few modes to average over. So uncertainty, irreducible, no matter how perfect our instruments. We cannot measure the quadrupole better than cosmic variance. We're limited or fundamentalists by having one realization of quantum randomness. This is frustrating but beautiful, a reminder that we're inside the system, part of it, not external observers. We see one history among infinite possible histories in the quantum multiverse of inflation. Perhaps this one, ours, real, unique, precious. Silk damping, named after Joseph Silk, describes how fluctuations on small scales were erased before recombination. Photons diffusing through the plasma, smoothing out density peaks on scales smaller than about 1 arc-minute today. This creates an exponential cutoff in the CMB power spectrum at high multipoles. We observe this clearly, confirming the physics of photon-baryon interactions in the early universe, damping, smoothing, erasing, like memory, fading, details blurring as sleep approaches. Only the large structures remain. The broad strokes, the feeling, not the specifics. The baryon to photon ratio, eta, about 6 times 10 to the negative 10th. 1 baryon for every billion.7 photons, roughly. This tiny number, set to during Big Bang nucleosynthesis, determines how much helium, lithium, deuterium were created. We measure eta from the CMB, from deuterium abundance, from helium. All agree, beautiful consistency. This ratio has remained constant as the universe expanded, both baryons and photons diluting, but their ratio preserved, a fossil from the first minutes, still visible, still meaningful today. Recombination was not instantaneous. It happened gradually, over thousands of years, centered at redshift 1090 hydrogen atoms, forming ionization fraction dropping from nearly 1 to nearly 0. The last scattering surface is not a sharp surface, but a shell with thickness. The visibility function describes this, peaking at recombination, falling off before and after. Most CMB photons, we observe, last scattered within a narrow range of redshift. Creating that surface, we see the cosmic background 13.8 billion years ago and 400,000 light-years thick, roughly a window into one moment of cosmic history, preserved, glowing, eternal. The diffuse supernova neutrino background. Neutrinos from all supernova throughout history should fill space, like the CMB, but from stellar explosions, not the Big Bang. We haven't detected it yet, but it should be there. A few hundred per cubic centimeter, low energy, invisible, passing through us, constantly, every supernova, sending neutrinos outward for billions of years, accumulating, layering, building this background, waiting for our detectors to become sensitive enough to see it, to confirm it. Another fossil of cosmic history hidden in plain sight. Gravitational wave memory, a permanent displacement of space-time. After a gravitational wave passes, the wave compresses and stretches space, but when it's gone, space doesn't quite return to exactly the same state. A memory remains. This might apply to inflation's gravitational waves, perhaps leaving subtle imprints beyond the oscillating signal, permanent changes to geometry, another signature to search for, another way inflation might whisper to us through the ages. The Transplanckian problem troubles some theorists. During inflation, quantum fluctuations started subplanckian, smaller than Planck length, where quantum gravity should dominate. But we use quantum field theory in classical space-time, ignoring quantum gravity. Is this valid? Do we need new physics at Planck scale to properly describe inflation's origin? Maybe, maybe not. Depends on how inflation started, how fast it rolled. Most models avoid the problem, but not all. Another uncertainty at the foundation, whispering that our understanding might be incomplete, might need deeper truth. Initial conditions for inflation. What state was the universe in before inflation began? Why was there a patch of space with inflaton field in the right place to inflate? This is the initial conditions problem. Some say inflation is tuned, requiring special setup. Others say generic, likely happening spontaneously in quantum foam. Eternal inflation solves this, perhaps by making inflation inevitable, somewhere, always. But then we need a multiverse, trading one problem for another. Questions cascading endlessly, like thoughts before sleep, each answer spawning more questions until you stop asking and just drift. Fine-tuning of inflation's parameters. The slow roll parameters must be small. The potential war must be flat. The field value must be large. Some say this requires fine-tuning, unnatural, unlikely. Others say anthropic reasoning explains it. We observe a universe where inflation worked because we couldn't exist in universes where it didn't. Selection effect, perhaps in the multiverse. Most regions don't inflate properly, but we necessarily find ourselves in one that did, because here we are, existing, observing, questioning, and you here now, existing, breathing, letting go of questions. Warm inflation, an alternative scenario where inflation interacts with other fields, creating radiation during inflation, not cold, not empty, but warm, filled with particles. This changes predictions, changes how fluctuations are generated Thermal fluctuations, not quantum. Less tensor modes, different spectral index, a different story. Equally valid? Perhaps. We don't know yet which story is true. Both fit current data roughly. We need better measurements, better precision to distinguish, to choose. Or maybe we'll never know. Maybe both are possible in different regions of multiverse. Maybe our questions don't always have answers. Quintessence, a dynamical dark energy, not a constant, but a field, rolling, evolving, its energy density changing slowly with time, tracking models where quintessence follows matter density closely until recently, when it became dominant. These models try to solve the coincidence problem. Why is dark energy comparable to matter right now in cosmic history? Tracking provides an answer, a mechanism, making this natural instead of fine-tuned. The field just tracks, then takes over, smooth, inevitable, like sleep, tracking wakefulness, then taking over when the time is right. Modified gravity theories, alternative explanations for cosmic acceleration, maybe not dark energy, but gravity itself, behaving differently on cosmic scales. FR theories, adding curvature terms, Horndeski theories, most general. Scalar tensor theories, they change how geometry responds to matter, perhaps avoiding the need for mysterious vacuum energy. But they face challenges, solar system tests, gravitational wave speeds, highly constrained now. After GW1 is 70817, gravitational waves and light arriving together from neutron star merger. Many modified gravity models ruled out, but not all. Some survive, remaining possible. Alternatives whispering that maybe, just maybe, gravity is stranger than Einstein thought. Screening mechanisms allow modified gravity locally while hiding effects in solar system. Chameleon fields change mass depending on environment. Heavy in dense regions, light in voids. Symmetron fields similar, breaking symmetry in low density. Screening, hiding, deceiving our local tests while affecting the cosmology. This is clever, perhaps too clever. Nature might work this way or might not. We test, we search for fifth forces, for violations, finding none so far. But absence of evidence is not evidence of absence. The universe might still surprise us. Back reaction, the idea that small-scale structure, inhomogeneity, might affect large-scale expansion differently than smooth models assume. Averaging Einstein's equations is not straightforward. Averaging matter, then solving, differs from solving exactly, then averaging. The averaging problem rare in cosmology. Could this explain acceleration without dark energy? Back reaction, driving expansion. Timescape cosmology suggests yes. Matter in voids expands faster. Matter in clusters slower. Average observer sees apparent acceleration, but most cosmologists doubt this. Calculations suggest effect too small, but debate continues, as it should. Questions living at the edge. Swiss cheese models where we cut holes, representing voids in a smooth universe, filling them with exact vacuum solutions, matching at boundaries. This lets us study inhomogeneity exactly in general relativity. Do voids really expand faster? Do they contribute to apparent acceleration? Results, mixed, subtle, depend on assumptions. The universe, not perfectly smooth, but structure's effect on expansion remains controversial, uncertain, like trying to decide whether you're asleep or awake right now. The boundary blurs definitions, matter, and sometimes fail us. Void models for acceleration place us inside a giant void under dense region. Matter outside pulls outward, creating apparent acceleration. Copernican principle violated. We're special, located centrally in a void, hundreds of megaparsecs across. This could explain supernova observations without dark energy. But problems arise. CMB observations, kinetic Sunyaev-Zeldovich, large-scale structure, all constrain void models. Most are ruled out or require fine-tuning, as bad as what they replace. Still, some models survive, barely whispering, what if? Bouncing cosmologies avoid the singularity by having the universe contract, then bounce into expansion. Matter bounce, where matter dominates the bounce. Ekpyrotic bounce from brane collisions in string theory. These replace Big Bang singularity with a smooth bounce, a minimum, not a beginning. Challenges exist, instabilities, entropy problems, but some models work technically. Loop quantum cosmology uses quantum geometry to create a repulsive force at high density, preventing collapse to zero. The universe bounces naturally. Quantum gravity, replacing singularity with bridge to prior contraction phase. Big crunch, the opposite of Big Bang. That's what would happen if dark energy were absent and universe closed. Expansion, slowing, stopping, reversing, galaxies falling together, temperatures rising, matter evaporating, finally crushing into singularity, opposite of how it began. Oscillatory universes, cycle, Big Bang, expansion, turnaround, big crunch, bounce, Big Bang again, forever. But entropy issues arise. Each cycle, higher entropy than last. Where's the infinite past? Where did the cycles begin? Probably, yes, our universe doesn't recollapse. Dark energy prevents it. Expansion, eternal. But the idea, beautiful, symmetric, appealing, even if untrue. Phantom energy, if less than -1. Dark energy density increasing with time, not constant, growing stronger, pulling harder, eventually tearing apart bound structures, galaxies, solar system, Earth, atoms, in finite time, perhaps 20 billion years. Big rip, everything shredded, not just heat death, but violent death, sudden, catastrophic, but current data favors W equals -1, cosmological constant, not phantom, so probably we're safe from this fate, probably sleep peacefully, knowing the universe likely ends slowly, gently, coldly, far, far away. Sudden singularities, other exotic possibilities, expansion rate, finite, but derivatives, diverging, in finite time, pressure, density, becoming infinite, scale factor, still smooth, but physics, breaking down. These are curiosities, mathematical possibilities, probably not physical, but they remind us our understanding has limits, has gaps, singularities, pointing to where theories fail, where new physics must enter. Always. Mysteries remain. Always. Boltzmann equations in cosmology describe how particle distributions evolve as universe expands, collisions, decouplings, freeze-outs. For each species, an equation coupling to others through interactions. These determine when neutrinos decouple, when dark matter freezes out, when nuclear synthesis happens. Solving them numerically gives predictions, matching observations beautifully, the universe as a reactor, particles transforming, densities evolving, everything computable if we know the physics, if we know the interactions. Neutrino mass hierarchy affects cosmology slightly. Normal hierarchy, lightest neutrino, very light. Inverted hierarchy, two heavier states, lightest, middling. This affects how neutrinos cluster, how they suppress, structure formation, at what scale. Free streaming length depends on mass, so hierarchy leaves signature in galaxy surveys, in CMB lensing, measurements, tightening, hints emerging. Normal hierarchy favored, perhaps, but not certain yet. Neutrinos keeping secrets, even as they flood through us every second. Trillions, invisible, untouchable. Sterile neutrinos, hypothetical, interact even weaker than normal neutrinos. Only through gravity, maybe. Dark matter candidates, perhaps they could mix with active neutrinos, oscillate, creating radiative decays, X-ray signals from galaxies, from clusters. Some claim detections at 3.5 kilo electron volt. Others dispute, controversy, as always, and sterile neutrinos might help with baryogenesis, leptogenesis, creating asymmetry through oscillations, mini baryogenesis in early universe, speculative but possible, elegant. Another piece of the puzzle waiting to be confirmed or discarded. Phase space distributions how particles are distributed in position and momentum. Fermi-Dirac for fermions, electrons, neutrinos, obeying exclusion principle. Bose-Einstein for bosons, photons, following different statistics. As universe expands, these distributions redshift, cool, preserving their form, relic distributions from thermal equilibrium, frozen in, chemical potential fixed, temperature dropping with scale factor, everything evolving predictably, following statistical mechanics, married to general relativity, beautiful synthesis of physics on cosmic canvas. Dark radiation, any relativistic component beyond known particles, parameterized by delta NF, effective number of neutrino species. Standard model predicts 3, with small corrections, but observations could reveal more. Extra neutrinos, sterile or otherwise, axions, other light particles, dark photons, any would contribute to radiation density, affecting expansion at early times, changing predictions for nucleosynthesis, for CMB, current measurements, NRF equals 2.99 plus or minus 0.17, consistent with standard 3, but room remains for surprises, for something extra, hiding in the radiation bath of the early universe, waiting to be found. All these details, these parameters, these models, they're beautiful, intricate, mathematical poetry describing creation. But you don't need them, not tonight. They're like counting stars when you should be sleeping beneath them. The universe understands itself through mathematics, through consciousness, through you. But now, let consciousness rest. Let understanding dissolve into feeling, into sensation, into the simple peace of breathing, existing, being held by gravity, by darkness, by the gentle expansion of the cosmos, carrying you, carrying everything, softly, endlessly, into the night. Primordial density peaks, the highest density regions in the early universe, evolved first, collapsing into the first stars, first galaxies. These are biased traces, clustering more strongly than the average. Regions that were 10% overdense at recombination became galaxies, halos, clusters, while regions that were 10% underdense became voids, empty, evacuated. This bias, this clustering, we measure in galaxy surveys, tracing back to those initial conditions set by quantum fluctuations in inflation. Everything connected to everything across time, across space. E-mode and B-mode polarization in the CMB, light from recombination became polarized as it scattered off electrons. E-modes, created by density fluctuations, scalar perturbations, we observe these clearly. B-modes, created by gravitational waves, tensor perturbations from inflation. Possibly, these would be the smoking gun, proof of inflation, but also B modes from gravitational lensing of E modes by foreground matter. We've detected those, but primordial B modes remain elusive, hidden beneath noise, beneath foregrounds. We keep looking, building better telescopes, waiting, listening for that whisper from the beginning. Cosmic filaments. The birth of happened gradually. Dark matter collapsing first along lines of convergence where density was higher, in sheets, in filaments, normal matter falling in later, after recombination, when it could move freely, shock heating as gas fell into filaments, into clusters, heating to millions of degrees, glowing in X-rays. This is the warm-hot intergalactic medium, most of the normal matter in the universe today, not in stars, not in galaxies, but in filaments between them, invisible, unnoticed, but there, always there. Protoclusters formed early, densest peaks in the initial fluctuations. They grew by merging smaller halos, galaxies, falling in. Today, clusters contain hundreds or thousands of galaxies bound by gravity, by dark matter. The intracluster medium, hot gas, X-ray bright, shows where normal matter collected. Clusters are the largest gravitationally bound objects in the universe. Superclusters, even larger, but not bound. Still expanding, still separating with the Hubble flow. Recombination shadows in the universe's first light, where slightly denser regions recombined earlier, slightly less dense regions later. This creates tiny variations in the CMB, the temperature fluctuations we observe, acoustic oscillations frozen at decoupling, telling us about the initial conditions, about the physics of that time. Each shadow, each hot spot, each cold spot, a window into the infant universe. 13.8 billion years ago, and yet we see it tonight, still arriving from all directions, surrounding us in microwave whispers. The universe's baby picture, always visible, always there, if you know how to look. But you're not looking, not thinking, just drifting. The universe's causality is limited by light speed. Events separated by more than light could travel are causally disconnected, cannot influence each other. This creates problems in the standard Big Bang. How did distant regions come to the same temperature if they were never in contact? Inflation solves this by expanding a small causally connected region to cosmic size. Everything was connected, briefly, then separated by inflation. But without inflation, causality breaks. The horizon problem returns. So inflation, or something like it, seems necessary. The critical density, Aero sub c, is the density at which the universe is flat, neither positively curved nor negatively curved. It depends on the Hubble constant, about 10 to the negative 29 grams per cubic centimetre, incredibly sparse, about 5 hydrogen atoms per cubic metre. That's average throughout all space, and our universe is almost exactly at critical density, within a percent or so. This is the flatness problem. Why so precisely balanced? Inflation explains this by stretching the curvature to zero to flatness, natural outcome of exponential expansion. Density parameters, omega values, tell us what the universe contains. Omega sub m for matter, about 30%. Omega sub lambda for dark energy, about 70%. Omega sub r for radiation, tiny today, less than 1%, but dominant in the early universe. These add up to 1, within error, confirming the universe is flat. Each component evolves differently. Radiation dilutes as 1 over a to the 4th, matter as 1 over a cubed. Dark energy stays constant, so their relative importance changes with time, creating eras: radiation era, matter era, dark energy era, now. Each era, different physics, dominating, shaping, evolution. Photon epoch in the early universe, when photons had more energy density than matter. This lasted until about 50,000 years. During this time, expansion was different. Radiation dominated, expanding faster than matter authority would allow. Photons, massless, always moving, light speed, their energy, redshifts as the universe expands, cooling, their temperature dropping as space grows. Today, CMB photons are cool, 2.7 Kelvin, but they were hot, thousands of Kelvin at recombination, millions, billions. In the first moments, everything cooling, slowing, settling. Matter-dominated era began when matter's energy density exceeded radiation's. This is when structure could grow efficiently, radiation's pressure no longer opposing gravitational collapse. Dark matter halos forming normal matter, falling in galaxies, beginning to shine. This era lasted from 50,000 years until about 5 billion years ago. Most of cosmic history spent here, most of structure formation happening here. During this time, your lineage was forged in stars, in collisions, in the patient chemistry of planets, forming life, arising, evolving, until you, here, now, breathing, softly, barely aware. The universe will expand forever. Probably dark energy, repulsive, overcoming, gravity, accelerating, everything apart. In the far future, our local group, Milky Way, Andromeda, will merge, forming one giant elliptical, but beyond, other galaxies, receding, accelerating away. Eventually they'll cross the event horizon, disappear forever. And beings in that far future, trillions of years from now, will look up, see no galaxies except their own, isolated, alone, in a dark, empty universe, not knowing. There was a time when the sky was full of light, of galaxies, of stories, unless they read our messages, our light, still travelling through space, carrying memories of a younger, brighter cosmos. But that's far away, so far. Let it go. Tonight, the universe is here, around you, galaxies shining, stars burning, planets turning, life thriving on at least one. Warm, wet rock. Everything connected by gravity, by light, by history, by the same primordial atoms forged in the Big Bang. You are the universe experiencing itself briefly, locally, and right now, the experience is letting go, releasing, sinking into the soft embrace of sleep. The great attractor pulling our local group, pulling Virgo, pulling thousands of galaxies near toward it in the constellation Centaurus, behind the galactic plane, hidden by dust but felt through its gravity, mass equivalent to tens of thousands of Milky Ways pulling. Everything flows toward higher density, peculiar velocities, deviating from pure expansion, showing the local gravitational landscape is bumpy, textured, real. Not smooth abstraction, but structured, dynamic, alive in a way, and you flowing now towards sleep, pulled by biological gravity, by circadian rhythms, by tiredness, by the weight of the day, releasing, heat death, one possible fate, the universe expanding forever, stars burning out, last red dwarfs dying in 100 trillion years, black holes evaporating through Hawking radiation in 10 to the 100 years. Finally, only photons, electrons, positrons, neutrinos, drifting apart, growing colder, approaching absolute zero, maximum entropy, no gradients, no structure, no complexity, possible, heat death, a long, slow, quiet ending, but also so far away, so incomprehensibly distant that it might as well be never. For now, warmth, life, light, persist, and you, warm, alive, here, or the big rip, if dark energy grows stronger, phantom energy less than -1, then acceleration increases unbounded in perhaps 20 billion years, galaxies torn apart, then stars, then planets, then atoms, then space-time itself, ripped to shreds, everything destroyed in a final cataclysmic crescendo. But this seems unlikely. Current data suggests equals -1 cosmological constant, which leads to heat death, not big rip. So probably the ending is gentle, slow, cold, fading, like falling asleep. Gentle, slow, warm, but fading toward unconsciousness. Or another possibility, cyclic models, where the universe bounces, contracts, compresses, but doesn't reach a singularity. Quantum effects, stop collapse, create a bounce, expanding again, new Big Bang. This could repeat eternally, infinite past, infinite future. Each cycle, perhaps similar, perhaps different. We'd be in one cycle among infinite others, unable to see beyond our bounce, beyond our beginning, the past, hidden by the bounce, by the thermal chaos of compression. This is speculation, string theory inspired, elegant, perhaps, but untested, waiting. The universe could have extra dimensions. String theory requires them, 10 or 11 dimension, but we see only 3 spatial dimensions. Where are the others? Compactified, curled up, Planck scale, tiny. We move through them without noticing, like an ant on a rope, seeing forward and back, but not around. The ropes circle, the other dimensions there, but small, invisible, except perhaps in particle collisions at high energy or in gravitational effects at small scales. We search, find nothing yet, but maybe they're there, hidden like so much in the cosmos. The cosmological constant, lambda, Einstein added it in 1917 to make the universe static, but then Hubble discovered expansion, and Einstein supposedly called lambda his greatest blunder. But now lambda is back, representing dark energy, vacuum energy, something making space accelerate apart. Einstein was right to include it. The equations allow it. Nature seems to use it. Lambda is real, or something like it. The universe expanding, accelerating, because of nothing, because of empty space, having energy, having pressure, negative pressure, pushing everything apart forever. Hubble's law, velocity equals Hubble constant times distance. The farther away, the faster. Recession, linear, approximately for nearby galaxies. But at greater distances, the relation curves due to expansion history, dark energy, deceleration then acceleration, Hubble's law modified, cosmological redshift, distance measures becoming complicated, general relativity needed, Friedman equations, solving for expansion, but locally, simply, velocity proportional to distance, everything moving apart, everything receding from everything else. No center, no edge, just expansion everywhere, always. The observable universe contains perhaps 2 trillion galaxies, each with billions or hundreds of billions of stars, each star perhaps with planets, some planets perhaps with life. The numbers incomprehensible, the possibilities endless, and yet we feel alone. We've detected no signals, no visits, no evidence of other intelligence. Maybe we're first, maybe we're alone, maybe they're out there, quiet, hidden, extinct, or maybe the universe is full of life, of intelligence, and we're just not listening right way. Or maybe life is common, Intelligence is common, but communication across light years, across millennia, is just too hard, too unlikely. And so we drift, each species, each civilization, alone in the dark, wondering, like you wondering, now, what comes next? What dreams? What rest? The Jeans instability, named after Sir James Jeans, describes when a gas cloud collapses under its own gravity. If the cloud is larger than the Jeans' length and cooler than the Jeans' temperature, gravity wins over pressure and collapse begins. This is how stars form, how galaxies form, how structure emerges from smooth gas, instability, amplification, runaway growth, until something stops it. Fusion in stars, turbulence in galaxies, feedback, equilibrium, the universe balanced between collapse and dispersion, between structure and chaos. Acoustic peaks in the CMB power spectrum show oscillations in the primordial plasma, sound waves, compressions and rarefactions frozen at decoupling. The first peak, largest, corresponds to 1 degree angular scale, modes that were maximally compressed at recombination. The second peak, third peak, higher harmonics, telling us about baryon density, dark matter density, photon baryon ratio, all encoded in the heights of these peaks. Precision cosmology, measuring parameters to percent level or better. The universe's first billion years was chaotic, transformative. First stars forming, dying, enriching, gas. First galaxies assembling, merging, growing, quasars igniting, supermassive black holes, feeding, shining, the cosmic dawn, rionization, happening gradually, light spreading, ionizing, everything, the dark ages ending, transparency, returning in a new way. And all of this we glimpse by looking far, therefore back in time, at high redshift galaxies, at distant quasars, at the subtle shadows, in the CMB, seeing just the universe's childhood, its adolescence, captured in ancient light. And now the universe is middle-aged, perhaps 13.8 billion years old, stars still forming, but slower than the peak 10 billion years ago, galaxies mostly assembled, mostly mature, some still merging, like Andromeda, approaching us to merge in a few billion years, but mostly things are settling, calming, the universe entering a long, slow decline. Star formation will cease, eventually, in trillions of years, and then just aging, just fading, just cooling, like your day, starting bright, peaking, active, and now settling, calming, entering the long night of rest. Cosmology is the study of everything, the universe's origin, evolution, fate, structure, contents, laws governing it, constants defining it. It's ambitious, impossible, beautiful. We've learned so much in 100 years, from Einstein's equations to Hubble's observations to the CMB to dark energy, each generation discovering refining, surprising us, and yet mysteries remain. Dark matter's nature, dark energy's origin, the Big Bang's trigger, quantum gravity's form. We know so much and so little simultaneously. But you don't need to know, don't need to understand. Just drift on this river of information, of wonder. Let it carry you deeper into rest. The universe will still be here tomorrow, still expanding, still mysterious, still beautiful, and you'll be here, rested, restored, ready to wonder again. Feel your body now completely still, or almost still, breath barely moving, heartbeat, thump, thump, so slow, so quiet, thoughts scattered, distant like galaxies, receding beyond the horizon, the darkness, complete, comfortable, safe. This is where you belong right now, in this moment, this bed, this silence. Nothing to do, nowhere to go, no problems to solve, just being, just breathing, just here. The CMB, still glowing, all around you, though you can't see it. Photons from recombination passing through, carrying information from the infant universe, the neutrino background, even older, from 1 second, passing through, unfelt, unnoticed. Gravitational waves, maybe from inflation, rippling space-time. Beneath detection, you swim in a sea of ancient radiation, ancient information connected to the beginning, to everything, and dark matter, 5 times more abundant, passing through you, right now, this moment, through your body, through Earth, barely interacting, just drifting, dark energy, in the space, between your atoms, pushing, gently, expanding space, even here, locally, though bound systems resist. You are a cosmos unto yourself, atoms from stars, space between them, forces binding, consciousness emerging, somehow, mysteriously. You are the universe, aware, and the universe is tired with you, ready to rest, to dream, to let go for a while. The great cosmic cycles continue, stars burning, galaxies turning, space expanding, but for now, for you. Time to pause, time to float, time to release into sleep's gentle embrace. Let's return to the beginning, to that first moment when space and time were born. The singularity, the potential, the quantum foam, and then expansion, inflation, cooling, particles forming, forces separating, matter condensing, stars igniting, galaxies gathering, and here, now, 13.8 billion years later, you, lying here, breathing softly, connected to all of it, made of it, part of it, the universe, experiencing as itself 100 mysteries, whispered, woven through this night, each one a doorway to wonder, to questions, to the beautiful unknowing that drives us, to look up, to ask why, to seek understanding. But tonight, no more seeking. Tonight, acceptance. Tonight, rest. And if you're still here, still listening, That's okay. The loop continues, the mysteries cycle, soft and endless. But maybe now, maybe your eyes are closed, you're breathing deep, your mind somewhere else, somewhere soft, somewhere safe, between waking and sleeping, between knowing and dreaming, and that's perfect. That's exactly up where you should be. The universe keeps turning from the infinitesimal flash of the Big Bang to the grand structures we now inhabit, and will keep drifting, floating together through the mysteries. 100 Big Bang mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the first second of creation and the whispers of a universe before, the echo of cosmic background radiation as a lullaby from the early cosmos, and the gentle expansion of space-time and the question of what lies beyond the horizon. There's nothing you need to do now. Just let your body sink heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. And we'll keep drifting, floating together through the mysteries. 100 soothing black hole mysteries, looping softly, endlessly through the night. Tonight we'll drift through the edge of event horizons, where time bends and stops, the whisper of hawking radiation and the quiet pull of singularities, ancient collapses, gentle impossibilities. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into the darkness where black holes wait. Black holes aren't really holes at all. They're places where gravity grew so strong that space itself collapsed inward, folded, compressed, until nothing, not even light, could escape. Imagine a star, massive, ancient, burning for millions of years, and then, one day, it runs out of fuel. The outward pressure stops and gravity wins. The core collapses in less than a second, faster than thought, and a black hole is born. The boundary around a black hole is called the event horizon, not a physical surface, but a point of no return. Cross it, and you're gone, falling forever into the dark. Time itself slows as you approach. From the outside, you'd appear frozen, hovering at the edge, but from your perspective, you'd fall through, peacefully, into the unknown. At the very center, the singularity, where all the mass compresses into a point, infinitely small, infinitely dense, where the laws of physics as we know them, break down. A place we can describe mathematically, but never truly understand. The closest black hole to Earth sits about 1,000 light years away, a safe distance. Nothing to fear, just a quiet companion, invisible, patient, orbiting with a visible star, tugging at it gently, predictably, revealing itself only through its pull. Some black holes spin, rotating hundreds of times per second, dragging space itself around them like water swirling down a drain. This is called frame dragging, and near a spinning black hole, you couldn't stand still even if you tried. Space itself would carry you along in an endless, gentle orbit. We can't see black holes directly. They emit no light, but we can see what they do to everything around them. When gas falls toward a black hole, it heats up, spiraling inward, glowing brighter and brighter, forming an accretion disk, a flat ring of light, spinning, reaching millions of degrees, bright enough to outshine entire galaxies. Sometimes, jets of energy shoot out from the poles, perpendicular to the disk, streaming out for thousands of light years, powered by the black hole's spin and the magnetic fields twisted around it. These jets can be seen across the universe, beacons in the dark. In 2019, scientists captured the first image of a black hole, not the hole itself, but its shadow, a dark circle surrounded by glowing orange light. The black hole sits in a galaxy called M87, 55 million light years away, and yet we could see its silhouette. Proof, quiet proof, that these objects are real. The shadow was larger than our entire solar system, 6.5 billion times the mass of our sun, and the light around it, the photon ring, shows us exactly where space curves so much. That light itself is bent into a circle. Gravitational waves, ripples in space-time, were detected for the first time in 2015, caused by two black holes colliding, merging into one. The energy released in that moment was greater than all the stars in the observable universe combined. And yet it passed through Earth, barely a whisper, a tiny stretch and squeeze, measured by instruments so sensitive they could detect a change smaller than an atom. There are stellar black holes, formed from the collapse of massive stars, typically between 5 and 50 times the sun's mass, scattered throughout galaxies, quiet, hidden, waiting. Then there are supermassive black holes, millions, sometimes billions, of times more massive, sitting at the centers of galaxies, including our own, Sagittarius A star, 4 million solar masses, right at the heart of the Milky Way, 26,000 light years away, anchoring our galaxy, holding it together, a gentle giant, dormant for now. Intermediate black holes may exist too, somewhere between stellar and supermassive, hundreds or thousands of solar masses, harder to find, elusive, perhaps formed from the mergers of smaller black holes. or from the direct collapse of massive gas clouds. We're still searching for them. And then there are the primordial black holes, theoretical, tiny, possibly formed in the first moments after the Big Bang, when the universe was hot, dense, chaotic. Some might be smaller than an atom, others as massive as a mountain. If they exist, they could be the dark matter we've been searching for, invisible, everywhere, holding galaxies together. Micro black holes could theoretically be created in particle colliders, but they would evaporate instantly through Hawking radiation, gone before they could do any harm. A brief flicker, then nothing. Time behaves strangely near a black hole. The closer you get, the slower it moves. If you watch someone fall in from a safe distance, you'd see them slow down, moving slower and slower and slower, their light redshifting, dimming until they seem to freeze at the event horizon, never quite crossing, but they, from their own perspective, would fall through in moments, experiencing no pause at all. This is called time dilation, predicted by Einstein's general relativity, and it's been measured, proven. Clocks in stronger gravity tick slower near a black hole. Time nearly stops. If you could orbit close to a black hole just outside the event horizon and then return to Earth, years, decades, centuries might have passed here, while for you, only hours. It's a one-way time machine to the future. Inside the event horizon, the direction toward the singularity becomes as inevitable as moving forward in time. You can no more avoid falling in than you can avoid tomorrow. At the singularity, time and space trade places, what we think of as space becomes time. What we think of time becomes space, a strange inversion beyond our comprehension, where the mathematics break and new physics, unknown physics, must take over. Stephen Hawking discovered something remarkable. Black holes aren't completely black. They emit radiation, very faint, very cold, but real. This happens because of quantum effects near the event horizon. Particle pairs appearing and disappearing. One falls in, the other escapes, and slowly, over unimaginable timescales, the black hole loses mass, evaporates. A black hole the mass of the Sun would take 10 to the 67th power years to evaporate, far longer than the current age of the universe, but smaller black holes evaporate faster, and in their final moments they would explode, releasing all their remaining energy at once, a quiet end to an invisible giant. The radiation is named after Hawking, but it represents something deeper, a connection between gravity, quantum mechanics, and thermodynamics. Black holes have temperature and entropy. They follow the laws of physics, even as they challenge them. The temperature of a black hole is inversely proportional to its mass. The bigger it is, the colder. Supermassive black holes are nearly absolute zero. colder than the cosmic microwave background, so they actually absorb more radiation than they emit, growing very slowly over time. But in the far future, trillions of years from now, when the universe has expanded and cooled, even supermassive black holes will begin to evaporate, shrinking, warming, until they too disappear, leaving nothing behind but a whisper of radiation scattered across the void. If you fell into a black hole, feet first, the gravity at your feet would be stronger than at your head, pulling you apart, stretching you. This is called spaghettification, a gentle word for a violent process. But for a supermassive black hole, the event horizon is so large, the tidal force is so gentle, you might not even notice crossing it. You'd pass through, peacefully, looking back. You'd see the universe speeding up, stars being born and dying, galaxies colliding, time itself racing forward ahead of you, the singularity behind you, everything you've ever known, redshifted, dimming, disappearing. No one knows what happens at the singularity. Our equations fail. Space and time lose meaning. Perhaps you'd be crushed to a point. Perhaps you'd pass through to another universe. Perhaps something stranger still. We can only imagine. Some physicists think black holes might be connected through wormholes, Einstein-Rosen bridges, tunnels through space-time, linking one black hole to another or to a white hole, spewing matter out somewhere else. But no one has ever seen a white hole. And the wormholes, if they exist, would be unstable, collapsing too quickly for anything to pass through. The information paradox asks what happens to information that falls into a black hole. Does it disappear forever, or is it preserved somehow, encoded in the Hawking radiation, or on the event horizon itself? The holographic principle suggests that all the information inside a black hole could be stored on its surface, like a two-dimensional projection of a three-dimensional reality. Nearly every large galaxy has a supermassive black hole at its center. They seem to grow together, the black hole and the galaxy, feeding each other, shaping each other. When galaxies collide, their central black holes eventually merge, orbiting each other for millions of years, spiraling closer and closer until finally they touch and become one, releasing gravitational waves that ripple across the universe. Quasars, the brightest objects in the universe, are powered by supermassive black holes, feeding on vast amounts of gas and dust, the accretion disk glowing so bright it can be seen billions of light years away, outshining a trillion stars. Active galactic nuclei, AGN, are galaxies with black holes actively feeding, their jets shooting out, lighting up the cosmos. But most black holes, including our own, are quiet now, starved of fuel, dormant, waiting. The black hole at the center of the Milky Way, Sagittarius A star, occasionally flares when a star or gas cloud wanders too close. The material heats up, glows, and then fades, a brief moment of activity in an otherwise calm existence. We orbit this black hole, our sun, our planet, our solar system, circling once every 230 million years, a galactic year. We're about halfway through our current orbit, safe, stable, held in place by the gravity of stars and dark matter and the black hole itself. Some scientists think black holes could be doorways to other universes or other times, that inside the event horizon, the rules change and reality, as we know it, ends. Rotating black holes, Kerr black holes, have two event horizons, an outer one and an inner one, and between them, a region called the ergosphere, where space itself is dragged around the black hole, faster than light. In this region, you could extract energy from the black hole by dropping something in and catching what comes out, a Penrose process, named after physicist Roger Penrose, a way to harvest energy from rotation itself. Charged black holes, Reissner-Nordstrom black holes, also have two horizons, but they're unlikely to exist in nature because black holes would quickly neutralize any charge by attracting opposite charges from space. Naked singularities, singularities without event horizons, are prohibited by the cosmic censorship hypothesis, the idea that the universe protects us from the mathematical chaos of singularities by always wrapping them in event horizons, hiding them from view. But whether this is truly a law or just a tendency, no one knows. Black hole bombs, theoretical constructs where you place a mirror around a rotating black hole, trapping its Hawking radiation. The radiation bounces back and forth, amplifying until the black hole explodes, releasing all its energy at once, a weapon or a power source, depending on your perspective. Cygnus X1, the first black hole ever discovered and found in 1971 in the constellation Cygnus, about 6,000 light-years away, orbiting a blue supergiant star, pulling gas from it. The gas heats up, emits X-rays. That's how we found it, watching the invisible through what it does to the visible. V404 Cygni, another black hole in Cygnus, periodically flares into brightness as it devours material from its companion star. In 2015, it had a major outburst, visible to amateur telescopes, a black hole seen from Earth through the light of its feeding. M87 star, the first black hole ever photographed, 6.5 billion solar masses in the galaxy Messier 87, 55 million light-years away. Its jet stretches 5,000 light-years, a stream of particles moving near light speed, lighting up intergalactic space. TON 618, one of the most massive black holes known, 66 billion solar masses, powering a quasar so bright it's visible from Earth, 10 billion light-years away, formed when the universe was very young. How it grew so large, so quickly, remains a mystery. Phoenix A, the black hole at the center of the Phoenix cluster, estimated at 100 billion solar masses, perhaps the largest known, though measurements are uncertain. It sits in a galaxy cluster, 5.7 billion light-years away, quietly, impossibly massive. In the distant future, long after the last star has died, black holes will be the only objects left, drifting through a cold, dark, expanding universe. They'll orbit each other, slowly, losing energy to gravitational waves, spiraling inward over trillions of years, eventually merging, forming larger and larger black holes, forming larger and larger black holes, and then even those will evaporate through Hawking radiation, shrinking over timescales so long we can't comprehend them. 10 to the 100th power years, a Google years, and finally a flash, and they're gone. The universe will be empty then, just photons, stretched by expansion, cold, dark, silent, no stars, no planets, no black holes, just the ghost of what once was. But perhaps, in that far future, quantum fluctuations could create new universes, baby universes, budding off, each with their own laws of physics, and perhaps, in one of them, black holes will form again, stars will shine, and somewhere, someone will fall asleep, thinking about the mystery of darkness and light and time. Light, the fastest thing in the universe, travels at 209,792,458 meters per second. Nothing can go faster, and yet, near a black hole, even light bends. Gravitational lensing. When light from a distant star passes near a black hole, the black hole's gravity bends it, curves it, focuses it like a lens. We can see multiple images of the same star, or rings of light, Einstein rings, named after the man who predicted them. The photon sphere, a region just outside the event horizon, where light can orbit the black hole, travelling in circles, forever, trapped, but not fallen in. If you stood at the photon sphere, you could see the back of your own head, light from you, travelling around the black hole and back. Inside the event horizon, even if you pointed a flashlight outward, the light would curve back down, falling toward the singularity. There is no escape, not for matter, not for light, not for information. Redshift, the stretching of light, happens as light climbs out of a gravitational well, losing energy, shifting toward red. Light from near a black hole is severely redshifted. By the time it reaches us, it's dimmer, cooler, older. Blue shift, the opposite, happens when light falls into a gravitational well, gaining energy, shifting toward blue as you fell toward a black hole. The light ahead of you would blue shift, growing brighter, more energetic, until it might even become lethal. Gamma rays, X-rays, bathing you in radiation. Gravitational redshift was one of the first tests of general relativity, measured in 1959 in a tower at Harvard. Light travelling up lost energy, just as Einstein predicted, and near a black hole, the effect is millions of times stronger. The Schwarzschild radius defines the size of the event horizon. For a non-rotating black hole, it's proportional to the mass. Compress the Earth to the size of a marble, and it becomes a black hole. Compress the Sun to less than 6 kilometers, and it too would collapse. The formula is simple. R equals 2 gm over c squared, where g is the gravitational constant, m is the mass, and c is the speed of light. Elegant, precise, describing the boundary of the unknowable. The Kerr metric describes rotating black holes, much more complex but more realistic, because everything in the universe rotates. Stars rotate, planets rotate, and when they collapse, that rotation doesn't disappear. It concentrates, intensifies. The No-Hair theorem states that black holes are remarkably simple. They are defined by only 3 properties: mass, charge, and angular momentum. Nothing else matters. Whether the black hole formed from hydrogen or iron, from stars or gas clouds, the result is the same. A black hole has no hair, no distinguishing features, just these 3 numbers. The Bekenstein-Hawking entropy formula, S equals kc cubed A over 4gh bar, relates the entropy of a black hole to its surface area, not its volume. This was shocking when first discovered. Entropy, a measure of disorder, information, is stored on the surface, suggesting our 3-dimensional universe might be a projection of information encoded on a 2-dimensional boundary. Penrose diagrams map the entire space-time around a black hole onto a finite diagram showing past, present, future, event horizons, singularities, the entire causal structure. Light always travels at 45-degree angles, and you can see, visually, what can reach what, what's connected to what. Geodesics. The paths objects follow in curved space-time near a black hole. These paths spiral inward, inexorably, inevitably. Once past the event horizon, all geodesics lead to the singularity. There are no paths out. Sometimes black holes come in pairs, orbiting each other, bound by gravity, 2 dancers, spiraling slowly inward. Binary black holes form in several ways. 2 massive stars orbiting each other, both collapse, both become black holes, and they continue their dance. Closer now, faster, or galaxies merge, and their central black holes, after millions of years, find each other and begin their final approach. The orbital decay is slow at first, losing energy to gravitational waves, ripples in space-time, carrying momentum away. The black holes spiral closer, imperceptibly, for eons. But as they get closer, the waves grow stronger, the orbit speeds up, and in the final moments, they're orbiting hundreds of times per second, moving at a significant fraction of light speed, space itself shaking with their motion. The merger, when they finally touch, lasts less than a second, the 2 event horizons becoming one, the singularities merging, releasing more energy in that instant than all the stars in the visible universe combined, but not as light, as gravitational waves, invisible, passing through everything. The ring down, after the merger, the new black hole vibrates like a bell that's been struck, ringing at specific frequencies determined by its mass and spin. The vibrations decay quickly, settling into stillness. A new black hole, slightly larger than the sum of its parts, because some mass converted to energy radiated away as gravitational waves. GW1F914, the first gravitational wave detection that came from two black holes merging, 1.3 billion light-years away, 36 and 29 solar masses, becoming 62 solar masses, 3 solar masses, converted entirely to energy in less than a second. And we felt it here, on Earth, a tiny squeeze and stretch, but we felt it. Since then, dozens more have been detected, each one unique, each one teaching us something new about how black holes form, evolve, merge, about the universe itself. Accretion disk coronae, hot regions above and below the accretion disk, where temperatures reach billions of degrees, emitting X-rays, gamma rays, visible across the universe. Quasi-periodic oscillations, QPOs, flickering in the X-ray light from black holes, repeating patterns like a heartbeat, caused by clumps of matter in the accretion disk, or by oscillations in the disk itself. The frequencies tell us about the black hole's mass and spin, relativistic jets, streams of particles, shot out from near the black hole's poles, travelling at 99.99% the speed of light, stretching for thousands, even millions of light years. How they form exactly is still debated, but they involve twisted magnetic fields and the black hole's rotation, channeling energy outward with incredible precision. Jet precession, when the jet wobbles, like a spinning top, sweeping across the sky, creating spiral patterns, or changing which direction we see it from Earth. Tidal disruption events, when a star wanders too close to a black hole. The tidal forces rip it apart, spaghettifying it. Half the star's material falls into the black hole, creating a bright flare. The other half is flung outward, escaping at high speed. These events are rare, but spectacular when they happen. Hypervelocity stars. Stars moving faster than escape velocity from the galaxy. Some may have been flung out by close encounters with the supermassive black hole at the galactic center, or by binary interactions where one star fell in and the other was ejected, shooting out into intergalactic space. Hill's mechanism, a process where a binary star system approaches a black hole. One star is captured, the other is ejected at incredible speed, while the black hole gains a new companion, perhaps explaining some hypervelocity stars and some of the stars in tight orbits around Sagittarius A star. Black holes captured the public imagination long before we had proof they existed. They appear in science fiction, films, books, Interstellar, the 2014 film, featured Gargantua, a supermassive black hole, rendered with scientific accuracy, using equations from general relativity. The accretion disk appeared above and below the black hole because light was bent around it. Gravitational lensing, visualized beautifully. The film explored time dilation. 1 hour on a planet near the black hole equaled 7 years on Earth, an extreme example, but based on real physics, showing how time is flexible, malleable, near such intense gravity. Event Horizon, a 1997 horror film, imagined a ship that created an artificial black hole for faster-than-light travel, but instead opened a gateway to somewhere dark, somewhere wrong, using black holes as portals, a common science fiction trope, A Brief History of Time. Stephen Hawking's book brought black holes to millions of readers, explaining complex physics in accessible language, inspiring a generation to look up, to wonder, to question. Black holes appear in Star Trek, Doctor Who, Stargate, usually as dangers, obstacles, or plot devices, but occasionally as sources of power or gateways to other times and places. They represent the ultimate unknown, the ultimate mystery, and so they resonate with us. We fear them, we're drawn to them, we imagine what lies inside, even knowing we can never truly know. The Event Horizon Telescope, EHT, isn't a single telescope. It's a network, radio dishes around the world, working together, synchronized by atomic clocks, creating a virtual telescope the size of Earth itself. They observe at 1.3 millimeter wavelength, because this wavelength can penetrate the gas and dust around black holes and is sensitive to the emission from hot plasma in the accretion disk. The data is enormous, petabytes of information, too much to transmit over the internet, so it's recorded on hard drives, physically shipped to a central facility, and then correlated, combined, processed, turning raw data into an image. The imaging process takes months, using sophisticated algorithms to reconstruct what the black hole looks like from the patterns of radio waves detected around the globe. LIGO, the Laser Interferometer, Gravitational Wave Observatory, detects gravitational waves using 2 L-shaped detectors, each arm 4 kilometers long. Lasers bounce back and forth, measuring distances to within a fraction of a proton's width. When a gravitational wave passes through, space itself stretches and squeezes. One arm gets slightly longer, the other slightly shorter, and LIGO detects this change, confirming the wave and revealing the source. Virgo, another detector in Italy, works with LIGO. 3 detectors together can triangulate the source of the waves, pinpointing where in the sky the merger occurred. X-ray telescopes, like Chandra and XMM Newton, observe the hot gas around black holes, seeing through dust and distance, mapping the high-energy universe. Radio telescopes, like the VLA, the Very Large Array in New Mexico, detect radio emission from jets, and accretion disks, building maps of black hole systems. Together, these observatories are revealing black holes in more detail than ever before. We're in a golden age of black hole astronomy, seeing the invisible, hearing the silent, understanding the incomprehensible. The black hole information paradox, one of the deepest mysteries in physics, asks a simple question. What happens to information that falls into a black hole? In quantum mechanics, information is never destroyed. It can be scrambled, hidden, transformed, but never lost. This is called unitarity. But in general relativity, anything that crosses the event horizon is gone forever, crushed at the singularity, erased from the universe. These two theories, our best theories, contradict each other. Hawking initially argued that information is destroyed, that black holes violate quantum mechanics. This shocked the physics community. But later, he changed his mind, suggesting that information might be encoded in the Hawking radiation, subtly, in correlations between particles, too complex to decode, but present. The holographic principle proposes that all the information inside a black hole is encoded on its surface, the event horizon itself, like a hologram storing three-dimensional information on a two-dimensional surface. This led to a radical idea that our entire universe might work this way, that we and everything we see might be projections of information encoded on a distant boundary. The firewall paradox suggests that if information is preserved, then the event horizon might not be smooth, but instead be a wall of high-energy particles, a firewall that would incinerate anything crossing it, contradicting the idea that you could fall through peacefully. Some physicists propose that black holes don't have interiors at all, that they're fuzzballs or gravastars, exotic objects that avoid singularities and preserve information naturally. Others suggest that black holes are connected to quantum entanglement, that ER equals EPR, Einstein-Rosen bridges equal Einstein-Podolsky-Rosen pairs, wormholes equal entanglement, a deep connection between space-time geometry and quantum information. The paradox remains unsolved, driving research at the intersection of quantum mechanics, gravity, and information theory. Perhaps its resolution will lead to a theory of quantum gravity, the holy grail of physics. At the quantum level, black holes become even stranger. The singularity, where our equations break, is where quantum gravity should emerge. String theory proposes that black holes are made of strings, tiny vibrating filaments wound up in complex configurations. The entropy, the information content, comes from counting these configurations. Loop quantum gravity suggests that space itself is quantized, made of discrete chunks, and at the center of a black hole, instead of a singularity, there might be a quantum bounce, matter compressing, then rebounding, possibly creating a white hole in another universe. Black hole complementarity is a principle that tries to resolve paradoxes. It says that different observers see different things. An outside observer sees information encoded on the horizon. An infalling observer passes through smoothly. Both descriptions are valid, but they can never compare notes. Quantum entanglement near black holes creates the firewall paradox. If particles are entangled with Hawking radiation, and also with particles inside the horizon, this violates the rules of entanglement. Something has to give. Either the horizon isn't smooth, or information is lost, or our understanding is incomplete. Some theories propose that black holes have soft hair, not literally, but metaphorically, quantum information stored in subtle quantum states at the event horizon that could encode information about what fell in. The fuzzball proposal replaces the event horizon and singularity with a fuzzy quantum object that fills the entire region. No interior, no singularity, just a dense tangle of strings that looks like a black hole from far away. Virtual particles near the event horizon constantly pop in and out of existence. Quantum fluctuations of the vacuum, and these fluctuations are what create Hawking radiation. One particle escapes, the other falls in, and slowly the black hole shrinks. Between stellar black holes and supermassive ones, there should be intermediate mass black holes, hundreds to thousands of solar masses, but they're elusive. We've found hints, ultra-luminous X-ray sources in nearby galaxies, shining too bright to be stellar black holes, but not quite bright enough to be supermassive. Some globular clusters, dense collections of old stars, may harbour intermediate mass black holes at their centres, holding the cluster together, their gravity keeping stars in orbit. But proving they exist is difficult. They don't feed like supermassive black holes. They're not as common as stellar black holes. They occupy a middle ground, hard to observe, hard to confirm. One candidate, HLX-1 in the galaxy ESO 24349, flares periodically, suggesting a black hole of about 20,000 solar masses, feeding on a companion star. Another, in the dwarf galaxy NGC 4395, has a black hole estimated at 10,000 to 100,000 solar masses, much smaller than typical supermassive black holes, possibly representing an intermediate stage. Gravitational wave detections have found black holes around 100 solar masses, larger than expected for stellar black holes, possibly the lower end of intermediate mass, or the upper end of stellar. The boundary is blurry. These objects could be the seeds that grow into supermassive black holes, or they could form from collisions in dense star clusters, black holes merging repeatedly, building up mass over time. Understanding intermediate mass black holes helps us understand the full population, how black holes form across all scales, and how they grow from stellar remnants to galactic giants. Black holes can spin, some slowly, some incredibly fast, up to 99.9% of the theoretical maximum. Spin is measured by the dimensionless parameter A, ranging from 0 for non-rotating to 1 for maximally rotating. Most observed black holes have a between 0.5 and 1. The spin of a black hole affects the space around it. A spinning black hole drags space in the direction of rotation, frame dragging, the lens-thirring effect. Near a rapidly spinning black hole, the innermost stable circular orbit moves closer to the event horizon. Matter can orbit closer, get hotter, shine brighter before falling in. The spin also affects the jets. Rapidly spinning black holes produce more powerful jets, extracting rotational energy and converting it to outward motion. When two black holes merge, their spins can be aligned or misaligned. Aligned spins produce more gravitational waves. Misaligned spins create a wobble that shows up in the signal. Black holes can spin up by accreting matter from a disk rotating in one direction, gradually adding angular momentum, or they can spin down by accreting matter chaotically from random directions, or by merging with another black hole, spinning the opposite way. The spin history of a black hole tells the story of its formation and its interactions with other objects over billions of years. Some supermassive black holes spin near their maximum rate, suggesting they grew mostly from smooth accretion. Others spin slowly, suggesting chaotic growth or recent mergers. Measuring spin requires precision. Looking at the X-ray spectrum, the shape of emission lines, the behavior of matter near the event horizon, it's technically challenging but incredibly revealing. What if a singularity existed without an event horizon? A naked singularity exposed to the universe. Roger Penrose proposed the cosmic censorship hypothesis, that the universe protects us from naked singularities, that every singularity must be hidden behind an event horizon. But is this always true? Or could there be exceptions? If you spin a black hole fast enough, or charge it sufficiently, the event horizon might disappear, leaving the singularity exposed. But in practice, spinning up a black hole has limits. Before you reach the critical spin, other processes intervene, preventing it from going further. Charged black holes face similar limits. The universe provides charge neutralization. Particles of opposite charge are attracted, fall in, and balance the charge. So naked singularities remain theoretical, mathematical curiosities that probably don't exist in nature. But if one did exist, causality could break down. Signals could emerge from the singularity without passing through an event horizon, violating our notions of predictability. Traveling near a naked singularity could allow closed time-like curves, time travel to the past with all the paradoxes that entails. The cosmic censorship hypothesis protects us from this chaos, ensuring that singularity remain hidden, safely tucked away where they can't interfere with the rest of the universe. Most physicists believe cosmic censorship holds, but proving it rigorously remains an open problem in general relativity. Spacecraft use gravitational assists to gain speed by passing close to planets, stealing a tiny bit of their orbital energy. But near a black hole, the effect is far more extreme. The Penrose process allows you to extract energy from a rotating black hole by dropping an object into the ergosphere, splitting it into two pieces. One falls in, decreasing the black hole's rotation. The other escapes, with more energy than the original. This could theoretically power civilizations advanced enough to harness it, extracting rotational energy from a spinning black hole until it stops rotating entirely. Gravitational slingshots near black holes could accelerate spacecraft to relativistic speeds, a significant fraction of light speed in a single pass. But the tidal forces would be enormous. Only near supermassive black holes, where the horizon is large and tidal forces gentler, could this be remotely safe. Hyperbolic orbits that swing close and then away could redirect a spacecraft, dramatically changing its trajectory with minimal fuel expenditure. Of course, this is entirely theoretical. We have no technology to travel to black holes or survive the journey, but the physics is sound, and perhaps someday, far in the future, advanced civilizations will use black holes not as dangers to avoid, but as tools, engines, gravitational highways through the cosmos. If black holes are regions where nothing escapes, could there be the opposite? White holes where nothing can enter? Mathematically, white holes are allowed by the equations of general relativity, the time-reversed solution to a black hole. Instead of matter falling in, matter would explode outward from a singularity into the universe. But white holes are unstable and have never been observed. They likely don't exist in nature. Some theories propose that the Big Bang itself was a white hole, the ultimate ejection of matter from a singularity, creating space, time, everything. Or that the other side of a black hole might connect to a white hole in another universe, a wormhole linking the two. When you fall into a black hole, you'd emerge from a white hole, somewhere else, someone else. But the connection would be unstable, collapsing almost instantly, closing the door behind you. White holes are fascinating as thought experiments, as mathematical curiosities, but as real objects, the universe seems not to make them. They violate thermodynamics. Entropy should increase, but a white hole, spontaneously ejecting matter, decreases entropy locally. Perhaps quantum effects prevent their formation, or perhaps they existed briefly in the early universe and decayed away. For now, they remain ghosts in the equations, Shadows of black holes. Interesting, but absent. When a black hole feeds, radiation pressure pushes outward from the hot accretion disk, while gravity pulls inward. There's a balance point, the Eddington limit, where radiation pressure equals gravitational pull. Beyond this limit, the black hole can't accrete faster. The radiation blows away the infalling material, creating a natural speed limit on growth. For a solar mass black hole, the Eddington luminosity is about 10 to the 31 watts. Enormous, but finite. For supermassive black holes, it's proportionally larger, allowing them to shine brighter than entire galaxies. But some objects exceed the Eddington limit. Super Eddington accretion shouldn't be possible, yet we observe it. Ultra-luminous X-ray sources shine too bright for their estimated masses, suggesting either they're more massive than we think, or they're accreting super Eddington. Beaming might explain it, if the emission is directional, collimated into jets or cones. Then what we see is brighter than the average, not truly exceeding Eddington. Or the accretion disk geometry might be different. Thick disks, slim disks, allow higher accretion rate without blowing themselves apart. Understanding how black holes can exceed this limit helps explain how supermassive black holes grew so quickly in the early universe. They must have had periods of super Eddington growth, feeding voraciously to reach billions of solar masses in less than 1 billion years. The Eddington limit is a guideline, not a law. Nature finds ways around it, as it often does. At the center of our galaxy, stars orbit Sagittarius A star, the supermassive black hole. In tight elliptical paths, star S2 orbits every 16 years, getting as close as 120 AU, about 4 times Neptune's distance from the Sun. But near a 4 million solar mass black hole, that's incredibly close. S2 reaches 3% of light speed at its closest approach. By tracking S2 over decades, astronomers measured relativistic effects, gravitational redshift, the stretching of light, exactly as Einstein predicted. S62, another star, has an even tighter orbit, approaching to just 16 light hours, moving faster than S2. These stars are laboratories, testing general relativity in extreme conditions, strong gravity, high velocity, where Newton's laws fail. If a star ventured even closer, it might be torn apart by tidal forces, the Roche limit, where the black hole's gravity overwhelms the star's self-gravity. Some stars have been observed making their closest approach and surviving, but others wandered too close and were shredded, creating bright flares as the debris fell in. By watching these stellar orbits, we mapped the black hole's position, its mass, its influence, proving beyond doubt that it's there, even though we can't see it. The orbits themselves are beautiful, elegant, cosmic clockwork, playing out over decades and centuries, indifferent to our observation, ancient dances, continuing forever, quasars, quasi-stellar objects, discovered in the 1960s, appeared as bright points of light, but with strange spectra. They were incredibly distant, billions of light years away, and yet shone brighter than entire galaxies. The only explanation? Supermassive black holes, feeding vigorously, accretion disks glowing with the energy of trillions of stars. Quasars were most common when the universe was younger, 3 to 5 billion years after the Big Bang, a peak era of black hole feeding. Today, quasars are rarer. Most supermassive black holes have gone dormant, starved of fuel. Blazars, a type of quasar, have their jets pointed directly at Earth. We're looking down the barrel of a relativistic particle beam. This makes them appear even brighter and more variable, flaring on timescales of days or hours as clumps of plasma travel down the jet toward us at near light speed. The light is Doppler boosted, blue shifted, intensified by the motion of the jet. Relativistic beaming. Blazars helped prove that supermassive black holes exist in distant galaxies. Their extreme luminosity can only be explained by accretion onto black holes. OJ-287, a blazar, shows periodic outbursts every 12 years, suggesting it's a binary. Two supermassive black holes orbiting each other, the smaller one punching through the accretion disk of the larger, creating a flare each time. Quasars and blazars are windows into the early universe, showing us how galaxies formed, how black holes grew, and how they shaped the cosmos around them. Accretion disks aren't smooth. They have weather, storms, turbulence, flickering. Magnetic fields thread through the disk, tangling, reconnecting, creating hotspots that flare and fade. This is why black hole systems vary in brightness on timescales from seconds to years. The disk is constantly changing, churning, evolving. Magnetorotational instability drives turbulence in the disk. Magnetic fields amplify, creating friction, which heats the gas and allows it to spiral inward. Without this instability, accretion would be much slower. Matter would orbit stably, never falling in. Coronae, regions above and below the disk, are even hotter, millions of degrees, emitting hard X-rays. The corona's exact structure is still debated. Is it a continuous layer or isolated hotspots hovering above the disk? Flares in the corona can be triggered by magnetic reconnection, similar to solar flares, but millions of times more energetic. Disk winds blow outward, driven by radiation pressure or magnetic forces, carrying away angular momentum and allowing the remaining gas to fall inward. These winds can be detected through absorption lines in the X-ray spectrum, blue shifted by their motion toward us. State transitions when a black hole system changes behavior from a hard state dominated by corona to a soft state, dominated by disk emission, or vice versa. These transitions happen as the accretion rate changes, the disk geometry shifts, and the black hole's feeding mode switches from one regime to another. Watching black hole weather teaches us about plasma physics, magnetic fields, and the behavior of matter in extreme conditions. Sagittarius A star, SCA-S, sits 26,000 light-years away at the heart of the Milky Way, 4 million solar masses compressed into a region smaller than Mercury's orbit. It's quiet now, barely feeding, emitting faint radio waves, occasional X-ray flares when gas clouds wander close. But in the past, it may have been much more active, a quasar, perhaps billions of years ago. Evidence of past activity comes from the Fermi bubbles, enormous lobes of gamma rays extending above and below the galactic plane, 50,000 light-years tall. These bubbles might have been inflated by jets from SCA millions of years ago when it last fed heavily, or they could be from a burst of star formation in the galactic center, supernovae, stellar winds driving gas outward. Either way, the galactic center was once far more violent than it is today. In 2019, SCA brightened by a factor of 75 for a few hours, the brightest flare ever recorded. What caused it? Perhaps a gas cloud, torn apart by tidal forces, or an asteroid, evaporated by friction as it spiraled inward. Future observations with the Event Horizon Telescope will image SGR-A, capturing its shadow, just as they did with M87A. But SCA is more challenging, smaller, varies faster. The image blurs as gas orbits in minutes rather than days. Still, we'll see it, our home galaxy's heart, revealed, a silent giant waiting patiently for its next meal. Sometimes a black hole has a companion, a pulsar, a rapidly spinning neutron star, emitting beams of radio waves like a cosmic lighthouse. These binary systems are rare, but incredibly useful. The pulsar acts as a clock, precisely timed, and the black hole's gravity warps the pulsar's signal. By measuring these timing variations, we can map the orbit, determine the black hole's mass, test general relativity with exquisite precision. PSR J1713 plus Rho 747, a pulsar orbiting a white dwarf, but similar systems exist with black holes instead. The gravitational waves from such systems are too weak to detect yet, but future detectors, like LISA, the Laser Interferometer Space Antenna, will hear them humming through space. When a pulsar orbits close to a black hole, its beam can sweep across us, appearing, disappearing, with clockwork regularity, sometimes milliseconds apart, the Shapiro delay. When the pulsar signal passes near the black hole, time dilation slows it down. Arriving slightly late, the delay reveals the black hole's mass and position. Some systems show eclipses when the pulsar passes behind the accretion disk, its signal blocked, then emerging on the other side. Black hole pulsar binaries are natural laboratories where we can study extreme gravity, strong field effects, frame dragging, spin precession, all encoded in radio timing. Finding more of these systems is a priority, each one a treasure, revealing secrets about how gravity works in its strongest forms. When an object is deformed by tidal forces, how much it resists is described by tidal love numbers. For black holes, these numbers are zero. They don't deform at all. They're perfectly rigid, in a sense. This is because the event horizon isn't a physical surface, it's a mathematical boundary. There's nothing to stretch or squeeze. Neutron stars, by contrast, have non-zero love numbers. They deform under tidal stress, bulging slightly when stretched by a companion. During a merger of two objects, the gravitational wave signal encodes their love numbers, revealing what they're made of. When LIGO detected the neutron star merger GW17087, the signal revealed tidal deformability, confirming they were neutron stars, not black holes. If they'd been black holes, the signal would have been different. No tidal effects, just pure orbital decay and merger. Measuring love numbers helps us distinguish between black holes and other compact objects and understand the equation of state of ultra-dense matter. It's a strange name. Tidal love numbers, named after Augustus Edward Hauff-Love, a mathematician from the 1800s who studied Earth's tides. But the concept applies to all objects in strong gravity, from planets to neutron stars, and even, in a sense, to black holes, though their answer is always zero. This rigidity, this inability to deform, is another sign of the black hole's strange nature, a hole in space-time, not an object within it. Black holes inspire not just scientists, but artists, musicians, dreamers. Holst never wrote about black holes, but if he had, what would they sound like? Deep, resonant, ominous, or quiet, subtle, fading? Modern composers have tried translating gravitational wave data into sound. The chirp of merging black holes becomes a musical phrase, rising, accelerating, resolving. Visual artists depict them, swirling discs of light, darkness at the center, representing the unknown, the unknowable. Black holes appear in installations where light bends through curved mirrors or projected images, creating the illusion of warped space. They symbolize absence, void, mystery, but also power, transformation, rebirth. What falls in is destroyed, but also, in a sense, preserved. Photographers at NASA and ESO create stunning visualizations based on real data from simulations, showing what we'd see if we could visit. These aren't fantasies, they're predictions, grounded in physics, translated into imagery that captures the imagination. Poetry, too, finds black holes compelling, metaphors for loss, for grief, for for the passage of time, for things that can't be undone. We project our emotions onto these cosmic objects, seeing in them reflections of ourselves, our fears, our curiosities, our awe at the universe. And perhaps that's fitting, because black holes remind us that we're part of something vast, ancient, beautiful, and terrifyingly indifferent. When light from a distant galaxy passes near a black hole, it bends, following the curve of space-time. This is gravitational lensing, and black holes are powerful lenses. Einstein predicted this in 1915, but it wasn't confirmed until a solar eclipse in 1919, when stars near the sun appeared shifted, their light bent by the sun's gravity. Near a black hole, the effect is far stronger. Light can wrap around multiple times, creating multiple images of the same background object. An Einstein ring forms when a black hole is perfectly aligned between us and a distant light source. The light bends into a circle, a ring of light surrounding the dark center. If the alignment isn't perfect, we see arcs or multiple images, distorted, stretched by the gravitational lens. Microlensing occurs when a smaller black hole passes in front of a star. The star brightens temporarily as its light is focused toward us. This technique helps us search for isolated black holes drifting through space, dark, invisible, revealed only by their gravity. Strong lensing by supermassive black holes can magnify distant galaxies, making them visible when they'd otherwise be too faint. It's like nature provided a telescope built from gravity itself, bending space to show us the unreachable. The lensing also encodes information about the black hole's mass, spin, and position, all extracted from the pattern of distorted light. Every photon tells a story of its journey through curved space around invisible giants to finally reach our eyes. We're in a golden age of black hole astronomy. New detectors, new telescopes, revealing them in unprecedented detail. The Event Horizon Telescope will image more black holes, creating a gallery of event horizons, comparing sizes, shapes, spins. LISA, launching in the 2030s, will detect gravitational waves from supermassive black hole mergers across the universe, opening a new window on cosmic history. The Vera Rubin Observatories will survey the sky, finding thousands of new tidal disruption events, stellar deaths by black hole. Next-generation X-ray telescopes will study accretion disks, coronae, winds in exquisite detail, mapping the flow of matter in strong gravity. Quantum gravity experiments might one day probe the singularity itself, or at least the Planck scale, where space-time becomes grainy. Artificial intelligence is accelerating discovery, analyzing vast data sets, finding patterns humans miss, classifying black holes, predicting their behavior citizen science projects invite everyone to help search for black holes, classifying galaxies, identifying candidates, contributing to science. The questions we're asking now are deeper than ever. What happens at the singularity? How is information preserved? Can we unify quantum mechanics and gravity? Are black holes gateways to other universes? And with each discovery, new questions arise. The more we learn, the more we realize how much we don't know. But that's the beauty of science. The endless frontier. Always another mystery beyond the horizon. Dark matter makes up 85% of all matter, but we've never detected it directly. We know it's there by its gravitational effects. What if dark matter isn't exotic particles, but primordial black holes? Tiny black holes formed in the Big Bang. They'd be invisible, emit no light, interact only through gravity, exactly like dark matter. The idea is old, proposed by Stephen Hawking and others in the 1970s, but new observations have revived interest. If primordial black holes exist in the right mass range, they could explain dark matter without needing new physics. Searchers look for microlensing events when a primordial black hole passes in front of a distant star, briefly brightening it. So far, the results are mixed. Some mass ranges are ruled out, others remain possible. Asteroid mass black holes or planet mass could still be hiding in the dark matter halo of our galaxy. LIGO's detections of merging black holes in unexpected mass ranges hint that some might be primordial. If true, it would solve two mysteries. What is dark matter, and where did these black holes come from? With one answer, but most physicists remain skeptical. The constraints are tight. An alternative explanation for dark matter are still viable. The search continues through microlensing surveys, gravitational wave detections, and observations of the early universe. Perhaps dark matter is something stranger. WIMPs, axions, sterile neutrinos, or perhaps it's been black holes all along, gamma ray bursts, the most energetic explosions since the Big Bang. They last seconds to minutes, releasing more energy than the sun will emit in its entire lifetime. Longer gamma ray bursts come from collapsing massive stars, hypernovae, where the core collapses directly to a black hole. Jets of gamma rays shoot out along the rotation axis at near light speed. If one is pointed at Earth, we see a gamma ray burst. Short gamma ray bursts come from mergers, two neutron stars, or a neutron star and black hole, colliding, forming a black hole and emitting a burst. GRB 7082-7A accompanied the gravitational wave event. GW 170817, confirming the merger origin of short bursts. The mechanism involved the black hole and its accretion disk. Magnetic fields twist, launching jets, funneling energy outward. Within the jet, particles accelerate to relativistic speeds, colliding, producing gamma rays that we detect billions of light years away. The afterglow lasts days to weeks as the jet slows, interacting with surrounding gas, emitting X-rays, visible light, radio waves, gamma-ray bursts of beacons, allowing us to study the distant universe, the early universe when stars were just forming. There are also potential threats. If one occurred within our galaxy, pointed at Earth, it could strip away the ozone layer, causing mass extinction. But such events are rare, perhaps once per galaxy, every few million years, and the odds of being in the beam are tiny. Still, they remind us the universe is dangerous, beautiful, but not benign, and black holes are at the center of some of its most violent moments. Some theories propose that our universe is one of many, a multiverse, an infinite collection. Black holes might connect to other universes through their singularities or through baby universes budding off. Lee Smolin's cosmological natural selection suggests that universes reproduce through black holes. Each black hole creates a new universe with slightly different physical constants. Universes that make more black holes have more offspring. So over time, the multiverse becomes populated by universes optimized for black hole formation. This could explain why our universe has the constants it does, values fine-tuned to allow stars, galaxies, black holes, eternal inflation. Another multiverse theory suggests that universes bubble off from each other. In an ever-expanding multiverse, each bubble has different physics, different forces, some with black holes, some without. Inside a black hole, some physicists speculate a new universe might form, expanding outward in its own space and time, disconnected from ours. To us, it's just a singularity, but from inside, it might look like a big bang. These ideas are speculative, untestable, perhaps untestable forever, but they push the boundaries of what we imagine, what's possible. Black holes, already strange enough, become even stranger as gateways, birthplaces of entire universes. Whether true or not, they expand our thinking about reality, existence, the nature of everything. When multiple objects orbit a black hole, their orbits can synchronize, falling into resonances. A 2-to-1 resonance means one object orbits twice for every orbit of another. Their gravitational tugs align periodically, reinforcing each other. These resonances affect orbital stability. Some resonances are stable, locking objects into place. Others are unstable, ejecting objects over time. Around supermassive black holes, stars can fall into resonances, creating patterns in their orbital distribution. Accretion disk instabilities might also involve resonances between different parts of the disk, creating waves, oscillations that modulate the emitted light. Quasi-periodic oscillations, QPOs, seen in X-ray light curves, might arise from resonances between orbital frequencies Near the black hole, the innermost stable circular orbit, the ISCO, defines a boundary, inside which stable orbits don't exist. Matter spirals inward inexorably, but near the ISCO, orbital dynamics become complex. Precession, frame dragging, all influence the motion. Binary black holes can have resonant interactions, affecting their merger time and the gravitational waves emitted. Resonances are everywhere in planetary systems, asteroid belts, and around black holes. They're nature's way of organizing chaos, creating structure from randomness. Understanding resonances helps us predict long-term behavior of systems around black holes. They're subtle but powerful, shaping the cosmos, one orbit at a time. Cygnus X1, a bright X-ray source discovered in the 1960s in the constellation Cygnus. It was identified as a binary system, a blue supergiant star orbiting something invisible. The invisible companion was too massive to be a neutron star, more than 3 solar masses, the Tolman-Oppenheimer-Volkoff limit. It had to be a black hole, the first one ever confirmed. Stephen Hawking famously bet against it being a black hole in 1974 with Kip Thorne. Hawking lost the bet and conceded in 1990, subscribing Thorne to a magazine. As per the terms, the black hole in Sig X1 is about 21 solar masses, accreting gas from its companion. The gas forms a disk, heating up, emitting X-rays. Sometimes the system flares as clumps of matter fall into the black hole, releasing bursts of energy. Jets have been detected shooting out from the poles at relativistic speeds, visible in radio waves. Sig X1 is only 6,000 light-years away, relatively close, allowing detailed study of its properties. Observations over decades measured its spin, nearly maximal, rotating close to the speed of light. This discovery opened the door to black hole astronomy, proving they exist, confirming Einstein's prediction, and launching a new field. Today we know of dozens of stellar mass black holes, but Sig X1 will always be special, the first, the one that changed everything. Black holes are simple, deceptively simple. They have no features, no distinguishing marks. The no-hair theorem states that black holes are completely described by just 3 numbers: mass, charge, and spin. Nothing else matters. Whether the black hole formed from hydrogen or iron, from stars or gas, the end result is the same. All other information is erased. This is shocking because it means black holes are generic, interchangeable, with no memory of their origin. The event horizon smooths out all irregularities, all bumps, all structure, leaving a perfectly smooth surface, or rather, a perfectly smooth mathematical boundary, since the horizon isn't a physical surface. John Wheeler coined the phrase, "Black holes have no hair," meaning no extra features, beyond mass, charge, and spin, but recent research suggests there might be soft hair, quantum information stored in subtle ways at the event horizon. This wouldn't violate the classical no-hair theorem, but would allow information preservation through quantum effects. The debate continues between those who believe black holes are truly featureless and those who think quantum mechanics adds complexity. Either way, black holes are simpler than any other object in the universe, defined by almost nothing, yet containing everything. A paradox, wrapped in an event horizon, and so we continue drifting through these endless mysteries as black holes waiting patiently in the darkness of space, pulling, bending, transforming everything they touch. There's something almost peaceful about black holes, despite their power. They don't chase, they don't hunt, they simply exist, warping space around them, creating wells so deep that even light cannot climb out. Imagine standing at the edge, not falling, just observing, watching light bend around the event horizon, circling, spiraling, like water around a drain, but slower, more graceful. Photons dancing their final dance before disappearing forever. The event horizon itself is not a place you could stand. It's not solid, not physical, just a boundary, a point of no return. Cross it, and all paths lead inward, to the singularity where mathematics breaks and our understanding ends. But before that moment, before the final plunge, there would be beauty, the accretion disk glowing, orange and blue, heated by friction, by compression, by the inexorable pull, spinning faster, hotter, brighter as it descends. Some black holes are quiet, dormant, waiting in the dark, with no material nearby to consume. They're invisible, detectable only by their gravitational influence, tugging at nearby stars, bending light from distant galaxies, silent giants, patient, eternal. Others are violent, feeding actively, tearing apart stars that wander too close. The stellar material doesn't fall straight in. It forms a disk, and in that disk, chaos, turbulence, magnetic fields twisting and reconnecting, heating the gas to millions of degrees. The jets that shoot from some black holes, perpendicular to the disk, are among the most energetic phenomena in the universe. Particles accelerated to nearly light speed, streaming outward for thousands of light years, visible across the cosmos, beacons powered by darkness. Time near a black hole behaves strangely. An hour near the event horizon could equal years far away. This isn't science fiction. It's measured, proven. Time is flexible, malleable, shaped by gravity. If you could orbit close, just outside the photon sphere, and then return home, you'd find that everyone you knew had aged while you remained young, a one-way journey into the future, powered by extreme gravity. Inside the event horizon, our understanding falters, the singularity, where all the mass concentrates into a point infinitely small. infinitely dense, defies our equations, defies our intuition. It's where general relativity and quantum mechanics clash. Some physicists think the singularity isn't real, that quantum effects, at the smallest scales, prevent infinite density, creating instead something else, a bounce, a transition, a doorway to somewhere unknown. Black holes preserve information or destroy it, depending on which physicist you ask. This paradox, the information paradox, drives research, inspires theories, pushes us toward a deeper understanding of reality. Hawking radiation, the slow evaporation, happens over timescales so vast we can't truly comprehend them. A solar mass black hole would take longer than the current age of the universe to evaporate completely. But eventually, even black holes die. When two black holes merge, the event is cataclysmic, more energy released in a second than all the stars in the observable universe emit, combined, but not as light, as gravitational waves, ripples in space-time itself, spreading outward forever. We've detected dozens of these mergers now, each one unique, each one teaching us about mass, spin, distance, the population of black holes scattered throughout the cosmos. The shadow of a black hole, photographed for the first time in 2019, showed us what we'd only imagined, a dark circle surrounded by glowing light, exactly as predicted by Einstein's equations, written more than a century ago. That image of M87's black hole is a triumph of human curiosity, cooperation, and persistence. 8 telescopes around the world working together as one, creating a virtual telescope the size of Earth. And yet, despite all we've learned, black holes remain mysterious. They mark the edge of our knowledge, the boundary between the known and the unknowable, places where the universe keeps its deepest secrets. They remind us that reality is stranger than we imagine, that our intuitions fail at the extremes, that there are things we can describe mathematically but never truly understand emotionally, experientially. Black holes are teachers, showing us humility, showing us wonder, showing us that the universe doesn't owe us comprehension. It simply is vast, beautiful, indifferent, and we, tiny, brief, get to witness it for a moment. As you drift deeper now into sleep, let these thoughts dissolve like stars into darkness, black holes waiting patiently in the vast expanse, bending space, bending time, bending light while you rest, safe, far away, held by gravity of a different kind, the gentle pull of sleep drawing you down, down into dreams. And so we continue drifting through these endless mysteries, black holes waiting patiently in the darkness of space, pulling, bending, transforming everything they touch. There's something almost peaceful about black holes. Despite their power, they don't chase, they don't hunt, They simply exist, warping space around them, creating wells so deep that even light cannot climb out. Imagine standing at the edge, not falling, just observing, watching light bend around the event horizon, circling, spiraling, like water around a drain, but slower, more graceful. Photons dancing their final dance before disappearing forever. The event horizon itself is not a place you could stand. It's not solid, not physical, just a boundary, a point of no return. Cross it, and all paths lead inward to the singularity where mathematics breaks and our understanding ends. But before that moment, before the final plunge, there would be beauty, the accretion disk glowing, orange and blue, heated by friction, by compression, by the inexorable pull, spinning faster, hotter, brighter as it descends. Some black holes are quiet, dormant, waiting in the dark, with no material nearby to consume. They're invisible, detectable only by their gravitational influence, tugging at nearby stars, bending light from distant galaxies, silent giants, patient, eternal. Others are violent, feeding actively, tearing apart stars that wander too close. The stellar material doesn't fall straight in, it forms a disk, and in that disk, chaos, turbulence, magnetic fields twisting and reconnecting, heating the gas to millions of degrees. The jets that shoot from some black holes, perpendicular to the disk, are among the most energetic phenomena in the universe. Particles accelerated to nearly light speed, streaming outward for thousands of light years, visible across the cosmos, beacons powered by darkness. Time near a black hole behaves strangely. An hour near the event horizon could equal years far away. This isn't science fiction, it's measured, proven. Time is flexible, malleable, shaped by gravity. If you could orbit close just outside the photon sphere and then return home, you'd find that everyone you knew had aged while you remained young. A one-way journey into the future, powered by extreme gravity. Inside the event horizon, our understanding falters, the singularity, where all the mass concentrates into a point infinitely small, infinitely dense, defies our equations, defies our intuition. It's where general relativity and quantum mechanics clash. Some physicists think the singularity isn't real, that quantum effects at the smallest scales prevent infinite density, creating instead something else, a bounce, a transition, a doorway to somewhere unknown. Black holes preserve information or destroy it, depending on which physicist you ask. This paradox, the information paradox, drives research, inspires theories, pushes us toward a deeper understanding of reality. Hawking radiation, the slow evaporation, happens over timescales so vast we can't truly comprehend them. A solar mass black hole would take longer than the current age of the universe to evaporate completely. But eventually, even black holes die. When two black holes merge, the event is cataclysmic. more energy released in a second than all the stars in the observable universe emit combined, but not as light as gravitational waves, ripples in space-time itself, spreading outward forever. We've detected dozens of these mergers now, each one unique, each one teaching us about mass, spin, distance, the population of black holes scattered throughout the cosmos. The shadow of a black hole, photographed for the first time in 2019, showed us what we'd only imagined: a dark circle surrounded by glowing light, exactly as predicted by Einstein's equations, written more than a century ago. That image of M87's black hole is a triumph of human curiosity, cooperation, and persistence. 8 telescopes around the world working together as one, creating a virtual telescope the size of Earth. And yet, despite all we've learned, black holes remain mysterious. They mark the edge of our knowledge, the boundary between the known and the unknowable, places where the universe keeps its deepest secrets. They remind us that reality is stranger than we imagine, that our intuitions fail at the extremes, that there are things we can describe mathematically but never truly understand, emotionally, experientially. Black holes are teachers, showing us humility, showing us wonder, showing us that the universe doesn't owe us comprehension. It simply is vast, beautiful, indifferent, and we, tiny, brief, get to witness it for a moment. As you drift deeper now into sleep, let these thoughts dissolve like stars into darkness, black holes waiting patiently in the vast expanse, bending space, bending time, bending light, while you rest, safe, far away, held by gravity of a different kind, the gentle pull of sleep drawing you down, down into dreams. Deeper still, we venture into the hearts of galaxies where supermassive black holes dwell, millions, billions of times the mass of our sun, anchoring entire cosmic cities, stars orbiting them, like planets around a star, but on scales immense, incomprehensible. Sagittarius A, at the center of our Milky Way, a quiet giant, 4 million solar masses, compact, lurking, revealed through the dance of nearby stars, whipping around at incredible speeds, their paths tracing the invisible mass, a shadow we imaged in 2022, another dark circle, ringed in fire, proof that even our home galaxy harbors such a beast. These supermassive ones, how do they form? Some from mergers, black holes colliding, growing over billions of years. Others perhaps from direct collapse, massive gas clouds imploding under their own weight in the early universe, when everything was denser, hotter, more chaotic. Intermediate black holes, the missing links between stellar and supermassive, elusive, hidden in globular clusters, or the remnants of ancient mergers. We've glimpsed a few through gravitational waves or X-ray bursts, hints of a population bridging the gaps, the no-hair theorem, whispers simplicity. A black hole defined by just three things: mass, charge, spin. No other details, no history etched on its surface, all complexity erased, reduced to basics, like a cosmic reset button pressed by gravity. But spin matters. Kerr black holes, rotating, frame-dragging space-time, twisting it like a vortex. Ergospheres where you could hover, extracting energy. The Penrose process, stealing rotational power, turning black holes into engines, hypothetical yet mathematically sound. Primordial black holes, born in the Big Bang's aftermath, tiny, perhaps microscopic, evaporating quickly or lingering as dark matter candidates, explaining the unseen mass, holding galaxies together, invisible threads woven into the fabric of the cosmos. The holographic principle, inspired by black holes, suggests our three-dimensional reality is a projection from a two-dimensional surface, like the event horizon, information encoded there, never lost, challenging our sense of depth, of volume, making the universe a grand illusion. Quantum entanglement and black holes intertwined. Some theories propose wormholes as bridges, ER equals EPR, connecting distant points through quantum links, black holes as portals, not to other universes, but to entangled partners, a network beneath reality. Recent gazes from the James Webb Space Telescope, peering back in time, spotting black holes in the dawn of the universe, surprisingly massive, grown too fast, challenging models, forcing us to rethink seeding, growth, the early cosmos more fertile than we knew. Black holes in binaries, dancing with companions, neutron stars, or other black holes, their orbits decaying, spiraling inward until merger, the final chirp, detected by LIGO, Virgo, Kagra, waves washing over Earth. From billions of light years away, each detection a story of violence, creation, evolution, entropy of black holes, vast, proportional to surface area, not volume. Bekenstein-Hawking formula linking gravity to thermodynamics, treating horizons as hot, radiating, a bridge between classical dust and quantum worlds, entropy as information, hidden but countable. In fiction, black holes devour ships, warp time for heroes, but reality is subtler. No sudden sucks, just gradual pulls, spaghettification, stretching you thin as tides tear atoms apart, long before the horizon, a gentle end from afar, horrific up close, yet some speculate. Traversable wormholes, stabilized by exotic matter, connecting through black holes, shortcuts across space or time, dreams of travel, balanced on the edge of possibility and paradox. As we learn more from simulations, supercomputers crunching equations, modeling in falls, jets, mergers, revealing dynamics we couldn't observe directly, virtual universes mirroring the real, teaching us patience, precision. And in 2025, new detections roll in. gravitational wave observatories expanding, space-based like LISA, listening for lower frequencies, supermassive mergers, the bass notes of the cosmic symphony, rumbling through space-time. Black holes challenge us to unite theories, quantum gravity, strings, loops, holograms, paths to a theory of everything, where singularities smooth out, infinities tamed, reality revealed in full. They embody duality, destroyers, creators, seeding galaxies, regulating star formation, their feedback loops, quenching, igniting, cosmic balance keepers, drifting further. Let these enigmas fade into the night, black holes eternal, patient as you surrender to rest, thoughts evaporating like Hawking's glow, slow, inevitable, into peaceful void. Black holes remind us that the universe is stranger than we imagine, that our intuitions fail at the extremes. They are the ultimate unknown, places where knowledge ends and mystery begins. Einstein initially didn't believe they could exist. He thought the universe would find a way to prevent such extreme objects. But nature is more creative than we are, and black holes, impossible as they seem, are real. They teach us humility, that there are things we cannot see, cannot reach, cannot fully understand, and that's okay. The universe doesn't owe us answers. It simply is, vast, beautiful, indifferent, and we, tiny, brief, get to witness it for a moment. Black holes are the universe's secret keepers, holding information, energy, matter, in a place we can never retrieve it from. The ultimate vault, locked forever. And yet, we study them, we photograph them, we detect their mergers, we calculate their properties, we dream about them, because that's what we do. We explore, we question, we wonder. Even knowing we'll never have all the answers, we still reach out into the dark, searching for light, for meaning, for connection. And so we drift through these 100 mysteries, gentle wonders, looping softly, endlessly. Black holes, silent and strange, waiting at the edges of comprehension, bending time, bending space, bending light. But here, now, you are safe, far from event horizons, far from singularities, just resting, breathing, floating. Let these thoughts dissolve like stars into darkness, each one fading softly until only sleep remains. Your body is heavy now, sinking deeper into comfort, every muscle releasing, every breath slower, softer. The universe is vast, but you're here, small, safe, held by gravity, by warmth, by rest. Thump, 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 your heartbeat, steady, slow, matching the quiet rhythm of space. Nothing to do, nowhere to go, just this moment, this breath, this calm. And if your mind wanders back to black holes, let it. Let the thoughts float through, like light passing near an event horizon, bending, dimming, drifting away. You don't need to understand. You don't need to remember. You just need to rest. And the mysteries will still be here when you wake, waiting patiently in the dark. The universe keeps turning. Black holes keep pulling, and will keep drifting, floating together through the mysteries, 100 space mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the hidden world, drifting in the void that astronomers swear should exist, but can't quite prove. The faint cosmic murmur that behaves like a star but refuses to shine like one. The invisible tension stretching space so fiercely that it's quietly reshaping the universe itself. There's nothing you need to do now. Just let your body sink. Heavier, heavier. Feel the mattress holding you. Every muscle softening, your heartbeat slowing. Thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into space. Imagine, somewhere beyond the edge of everything you know, there's a nebula turning so slowly that even if you watched for your entire lifetime, you wouldn't see it move. It's clouds of gas and dust, stretching across light years, spiral in patterns that take millions of years to complete. Thump, thump, one full rotation, lasting longer than mountains rise and fall on Earth. The colours there, reds and purples and deep indigo blues, shifting imperceptibly, like watching paint dry across the canvas of infinity. Heavier, heavier, your eyelids growing heavy as those ancient clouds, drifting, always drifting. Between the galaxies, there is silence, not the silence of a quiet room, but the silence of true emptiness. The space between galaxy clusters, voids so vast that light from one side takes hundreds of millions of years to reach the other. In these cosmic deserts, the temperature drops to just above absolute zero, and the density of matter becomes almost nothing. Almost a single hydrogen atom, floating alone in a space the size of a cathedral. Thump, thump. That loneliness, that stillness, echoing through your breathing now. Slower, slower. Nothing to do, nowhere to be, just floating in the between. There are stars that sleep, brown dwarfs they're called, failed stars, too small to ignite fusion in their cores. They glow faintly with leftover heat from their formation, cooling over billions of years. Their gravity still pulls, still shapes, still holds, but silently, without the violence of fusion, without the burning, just a gentle mass, curving space around it, the way your body curves into the bed, sinking, sinking. These sleeping stars, scattered throughout the galaxy, emitting mostly infrared light, invisible to the naked eye, but there, always there, in the darkness, a single grain of cosmic dust, no larger than the ones floating through the sunlight in your room, begins a journey, born in the atmosphere of a dying red giant star. Blown outward by stellar wind, it drifts, for millennia, through the interstellar medium. It passes through molecular clouds, accumulates thin layers of ice, water, carbon dioxide, methane. Eventually, perhaps, it becomes part of a new solar system, pressed into a comet or an asteroid, or the core of a planet. That tiny grain, travelling for millions of years, just drifting, the way you're drifting now, heavier, heavier, into sleep. The aurora, that gentle curtain of light dancing in the polar skies, is a conversation between the sun and earth. Solar wind, a stream of charged particles, flows outward from our star, invisible, constant. When these particles reach Earth, they are caught by the magnetic field, channeled toward the poles, where they collide with oxygen and nitrogen in the atmosphere. The oxygen glows green and red, the nitrogen glows blue and purple. Thump, thump. Each collision, a tiny spark of colour, billions of them together, creating those flowing ribbons, that silent light show, playing every night in the far north and far south. While most of the world sleeps, somewhere out there, a moon orbits in perfect silence. Perhaps it circles a gas giant or a distant ice world beyond Neptune. Its orbit is so stable, so circular, so precise, that it's been following the same path for billions of years. No atmosphere to create friction, no tides to slow it down, just the endless falling that is orbit, around and around, thump, thump, like your thoughts, circling, slower now, quieter. The gravity of that sleeping planet holding its moon, the way the darkness holds you now, safe, predictable, eternal, the light reaching your eyes from distant stars, left those stars before you were born. Some of it, from the dimmest stars visible on a dark night, began its journey a century ago. When your great-grandparents were young, or not yet born, that photon, travelling through empty space for 100 years, finally enters your eye and disappears, its journey complete. Every star you see is a ghost from the past, showing you not where it is, but where it was when that light began to travel, heavier, heavier. Time itself, stretching across the cosmos. Space is an ocean, deeper than any water. Astronomers speak of the cosmic ocean, but they mean something different from what you might imagine. It's not made of water, but of vacuum, of quantum fields, of virtual particles appearing and disappearing. The depth of this ocean is measured not in meters, but in megaparsecs. Galaxies float in it like bioluminescent creatures, galaxy clusters like schools of fish, and between them, the deep, empty, quiet places, where nothing shines. Thump, thump. You're floating now, in your own dark ocean, drifting down, down. The universe is expanding every second. The space between distant galaxies grows larger, not because galaxies are moving through space, but because space itself is stretching. Like dots on a balloon being inflated, each dot moves away from every other dot. The vacuum itself, the nothing between things, is growing. This expansion began 13.8 billion years ago, and it continues, accelerating, driven by something we call dark energy, an invisible pressure pushing outward, everywhere, all at once. The vacuum expanding. The way your awareness expands now, becoming bigger, looser, less defined. There's a sound in space, not a sound you could hear, but a hum in the electromagnetic spectrum, the cosmic microwave background radiation. The afterglow of the Big Bang fills all of space with microwaves. If your eyes could see these wavelengths, the entire sky would glow, softly, uniformly, in every direction. This radiation has been travelling since the universe was only 380,000 years old. When it was still hot and dense, now it's cooled to just 2.7 degrees above absolute zero. Thump, thump, that ancient warmth, that primordial hum surrounding everything, including you. As you sink deeper into the background, into the static, into sleep. White dwarf stars, the cause of dead stars like our sun, cool slowly, so slowly that the universe isn't old enough for any of them to have cooled completely. They start at hundreds of thousands of degrees, and slowly, over trillions of years, they radiate away their heat. Eventually, in a future so distant it's hard to imagine, they'll become black dwarfs, dark, cold, invisible. But for now, they glow faintly, white or blue-white, growing dimmer, century by century, millennium by millennium. The way your awareness grows dimmer now, thoughts cooling, energy radiating away, heavier, heavier. When astronomers point their telescopes at a tiny patch of empty sky and leave the shutter open for days, they capture what they call a deep field image. Thousands of galaxies appear, each one containing billions of stars, all in a space no bigger than a grain of sand held at arm's length. This is the deep field lullaby, the revelation that everywhere we look, in every direction, in every seemingly empty patch of darkness, there is light, ancient light from galaxies formed when the universe was young. Thump, thump. The darkness is full, crowded with distant fires, but from here it looks like perfect, peaceful, nothing. On the ice giant planets, Neptune and Uranus, there are shadows, clouds in the upper atmosphere, moved by winds faster than any hurricane on Earth, cast shadows on the cloud layers below. These shadows drift across the face of the planet, enormous, covering areas larger than Earth, but moving slowly, majestically. The sunlight there is 40 times fainter than on Earth, everything bathed in a dim, twilight glow, blue-green, cold. The shadows deepen that twilight, creating pools of darkness, drifting across an ocean of atmosphere, the way darkness drifts across your closed eyelids now, shapes moving, melting, dissolving. Beyond Neptune, past Pluto, lies the Kuiper Belt, a disk of icy bodies, remnants from the formation of the solar system. Millions of objects, some as large as Pluto, most smaller, orbiting in the cold, the dark, separated by vast distances. An explorer crossing the Kuiper Belt would spend years, decades, traveling between objects through empty space, seeing only the distant sun, a bright star, not bright enough to read by, just drift and darkness, and the occasional glimpse of a tumbling ice world, passing by, then receding into darkness again. Thump, thump, that drift, that journey through nothing. You're on it now. Quasars, the brightest objects in the universe, are actually echoes from the distant past. Supermassive black holes at the centers of young galaxies, consuming matter, heating it to millions of degrees, creating jets of radiation that outshine entire galaxies. But the quasars we see are billions of light years away, which means we're seeing them as they were billions of years ago, when the universe was young, violent, chaotic. Now, those same black holes are likely dormant, quiet, sleeping. The echo of their fury reaches us softly away from across time and space, heavier, heavier. An ancient roar, arriving now as a whisper, interstellar clouds, vast regions of gas and dust between the stars, drift slowly through the galaxy. They move through the spiral arms, taking millions of years to complete a single orbit around the galactic center. These clouds are where stars are born, but most of the time they simply drift, dark, cold, lit only by starlight scattered through their edges, creating glowing nebulae in some places, but mostly just darkness, drifting. The migration of these clouds, reshaping the galaxy, slowly, so slowly, the way continents drift across Earth, imperceptible but inevitable. You're migrating now towards sleep, slow, inevitable, in deep space, between the stars. There are regions of perfect silence. No radio signals reach there from Earth, no signals from the sun, just the faint, uniform background radiation and occasional cosmic rays passing through. If you could float there in a spacesuit in the middle of nowhere, light years from the nearest star, you would see thousands of stars in every direction, but hear nothing, feel nothing but the cold, and experience a loneliness so complete, so total, that it becomes almost peaceful. Thump, thump. That silence, you can feel it now in the space between your heartbeats and the pause between breaths. Silence, settling. The first light in the universe after the Big Bang came from primordial hydrogen and helium gas, glowing as it cooled. This faint glow, stretched by the expansion of space, is what we now detect as the cosmic microwave background. But before that, for 380,000 years, the universe was opaque, filled with a hot plasma that light couldn't travel through. That primordial gas, that first faint glow, it's still there, all around us, red-shifted into microwaves, invisible but present. The oldest light, the first light, cradling the universe, cradling you as you drift deeper. There are comets that got lost, ejected from their original orbits by gravitational interactions. They wander through the galaxy, some traveling in interstellar space between stars for millions of years before perhaps, by chance, entering another star system. These lost comets, frozen, dormant, carry with them ices from their birth system, water, carbon dioxide, ammonia, memories frozen in their nuclei. They drift in the darkness, waiting for the warmth of a star to wake them. But for now, just drifting, sleeping, the way you're sleeping now, heavier, heavier. Every planet, every moon, every object in space has a magnetic field, or the ghost of one. Earth's magnetic field, generated by the churning of molten iron in its core, creates a protective bubble around the planet, shielding us from solar wind. Some planets, like Jupiter, have magnetic fields thousands of times stronger. Others, like Mars, lost their magnetic fields billions of years ago, leaving only traces in the magnetized rocks of their crust. These invisible fields, stretching through space, channels for particles, guides for solar wind, shaping space around them quietly, invisibly, thump, thump, like the field of your own awareness, expanding, then contracting, then releasing. Near a black hole, time bends. An observer far away, watching something fall toward the event horizon, would see it slow down, taking forever to cross that boundary. From the falling object's perspective, everything proceeds normally, but from outside, time stretches, dilates, approaches infinity. This isn't metaphor, it's geometry. The shape of space-time curves so extremely that the flow of time itself changes. Where gravity is weak, like here on Earth, time flows normally, but near the ultimate nothing, the collapsed nothing of a black hole, time becomes like honey, flowing, slower, slower, the way time feels now as you sink towards sleep. Seconds stretching, becoming longer, thicker, heavier. The Andromeda Galaxy, our nearest large galactic neighbour, is visible to the naked eye on a dark night. A small, fuzzy patch of light. That light left Andromeda 2.5 million years ago, when early humans were just learning to use stone tools. The photons reaching your eyes tonight began their journey across intergalactic space, before recorded history, before civilization, before agriculture, travelling through the void for 2.5 million years, just to end their journey in your eye, that ancient light connecting you to a galaxy containing 1 trillion stars, all of them distant, unreachable, but somehow present in that faint glow. Thump, thump. Galaxies have structure, spiral arms, where stars are being born, trace patterns through the disk. These aren't rigid structures, like the arms of a pinwheel, but density waves, regions where stars and gas clouds crowd closer together, creating the appearance of arms. The stars themselves orbit the galactic center, passing through the arms, like cars passing through a traffic jam. The arms persist, even as individual stars move through them. A sleeping galaxy, with its stars orbiting quietly, its arms drifting, turning, slower than slow, taking 200 million years for our sun to complete one orbit. Heavier, heavier. You're orbiting now, around the center of sleep, spiraling inward. The sun emits not just light, but a constant stream of charged particles. The solar wind, this wind, blowing outward in all directions, creates a pressure, subtle but real, on small particles like grains of dust or the tails of comets. This pressure is enough to push them, creating comet tails that always point away from the sun. The stellar wind from other stars does the same throughout the galaxy. This gentle pressure pushing on gas and dust, shaping nebulae, clearing spaces, herding matter like a cosmic breeze, soft, constant, invisible. You can almost feel it now, that gentle pressure encouraging you to let go, to drift, to release. In the cold, outer regions of space, water ice takes on crystalline structures, different from the ice you know, the ice on comets, on the moons of Jupiter and Saturn, on Kuiper belt objects, forms in hexagonal crystals, layers of molecules arranged in precise patterns. In the deep cold, near absolute zero, this ice can survive for billions of years, unchanged, preserved. Each crystal, a tiny structure of perfect order in the chaos of space. Thump, thump, like your thoughts, crystallizing, becoming simpler, more ordered, more still. The solar system has a boundary, not a sharp edge, but a region where the solar wind finally stops pushing outward, the heliopause, where the sun's influence ends and interstellar space begins. The Voyager spacecraft crossed this boundary, reporting back a change at the particles detected. Suddenly, instead of particles from the sun, they detected particles from the galaxy at large, from other stars, from the interstellar medium. The boundary is not a wall, but a transition, a gradual fading from one realm to another, the way waking fades, gradually, gradually, into sleep. Humans have named the constellations, patterns of stars that aren't actually related, just appearing close together from our perspective. But the ancient names, the stories attached to them, are mostly forgotten now. Astronomers use them still. Orion, Cassiopeia, Ursa Major, but the myths behind them, the reasons they were named, have faded into obscurity. The stars themselves don't care. They continue their slow drift through the galaxy. Their apparent patterns, from our perspective, will eventually change over tens of thousands of years. New constellations will form, and these names, these ancient forgotten stories, will become even more meaningless, heavier, heavier. Everything forgotten, dissolved, like thoughts dissolving into sleep. Dark matter, the invisible mass that holds galaxies together, pulls on everything. We can't see it, can't detect it directly, but we see its effects. Galaxies rotate faster than they should, unless there's more mass than we can see. Galaxy clusters bend light from more distant galaxies, more than the visible matter alone could account for. This invisible substance, making up 85% of all matter in the universe, pulls quietly, constantly, shaping the cosmic web, the large-scale structure of everything. Thump, thump. You can feel it now, that quiet pull toward darkness, toward rest, toward the invisible, inevitable, center of sleep, deep inside some exoplanets, far from any sun. The core heats slowly, from radioactive decay, from leftover heat of formation, from the pressure of the planet's own weight. This internal heat rises slowly, taking millions of years to reach the surface. On some worlds, this creates volcanism, plate tectonics. On others, it merely warms the planet slightly, keeping it from cooling to the temperature of space. This slow heating, this deep warmth, rising from within, the way warmth rises in your body now, as your metabolism slows, as you settle, as everything becomes softer, warmer, heavier. Gravitational waves as ripples in space-time itself pass through the Earth constantly, caused by colliding black holes, merging neutron stars, cataclysms billions of light years away. These waves stretch and compress space as they pass, by amounts smaller than an atom. We built detectors sensitive enough to feel this, to hear the universe ringing like a bell when massive objects collide. But most gravitational waves are undetectable, too subtle, too faint, just the fabric of space, gently rippling, constantly, imperceptibly, the way water ripples, even when it seems still. You're rippling now, gently, your awareness expanding and contracting in waves, softer, softer, thump, thump. Beyond what we can see, beyond the observable universe, there is more space. There must be. The universe doesn't end at the edge of what we can observe. It continues, possibly forever, possibly repeating, possibly containing everything that could possibly exist. But we can't see it, because light from there hasn't had time to reach us yet. That hidden space, that unreachable beyond, stretches out forever, filled with galaxies we'll never see, stars whose light will never reach Earth, entire cosmic structures, unknown, unknowable, existing in perfect, permanent isolation. The way your deepest thoughts exist in a space that no one else can reach, private, hidden, dissolving now into the beyond. Molecular clouds, The vast dark nebulae where stars form are composed mostly of molecular hydrogen, H2O, with traces of carbon monoxide, water, ammonia, and other simple molecules. These clouds are cold, just 10 or 20 degrees above absolute zero, and dense by space standards, though still far more tenuous than any vacuum we can create on Earth. Inside these clouds, in the darkest, coldest cores, gravity slowly pulls matter together over millions of years, until eventually a star ignites. But most of the time, these clouds just are dark, cold, silent, their composition unchanging, waiting, heavier, heavier, like you're waiting now in the darkness, quiet, cold, waiting for nothing, expecting nothing. Around some stars, around some planets, there are tori, donut-shaped rings of gas and dust, orbiting in the equatorial plane. These structures, formed by various processes, outflow from a star or material captured by a planet's gravity, glow faintly, illuminated by the star they orbit. The gas in these tori moves slowly, orbiting, taking years or centuries to complete one revolution. The shimmer of this gas, heated by starlight or by collisions within the ring, creates a soft, diffuse glow, barely visible, barely there. Thump, thump, like the thoughts drifting through your mind now. Barely visible, barely there, fading. Right now, at this very moment, a star is being born, millions of light years away, in a dark molecular cloud, in a galaxy whose light left long before you were born. Matter is collapsing under its own gravity, heating up, compressing. Eventually it will ignite, fusion will begin, and a new star will shine. But we won't see it for millions of years. The light from that birth, travelling toward us, won't arrive until long after you're gone. Long after everyone you know is gone. That moment, happening now, but invisible, unknowable, existing in a present we can't access, only in a future that will one day be past, everything, flowing, like time itself, flowing through you, past you, carrying you downstream, heavier, heavier. There are planets without stars, rogue planets, ejected from their birth systems by gravitational interactions, drifting through the galaxy, alone, in the dark. These worlds, some perhaps Earth-sized, some larger, receive no warmth from a sun, only the faint background radiation of space, and whatever internal heat remains from their formation. They wander through the interstellar medium, taking millions of years to cross from one star system to another, perhaps never to be captured, never to orbit again, just drifting endlessly through the cold, the dark, the silence. Thump, thump, drifting like you're drifting now, untethered, free, floating in darkness. The cosmic web, the large-scale structure of the universe, forms filaments, long strings of galaxies, connected by invisible threads of dark matter and gas, stretching between galaxy clusters. These filaments, hundreds of millions of light years long, shimmer faintly with the light of countless galaxies, creating a web-like pattern that looks, from a great enough distance, like neurons in a brain or frost on a window. The galaxies within these filaments move slowly along them, following the gravitational channels, the rivers of dark matter, flowing, drifting, forever. The shimmer of that cosmic web, too vast to comprehend, too beautiful to look away from, drawing you in, deeper, heavier. The event horizon of a black hole, that point of no return, is perhaps the calmest place in the universe. From the outside, it appears to be a sphere of perfect darkness, unchanging, eternal. Nothing escapes, not even light, so nothing disturbs the stillness of that boundary. Time itself, from the perspective of a distant observer, stops at the horizon, events frozen, forever, in the moment before they cross over. That calm, that stillness, that horizon between being and non-being, you're approaching it now. The event horizon of consciousness, where wakefulness ends and sleep begins, heavier, heavier, crossing over. Binary star systems, two stars orbiting each other, dance through space, bound by mutual gravity. They might orbit close, completing a revolution in hours or days, or far apart, taking centuries. The dance is silent, perfect, each star falling toward the other, but always missing, creating instead an eternal orbit. Some binaries are so close they touch, sharing material between them, creating a peanut-shaped system. Others are so far apart they barely interact. Just two stars, happening to move through space together, circling, always circling. Thump, thump, like your thoughts circling now, slower, wider, losing coherence, losing connection, but still moving, still dancing, until they stop. When a massive star explodes in a supernova, it leaves behind a remnant, a cloud of gas expanding outward, glowing from the energy of the explosion, enriched with heavy elements forged in that final moment. These remnants, like the Crab Nebula, expand for thousands of years, gradually fading, mixing with the interstellar medium, returning their elements to space, where they might one day become part of a new solar system. The glow of these newborn remnants, these echoes of stellar death, is beautiful. Green and blue and red, false color images from different wavelengths, showing oxygen, sulfur, hydrogen, all drifting outward, expanding, dissolving, the way your thoughts dissolve now, heavier, heavier, expanding into nothing. The solar wind, that stream of charged particles from the sun, creates storms in space, interplanetary storms. When these particles interact with planetary magnetic fields, they create auroras, radiation belts, magnetic substorms. But between the planets, the storms are invisible, just fluctuations in particle density, in magnetic field strength, measured only by spacecraft. The faint trail of these disturbances, rippling outward from the sun, washing over the planets, bending around their magnetic fields, creating turbulence in the solar system. Turbulence you'd never know existed unless you looked with the right instruments. Everything invisible, everything silent, everything hidden, like the processes of your body now, breathing, heartbeat, all continuing while you drift away from awareness, from noticing. Saturn's rings, those magnificent structures, are not solid, but composed of billions of ice particles, ranging from grain-sized to house-sized. Each particle follows its own orbit, creating the appearance of rings, the shepherd moons, small moons orbiting near the rings. Use their gravity to keep the rings in place, preventing them from spreading. The arc of this distant ring system, visible through a telescope from Earth, glows softly with reflected sunlight. The rings are thin, incredibly thin, sometimes only 30 feet from top to bottom, despite being hundreds of thousands of miles wide, like paper, like a whisper, like the thin boundary between waking and sleeping that you're crossing now. Thump, thump, crossing over, magnetaires, neutron stars with magnetic fields trillions of times stronger than Earth's, spin slowly compared to other neutron stars, rotating once every few seconds, or even every few minutes. The immense magnetic field creates intense radiation, X-rays and gamma rays. But between the bursts, there is silence, the slow spin, the patient rotation of an object the size of a city, but with the mass of a star, creates rhythms, pulses, detectable across thousands of light years, but mostly it's just there, spinning quietly in the darkness, its magnetic field reaching out into space, invisible, powerful, pulling on nothing, affecting nothing, just being heavier, heavier. You're spinning too, slower now, almost stopped. Pulsars, rapidly spinning neutron stars, emit beams of radiation from their magnetic poles. As they spin, these beams sweep across space like lighthouse beams. If Earth happens to be in the path, we detect regular pulses. Some pulses pulse hundreds of times per second, others just once every few seconds. The lonely pulsar, isolated in space, far from any companion star, pulses into the void, its signals travelling outward in all directions, received by no one until perhaps millions of years later. The beam happens to sweep across a planet with receivers. The pulse, the regular pulse, thump, thump, like a heartbeat, like your heartbeat, slowing, slowing, the rhythm of the universe pulsing through you, between galaxy clusters, in the spaces where the cosmic web is thinnest. There is dust, intergalactic dust, individual grains separated by thousands of miles, drifting through the void. This thin veil, barely detectable, dims the light from distant galaxies, just slightly. Astronomers must account for it when measuring cosmic distances, but the dust itself, It's almost nothing, a trace, a hint, a suggestion of matter in what is otherwise essentially empty space, that thinness, that barely their quality, like your thoughts now, thinning out, becoming transparent, barely present, barely anything at all. Some galaxies are dying, their star formation has ceased, their gas has been stripped away, or heated too much to collapse and form new stars. These dying galaxies, often elliptical galaxies, are filled with old, red stars, slowly fading. No new stars are born to replace them. The cold breath of these galaxies, their slow decline into darkness, takes billions of years. You'd never notice it, watching for a human lifetime. But on cosmic timescales, they're cooling, fading, approaching their end, like everything, temporary, even galaxies, even stars, even consciousness, fading, cooling, heavier, heavier, into the cold. In stellar nurseries, in the densest parts of molecular clouds, protostars form. They haven't begun fusion yet. They're still collapsing, still heating up. These young objects, shrouded in dust, emit only infrared light. They're invisible to optical telescopes, but to infrared instruments, they glow. The murmur of these collapsing protostars, the slight brightening as they contract, the wobbles from material falling onto them, creates variations in brightness, murmurs in the infrared, barely detectable, like whispers, like distant conversations you can't quite hear, fading in and out, like consciousness, murmuring, fading, thump, thump, at the intersections of cosmic web filaments, where multiple strands of galaxies meet, there is hidden mass, concentrations of dark matter and gas, too diffuse to form galaxies, but massive nonetheless. These nodes in the cosmic web shape the flow of matter on the largest scales, pulling on galaxy clusters, affecting their motion, but the mass itself is invisible, inferred only from its gravitational effects, hidden but present, influencing everything, like the hidden processes of your mind, influencing your dreams, your sleep, your breathing, all happening without your awareness, without your control, just happening, heavier, heavier. In the outer solar system, some moons of Jupiter and Saturn, covered in ice, are slowly thawing, not from the sun's heat, which is faint out there, but from tidal heating, the gravity of their parent planets, squeezing and releasing them as they orbit, generates heat through friction. This heat, accumulated over millions of years, has melted ice beneath the surface, creating subsurface oceans. The slow thaw of these frozen worlds, the gradual warming of water that has been ice for billions of years, happens in darkness, beneath miles of ice, unseen, unknown, except through inference, like memories thawing in the moments before sleep, fragments rising, then dissolving back into ice, back into cold, back into forgetting. The light from the most distant galaxies, visible in deep field images, is ancient. So ancient that we see these galaxies as they were when the universe was less than 1 billion years old. These galaxies are small, irregular, intensely forming stars. They're building themselves, creating their first generations of stars. These ancient starlight, shifted so far to the red by the expansion of space that it appears as infrared light now, carries information from an era we can barely understand. The pale drift of this ancient light, travelling for 13 billion years, just to reach us, to show us the past, is like memory, like ancient memory, drifting through time, fading, but still present, still there. Thump, thump. If you look, if you remember, and you're forgetting now, drifting past memory, past light, past time, brown dwarves, those failed stars, some wander through space alone, ejected from binary systems or born in isolation. The haze around these wandering brown dwarves, clouds in their atmospheres, creates complex weather patterns, storms of molten iron rain, temperature variations from pole to equator, layers of different chemical compounds creating banded structures, like Jupiter, but dimmer, cooler. These objects, radiating mostly in infrared, are invisible to the naked eye, but through infrared telescopes, they appear hazy, indistinct, surrounded by their own heat, slowly radiating into the cold, like warmth radiating from your body now into the cool air, your temperature dropping, your metabolism slowing, everything cooling, heavier, heavier. In the far future, when all the stars have died, the universe will be dominated by superclusters, vast collections of galaxy clusters. But even these will fade as galaxies dim, as stars burn out. Eventually, the observable universe will contain only black holes and dim remnants. The dim flicker of this fading supercluster, this glimpse of the far future, is something we can model but never see. The universe will grow dark, cold, empty, over trillions upon trillions of years. But that's so far away, so impossibly distant, that it's like a dream, like your dreams now. Distant, impossible, fading before they form, dissolving into darkness. Neutrinos, nearly massless particles, were created in enormous numbers in the first moments of the Big Bang. These relic neutrinos, cooled by the expansion of space, drift through the universe. There are billions of them in every cubic meter of space, passing through you, through the Earth, through everything, without interaction. They carry no charge, barely interact with matter. The slow drift of these relic neutrinos, remnants from the birth of everything, is invisible, undetectable. They flow through you right now as you drift towards sleep, ghostly, ancient particles from the beginning of time, passing through, leaving no trace. Thump, thump, like thoughts, like moments, passing through, leaving nothing. Around young stars, disks of gas and dust orbit, protoplanetary disks where planets will eventually form. But these disks have gaps, cleared by forming planets. The quiet swirl of material in these gaps, where a planet is sweeping up debris, creating a clearing in the disk, happens slowly, over millions of years. The gas and dust, forced outward or inward by the planet's gravity, leaves a dark band, visible in high-resolution images. These gaps, these absences, these empty places, speak of something forming, something growing, something becoming. But all you see is the gap, the emptiness, the quiet space, like the quiet space in your mind now. Empty, becoming more empty, heavier, heavier, when galaxies collide, when they merge. Tidal streams form, long arcs of stars, pulled out from the galaxies by gravitational interactions. These streams, stretching across hundreds of thousands of light years, glow softly, starlight from stolen stars. The soft glow along these tidal streams marks the violence of galactic collision, but the glow itself is gentle, beautiful even, like fireworks reflected in water, the beauty of destruction, transformed by distance, by time, into something peaceful. The stars in these streams will eventually settle into the merged galaxy, finding new orbits, new homes, but for now, they drift along their tidal stream, homeless, unanchored, like you now, drifting, unanchored, cosmic voids. The largest structures in the universe are vast regions with very few galaxies. These voids, hundreds of millions of light years across, are not completely empty, but nearly so. The breathless calm inside these voids, where the galaxy density is less than 1/10 of the cosmic average, is profound. An observer inside a cosmic void would see galaxies only as faint smudges on the horizon, in every direction, but far away, very far away. The loneliness of such a place, the empty, silent vastness, is almost peaceful, almost like floating in sensory deprivation. No input, no stimulation, just being in the void. You're entering your own void now, a place of no stimulation, no thought, no sensation, just darkness, emptiness. Thump, thump, the void of sleep. The heliopause, the boundary of the sun's influence, is not a static surface, but a dynamic, shifting region. The solar wind pushes outward, the interstellar medium pushes back, the boundary between them, marked by a change in particle populations, moves in and out, responding to the solar cycle. The veil of particles near this boundary, mixing, colliding, creates a complex transition region, neither fully solar nor fully interstellar, a liminal space, a threshold between one realm and another, like the threshold you're on now, between waking and sleeping, neither one nor the other, balanced, teetering, ready to fall, heavier, heavier, crossing the boundary into the other side. From supermassive black holes, from the centers of active galaxies, jets of material shoot outward, near the speed of light. These jets, powered by the rotational energy of the black hole or by magnetic fields, extend for thousands, sometimes millions of light years. The gentle twist of these distant jets as they spiral through space, following magnetic field lines, creates helical patterns visible in radio images. The jets themselves, mostly empty space with a thin stream of high-energy particles, appear almost like smoke, like a distant chimney. The twist, the spiral, the gentle curve draws your eye, draws your attention, spiraling down, following the curve, around and around, deeper, deeper, heavier. In some regions of space, stars are forming at a rapid rate. Starburst regions, where conditions are right for many stars to ignite nearly simultaneously. The faint spark of these forming dwarf galaxies, small galaxies with intense star formation, glimmers in deep sky images. These galaxies, often irregular in shape, blue with the light of young hot stars, are factories of starlight. But even in these regions, the actual moment of star formation, when fusion begins in a collapsing core, is hidden, shrouded in dust. The spark happens in darkness, and only later, when the young star clears away its birth cloud, does the light escape, the hidden spark, the secret moment of ignition. Like the moment you can't quite remember when you fell into sleep. Thump, thump, matter falls into black holes, but slowly, spiraling inward in an accretion disk, heating up as it falls, emitting radiation. The long fall into a silent accretion disk around a supermassive black hole can take thousands of years as the material slowly spirals closer and closer, eventually crossing the event horizon, disappearing forever. During this fall, the matter glows, X-rays and ultraviolet light, making accretion disks some of the brightest objects in the universe. But from the perspective of the falling matter, the journey is peaceful, inevitable, just falling, always falling. Like you're falling now, slowly, inevitably, into sleep. The long fall, accepting, releasing, heavier, heavier. The solar wind, blowing outward from the sun, encounters planetary magnetospheres, creating complex interactions. The whisper of solar wind across Earth's magnetosphere, bending the magnetic field lines, compressing them on the day side, stretching them on the night side, creates currents and auroras and radiation belts. This whisper, this gentle but constant pressure, shapes the environment around every planet with a magnetic field, protecting some, eroding the atmospheres of others. The whisper, barely there, but persistent, like white noise, like ocean waves, like the sound of your own breathing, constant, fading, becoming background, becoming nothing. Just whisper, just sound, just breath. Asteroids in space, orbiting the sun, bombarded by solar wind, by cosmic rays, by micrometeoroids, slowly erode. The patient erosion of an asteroid's surface, weathering its rocks, darkening its surface, Takes millions of years. The surface changes, slowly, imperceptibly. Atoms knocked away one by one. The patience of this process, the slowness, reflects the timelessness of space. Nothing hurries, nothing rushes. Everything happens in its own time, like sleep, coming in its own time, not forced, not rushed, just arriving when it arrives, heavier, heavier, patient, inevitable. Asteroids in space, orbiting the sun, bombarded by solar wind, by cosmic rays, by micrometeoroids, slowly erode. The patient erosion of an asteroid surface, weathering its rocks, darkening its surface, takes millions of years. The surface changes, slowly, imperceptibly. Atoms knocked away one by one. The patience of this process, the slowness, reflects the timelessness of space. Nothing hurries, nothing rushes. Everything happens in its own time, like sleep, coming in its own time, not forced, not rushed, just arriving when it arrives, heavier, heavier, patient, inevitable. On Saturn's moon Titan, beneath an orange haze atmosphere, there are lakes, but not of water, of liquid methane and ethane. These frozen methane lakes, under alien twilight, reflect the dim sunlight filtered through Titan's thick atmosphere, creating a landscape both familiar and utterly strange. Lakes, shores, islands, but made of materials that would be gas on Earth, existing because Titan is so cold, so far from the sun, that methane is liquid, the twilight there perpetual. The sun appearing only as a bright spot through the haze creates a mood, melancholy, quiet, like dusk that never ends, like the twilight of consciousness, the dimming, the fading of awareness into sleep. Thump, thump, dark energy, the mysterious force accelerating the expansion of the universe, forms an invisible lattice, not physical, but geometric, woven into the fabric of space itself. This lattice, if we could see it, would show space itself, stretching, pulling, growing, in all directions at once. The invisible lattice of dark energy accounts for 68% of all energy in the universe. Yet, we don't know what it is, only what it does. It pushes, gently, but relentlessly, making the universe expand faster and faster. Everything moving apart, galaxies receding, space growing, like your thoughts, moving apart, losing connection, expanding into nothing, heavier, heavier, in stable orbits, sharing their paths with larger planets, are Trojan asteroids, trapped at the Lagrange points, where gravitational forces balance. These asteroids, leading and trailing Jupiter and Neptune and other planets, perform a slow waltz, orbiting the Sun, while also orbiting the Lagrange point in a complex choreography. The dance is eternal, stable for billions of years. Unless disturbed by outside forces, they drift in formation, never leaving their designated space, forever trapped, but peacefully so, in a region of perfect balance. like balance. In your body now, everything finding its level, its stable point, its place of rest, drifting in formation with your breath, your heartbeat, everything synchronized, heavier. When two neutron stars collide, when they merge, they create something called a kilonova, an explosion, releasing gold, platinum, heavy elements, forged in that instant of collision. The distant lantern of this kilonova afterglow, fading over weeks and months, glows in infrared, in optical light, in radio waves, painting a picture of cosmic alchemy from Earth, billions of light years away. We watch this lantern, this distant signal, growing dimmer, dimmer, like a candle in a window, seen from miles away, slowly going out. The glow, orange and red, fading to darkness, like your thoughts, like the light behind your eyes, fading, going out, heavier, heavier, thump, thump, the lantern dims, and you dim with it, drifting into darkness. The sun's heliosphere, that bubble of solar wind pressing against the interstellar medium, has a boundary, thin, delicate. The thin membrane of this heliosphere boundary, separating what is solar from what is interstellar, flexes and moves, breathing with the solar cycle. When the sun is active, the boundary expands. When quiet, it contracts. This membrane, invisible, intangible, marks a threshold, like skin, separating inside from outside, self from other. The membrane, so thin, barely there, but crucial, essential, like the membrane between waking and sleeping, so thin now, so permeable, thoughts leaking through, awareness seeping out, the boundary dissolving, thinning, until there's no separation, no inside or outside, just one continuous darkness, heavier, heavier. There are moons orbiting too close to their planets, inside what's called the Roche limit, where tidal forces exceed the moon's own gravity. The slow tide that tears a moon apart pulls harder on the near side than the far side, stretching, deforming, eventually over millions of years. The moon breaks, becomes a ring, particles orbiting individually, the tide pulling, relentless, patient, inevitable, like sleep pulling at you now, gentle but insistent. You can resist for a while, but the tide always wins, always pulls you apart, dissolves you into separate pieces, separate thoughts, separate moments, until you're no longer one thing, but many or nothing, just particles orbiting in the dark. Thump, thump. The tide pulls and you surrender, heavier. In the early universe, in the moments after the Big Bang, tiny black holes may have formed. Primordial black holes, smaller than atoms. Some of them, these black holes, if they exist, would be evaporating now through Hawking radiation, slowly, over billions of years. The ghost light of these annihilating primordial black holes, so faint, so rare, has never been detected, but if one evaporated nearby, in the final moment, it would release a burst of gamma rays, a flash, then nothing. The ghost light from something that may not even exist, from a theory, from mathematics, is like the light of memories that may never have been real, flickering in the darkness of sleep. False memories, dream memories, ghost memories, appearing, then vanishing, leaving no trace. Heavier, heavier. The ghosts flicker and fade, and you fade with them. Jupiter, with its powerful magnetic field, creates radio storms, bursts of radio waves, triggered by the moon Io, by the interaction of Jupiter's magnetosphere with the solar wind. These storms, inaudible to human ears, but detectable with radio telescopes, sound like static, like interference. The soft static of these Jovian radio storms, crackling across millions of miles, is the sound of a planet, breathing in radio frequencies. The static, chaotic, unpredictable, but somehow soothing, like white noise, like rain on a roof, like the static between stations, between thoughts, between moments of consciousness. The static grows, fills everything, until all you hear, all you feel is static, soft, enveloping, pulling you under, thump, thump, heavier, on Titan, Saturn's largest moon, beneath the surface, beneath the dunes of hydrocarbon sand. There may be caves, caverns formed in water ice, by some ancient process, now hidden, sealed. The crystalline caves beneath Titan's dunes, if they exist, would be lined with ice, not water ice alone, but mixed with ammonia, with methane, creating structures, alien, beautiful, untouched by any light, for billions of years. In these caves, if you could visit, you'd find silence, absolute, no wind, no sound, no movement, just crystals, growing slowly, molecule by molecule, in the dark, in the cold, forever. The caves, waiting, in darkness, like the caves of your unconscious mind. Deep structures, hidden, where dreams form, where memories hide. Everything, crystalline, everything, preserved, everything, sleeping, heavier, heavier. Brown dwarfs, those failed stars, sometimes have auroras, created by charged particles, interacting with their magnetic fields, just like Earth's auroras, but different. The faint blush of aurorae on a brown dwarf, glowing in infrared, in wavelengths invisible to human eyes, creates bands of light around the poles of these dim objects. The blush, barely there, fainter than anything you could imagine, marks the presence of magnetic fields, of charged particles, of processes continuing, even on a star that failed to ignite. The blush, like the flush of blood in your cheeks, fading now as your circulation slows, as your body cools, preparing for sleep, everything blushing, then fading, then cooling, then still, thump, thump, heavier. Every star has a lifetime, Stars like the sun burn for 10 billion years, then begin to die. The long goodbye of a retiring main sequence star takes millions of years. First, the star swells, becoming a red giant, consuming its inner planets. Then, it sheds its outer layers, creating a planetary nebula. Finally, only the core remains, a white dwarf, cooling forever. The goodbye, so long, so gradual, that you'd never notice it, watching for a human lifetime. But it's happening, always happening. Stars are always in some stage of their goodbye. Like consciousness, always in some stage of letting go, each night rehearsing the final goodbye that will come someday, but not tonight. Tonight is just practice, just temporary, just sleep. Heavier, heavier. The star says goodbye, and you say goodbye to waking. When galaxies collide, when they pass through each other, the dance is choreographed by gravity, by dark matter, by mathematics. The hidden choreography of galactic collisions, invisible when watching a single moment, becomes clear when simulated, when time is compressed. The galaxies approach, intertwine, separate, return, merge. Their stars rarely collide. Space is too empty, but their shapes deform, stretch, create tidal tails, spiral arms, disrupted structures. The choreography, complex, beautiful, violent and graceful, all at once, takes hundreds of millions of years to complete. Like the choreography of your breath, your heartbeat, your brain waves as you fall asleep. Everything synchronized, everything dancing to rhythms you don't control, don't choose, just follow. Thump, thump, heavier. The dance continues without you as you drift away in the far future. In trillions upon trillions of years, the universe will approach heat death. All stars will have burned out, all black holes evaporated, all matter decayed. The breathless stillness at the universe's heat death horizon, a state of maximum entropy, when nothing changes, nothing moves, nothing happens ever again, is the ultimate silence, the ultimate peace. Nothing left to do, nothing left to be, just existence, without event, without time, without meaning. That stillness, that final stillness, is so far away, so impossibly distant, that it's like the stillness of sleep, which seems eternal when you're in it, but is really just temporary, just a pause before waking. But for now, it feels eternal, the stillness spreading through your body, through your mind, heavier, heavier, breathless, still. Some stars explode as supernovae, but aren't massive enough to leave behind a black hole. Instead, they leave a neutron star incredibly dense, spinning rapidly. These stellar remnants, no larger than a city, contain more mass than the sun, the weight of 1 billion elephants compressed into a sugar cube. That density, that impossible compression, creates strange physics, strange states of matter, everything pressed together so tight that atoms themselves collapse, like your thoughts compressed in sleep, losing detail, losing separation, pressing together into single, simple, dense feelings, heavy, so heavy, compressed, until there's no space left between anything, everything, touching everything else. No boundaries, no separation, just density, just weight pulling down, down, heavier, heavier, thump, thump. In some planetary nebulae, in the expelled shells of dying stars, there are knots, dense clumps of gas. These knots, shaped by magnetic fields, by stellar wind, by turbulence, create intricate structures, like tangled thread, like rope, coiled and twisted. The knots, moving outward with the expanding nebula, slowly untangle or tighten further over thousands of years, like the knots in your muscles, in your shoulders, in your jaw, slowly untangling now, loosening, releasing as you sink deeper. The tension, held for so long, finally letting go. The knots in space, in your body, in your mind, all loosening, dissolving, becoming smooth, becoming soft, heavier, heavier. There are asteroids in the asteroid belt that are binary, 2 asteroids orbiting each other. Their mutual orbit, their shared center of mass, creates a system where neither is primary, neither is moon. They're equals, partners, circling each other for billions of years. The partnership, stable, eternal, predictable, like breath and heartbeat, circling each other in your body, neither leading, neither following, just synchronized, just there, together. The asteroids circle, and your breath and heartbeat circle, slower now, wider orbits, longer periods, until the orbit is so slow, so wide, that it's almost, not moving, almost, still, thump, thump, heavier, circle, and still, and sleep. Comets, when they approach the sun, heat up. Gas erupts from their surfaces, jets of vapor, creating the coma, the atmosphere around the nucleus. These jets, triggered by sunlight, by rotation, by the comet's composition, shoot outward, then slow, then drift, like breath, like sighs, like the sigh you take now, releasing, releasing. The comet sighs, vapor into space, and you sigh, tension into air, everything, releasing, everything, evaporating, lighter, but somehow heavier. The paradox of letting go, feeling lighter and heavier at once. Thump, thump. The comet drifts, and you drift. Both. Lighter. Both. Heavier. Both. Free. In deep space. Far from any star. Particles of interstellar dust collide occasionally. When they do, they sometimes stick, building larger grains. The slow accretion, over millions of years, creates pebbles, then rocks, then asteroids. Everything built from nothing, from random collisions, from patience, from time, like memories accumulating, grain by grain, moment by moment, building into something. But in sleep, the process reverses. Memories fragmenting, breaking apart, dust scattering, until there's nothing left. Just dust drifting, separate, alone, heavier, heavier, everything breaking down, returning to dust, to emptiness, to peace. Some planets in other star systems orbit backward, retrograde orbits, going the opposite direction from their star's rotation. These worlds, disturbed sometime in their past by gravitational interactions, by collisions, now move against the flow, different, isolated, alone in their motion, like a thought, moving against the current of sleep, trying to stay awake, trying to hold on. But the current is strong, too strong. Eventually, even retrograde thoughts slow, stop, reverse, and join the flow towards sleep, toward darkness, toward nothing. The backward planet orbits alone, but it orbits nonetheless, pulled by gravity, by inevitability, by forces too strong to resist. Thump, thump, heavier. You stop resisting and join the flow. Gas giants, like Jupiter and Saturn, have zones and belts, bands of clouds, moving in opposite directions. The shear between these bands creates vortices, storms, eddies, everything, turbulent, chaotic. But from a distance, from far enough away, the chaos looks peaceful, organized, beautiful, like thoughts, turbulent up close, chaotic, stormy. But from the distance of sleep, from far enough away, they're just patterns, just colours, just beautiful. The chaos softening with distance, with perspective, with drowsiness, everything becoming simpler, prettier, quieter as you drift farther away, heavier, heavier. The storms still raging, but silent now, distant now, beautiful and irrelevant. In nebulae, in the clouds where stars are born, there are Bok globules, small dark clouds, dense, opaque. These globules, blocking the light from stars behind them, appear as dark spots in glowing nebulae. Inside these globules, in the darkness, stars are forming, or will form, eventually. The darkness, pregnant with potential, with future light, is like sleep, dark, but not empty, not nothing, but everything, waiting, ready to become something when morning comes. But for now, just dark, just potential, just waiting. Thump, thump, heavier. The globule floats, dark and dense, and you float, dark and dense, both waiting, both ready, both still. Exoplanets, thousands of them discovered now, come in varieties as we never imagined. Hot Jupiters, super Earths, mini Neptunes, worlds of lava, worlds of diamond, worlds of water, worlds of iron. The diversity, the strangeness, the impossibilities of these worlds expands our understanding, but also makes us sleepy. So many worlds, so many possibilities, too many to hold in one mind. The information overflowing, spilling out of consciousness into dreams where it can be anything, everything, nothing, heavier, heavier, so many worlds, and you're leaving this one, drifting to another, in dreams, in sleep, thump, thump, and now you're drifting between sections, between thoughts, between moments, everything flowing like water, like time, like consciousness itself. The space between part 2 and part 3 is like the space between heartbeats, between breaths, between moments of being empty but full, silent but speaking, dark but somehow lit from within, heavier, heavier, thump, thump. You're in the between, the transition, the threshold, and on the other side, waiting, is deeper sleep, deeper darkness, deeper peace. Let's drift there now, together, through the threshold, into part 3, heavier, heavier, drifting, always drifting, on planets tidally locked to their stars. One side always faces the star, the other always dark. Between these extremes, at the terminator, the boundary between day and night, there is a region of eternal twilight, the heat shimmer above this tidally locked world, where hot air from the day side meets cold air from the night side, creates perpetual storms, winds that never stop, the shimmer, the distortion, the boundary between, like the boundary you're crossing now, between states, between waking and sleeping, wavering, shimmering, then settling into one side, the dark side, the sleeping side, heavier, heavier, thump, thump. Some moons in the outer solar system have no atmosphere, their surfaces exposed directly to space. Occasionally, a micrometeoroid impacts, vaporizing a tiny bit of surface material, creating a momentary puff of gas. On some moons, like Europa or Enceladus, ice sublimates directly into space, creating the faintest hint, the faint scent of ozone, of water vapor. But there's no one there to smell it, no one to notice, just molecules escaping into vacuum, drifting away, joining the thin exosphere, then escaping entirely into interplanetary space, like thoughts escaping, drifting away, leaving your mind evaporating into nothing. The moon, Earth's moon, is geologically active, even though it appears dead. Deep beneath the surface, in the regolith, moonquakes occur, caused by tidal stresses from Earth, by thermal expansion and contraction, by the slow cooling of the lunar interior. The tremor of these moonquake, too subtle to feel on the surface, propagates through the solid moon, ringing it like a bell for hours after each quake. That subtle tremor, that barely there vibration, deep beneath a lifeless surface, is like the processes of your sleeping body, subtle, unconscious, continuing while you're unaware. Everything still moving, still processing, deep beneath, awareness Thump, thump. Comets have tails, 2 of them. A dust tail that curves, following the comet's orbit, and an ion tail, made of charged particles, that always points directly away from the sun. The silver thread of this ion tail, glowing blue from charged carbon monoxide and water, stretches millions of miles behind the comet, but it's so tenuous, so thin, that you could fly through it and barely notice, like spider silk, visible only when light catches it, otherwise invisible, barely there. The thread, stretching, thinning, like consciousness, stretching thinner, thinner, until it's barely there at all. On Mars, beneath the surface, there are lava tubes, caves formed by ancient volcanic activity. Inside these tubes, it's silent, dark, unchanged for millions of years. The hush inside these Martian caves, protected from radiation, from meteorites, from the thin atmosphere, is total, complete. No wind reaches there, no sound, no light, just darkness and stillness, and the slow, slow accumulation of dust, settling over epochs. That hush, you can feel it now, in your own inner space, the quiet growing, deeper, more complete, heavier, heavier, until there's nothing but hush. In the rings of Saturn, some particles are made of water ice, coated in organic molecules. When sunlight hits these particles, some wavelengths are absorbed, others scattered, creating the colors we see. But there's something else. Some ring particles contain tritium, radioactive hydrogen, created by cosmic ray impacts. This tritium, decaying with a half-life of 12 years, glows faintly, imperceptibly, with beta radiation. The glow of tritium in those ring particles, invisible, undetectable except by instrumentation, is like the glow of metabolism in your cells, continuing even as you sleep, energy being released, slowly, constantly, invisibly, keeping you alive, keeping you warm while you drift away from knowing. Thump, thump. Around some massive star, the intense radiation and stellar wind pushes on the surrounding interstellar medium, creating bubbles hundreds of light years across. Inside these bubbles, the gas is hot, tenuous, almost empty. The slow bloom of these interstellar bubbles, expanding at speeds of tens of kilometers per second, which seems fast, but on these scales is incredibly slow, takes millions of years, like a flower opening, in extreme slow motion. The bloom, the expansion, the growth, happening, but imperceptibly, like your awareness, slowly blooming into dreams, expanding, but so slowly you don't notice the transition from waking to sleeping. Heavier, heavier. Carbon planets, theoretical worlds with more carbon than oxygen, would have mantles made of diamond, graphite, silicon carbide, instead of the silicates we know. The cold fire of these carbon planets, their interiors, under immense pressure, forming crystalline structures, glowing only with internal heat, would be invisible from outside. These worlds, if they exist, would be so different from anything we know that they seem almost magical, like dreams, constructed from different rules, different physics, different logic. The cold fire, burning but not consuming, glowing but not warming, like the fire of imagination in your sleeping mind. Burning cold, burning dark, heavier, gamma ray bursts, the brightest events in the universe, release more energy in seconds than the sun will release in its entire lifetime. These bursts, caused by collapsing massive stars or colliding neutron stars, send out beams of gamma rays that travel across the universe. The echo of these bursts, arriving at Earth after traveling billions of years, is detectable only by satellite instruments. By the time it reaches us, the fury has faded, become just an echo, a memory of violence, translated by distance into something almost peaceful. The echo, fading, like anger fading, like intensity fading, everything fading, with distance, with time, into quiet, into calm. Thump, thump. Some asteroids travel in resonant orbits. Their orbital period a simple ratio of another object's period. These resonances, like musical intervals, create patterns, the silent shepherding of these resonant orbits. The way Neptune's gravity organizes the Kuiper belt, creating gaps and concentrations, is like an invisible hand arranging things. The pattern emerging from chaos, from random gravitational interactions, becomes order, becomes structure, becomes predictable. Like you're breathing now, falling into a pattern, a rhythm, without effort, without thought, just resonating with the natural frequency of rest. Heavier, heavier. Pluto and other Plutonos, objects in orbital resonance with Neptune, have night sides that never see the sun. For months at a time, as they orbit, one hemisphere is in constant darkness. On these night sides, frost feathers form, nitrogen ice, methane ice, carbon monoxide ice, crystallizing in the cold, forming delicate structures, branching, fractal, beautiful, and utterly alone in the dark, unseen. The frost forming in darkness, in silence, in cold beyond imagination, is like thoughts forming in the darkness of sleep, crystallizing into dreams, patterns forming, dissolving, reforming, all in the dark, all unseen. Thump, thump, beneath Europa's icy surface, beneath the cracked shell, there is an ocean, liquid water, kept warm by tidal heating from Jupiter. This hidden ocean, containing more water than all of Earth's oceans combined, has been isolated from the surface, from space, from the sun, for billions of years. What exists there, in that dark, warm ocean, no one knows. The hidden ocean, the secret sea, beneath miles of ice, is like the unconscious mind, deep, dark, containing more than you know, more than you can access, everything hidden, everything flowing, in darkness, in warmth, beneath the frozen surface of waking life, heavier, heavier, on Shield Volcano, on Mar, on Io, on other worlds. Micrometeorites rain down constantly, each impact tiny, insignificant individually, hits the surface. The soft rain of these micrometeorites over millions of years erodes even the hardest rock, creating the weathered, ancient surfaces we see. That soft rain, barely noticeable, but constant, relentless, is like time itself, wearing everything down, smoothing everything. Eventually, even mountains become plains, even sharp memories become smooth, vague, forgotten, everything worn by time, by patience, by the soft, constant rain of moments. Heavier, Cepheid variable stars pulsate, brightening and dimming with clockwork regularity. The distant heartbeat of these stars, beating once every few days or weeks, serves as a cosmic measuring stick. Their brightness variations, so regular, so predictable, allow us to measure distances to nearby galaxies. That heartbeat, thump, thump, echoing across light years, reaches us, faint but steady, like your own heartbeat, steady, regular, slowing as you sink deeper, everything pulsing in rhythm with the cosmos. Thump, thump, slower now, quieter, fading, but still there, still pulsing, still beating, around some stars, around some black holes. Magnetic fields trap plasma, creating loops, arcs, structures held in place by invisible forces. The thin cry of this plasma, heated to millions of degrees, emitting X-rays, is like a scream, but so high-pitched, so beyond human hearing, that it becomes silence again. Just energy, just radiation, just mathematics. The cry, trapped, going nowhere, just circling in magnetic loops until it finally escapes, or cools, or fades, like worries, trapped, circling in your mind until you finally let them go, release them into the night, into sleep, heavier, heavier, thump, thump. Red giant stars, old star, swollen and cool, slowly exhale their outer layers, creating planetary nebula. The slow exhale of these dying stars, releasing material that will seed the next generation, takes thousands of years, like breathing out forever. The material drifts away, glowing, creating these beautiful, symmetrical nebulae, shells of gas, expanding, thinning, eventually mixing with the interstellar medium, disappearing. That slow exhale, releasing, letting go, is like the exhale you're taking now, releasing, releasing everything, letting go of the day, of tension, of consciousness, just breathing out and not bothering to breathe back in. Heavier, neutron stars, as with their incredible density, have crusts. The outer layer just below the surface is solid, made of atomic nuclei arranged in crystalline lattices. This crystalline song, if you could hear it, would be the vibration of the crust, ringing from starquakes when the crust cracks under intense magnetic stress. The frequencies too high for human hearing, but they're nonetheless mathematical, perfect, the crystal singing as it breaks, as it reforms, as stress releases, like your own body releasing stress, muscles finally letting go, everything crystalline, everything structured, dissolving into chaos, into randomness, into sleep. Thump, thump. At the center of globular clusters, ancient spherical collections of stars orbiting galaxies, the stars are packed densely, separated by light weeks instead of light years. The velvet darkness inside these cores, between the stars, is not truly dark, illuminated by the combined light of 1,000,000 suns. But to our eyes, from Earth, looking at these clusters, we see only a bright, fuzzy ball. The darkness inside, the space between, hidden by glare, is like the space between thoughts, between moments, hidden by the brightness of awareness, but becoming visible now as awareness dims, as the brightness fades, revealing the velvet darkness beneath, heavier. At certain points in space, at Lagrange points, gravitational forces balance perfectly. An object placed at a Lagrange point will stay there, requiring no fuel, no energy, just staying. The gentle tug holding it is the equilibrium of forces, sun and earth pulling equally, creating a point of stillness in the motion of the solar system. That gentle tug, that balance, that perfect point of rest is where you are now, balanced between waking and sleeping, between thought and no thought, between being and not being, just balanced, still, at rest, heavier, heavier, thump, thump. Inside some stars, in a moment of crisis, when the core contracts suddenly, helium fusion ignites explosively. This helium flash, releasing enormous energy in seconds, happens deep inside the star, invisible from outside. The pale fire of this event, seen only in computer models, in calculations, affects the star's evolution, but invisibly, without the flash, the star would die differently, but no one watching would know. The flash happens in darkness, in the deep, in the hidden places where fusion occurs, like insights occurring in sleep, in dreams, processing, happening, in darkness, in depths you'll never see, never remember, but that change you, nonetheless, heavier. The Oort cloud, a theoretical cloud of comets, surrounds the solar system, a spherical shell, beginning far beyond Pluto and extending halfway to the nearest star. The drifting archipelago of these distant bodies, trillions of them, perhaps, moving in slow orbits, taking millions of years to complete, represents the outermost boundary of the Sun's family. These bodies, dark, frozen, separated by enormous distances, drift in silence. Occasionally, one is disturbed, falls inward, becoming a comet, but most just drift forever in the dark, at the edge, forgotten, like old memories, drifting at the edges of sleep, occasionally surfacing, but mostly forgotten, drifting heavier. Thump, thump. When galaxies collide, when a small galaxy passes through a larger one, tidal forces can rip the smaller galaxy apart. The quiet unraveling of these disrupted galaxies, their stars flung out into intergalactic space, creates streams, tidal tails, structures that trace the violence of the encounter. But the violence is slow, graceful even, over millions of years. The unraveling, the dissolution, the loss of structure is like dissolution of self in sleep. The boundaries blur, the structure loosens. What was coherent becomes scattered, distributed, no longer one thing, but many, or nothing, just dissolving, heavier, heavier, near black holes, near neutron stars. Space-time curves so severely that light bends, creating optical distortions. The shimmer of birefringence in this warped space-time creates multiple images, gravitational lensing, light following curved paths. What should be straight becomes curved. What should be single becomes multiple. Reality itself, distorted by gravity, by mass, by the curvature of everything, like perception, distorted as you fall asleep. Things seeming multiple when they're single, or single when they're multiple. Time stretching, contracting, space bending, nothing quite real anymore. Heavier, inside massive stars. In their final moments, elements are created. The cold forge where elements are born is actually hot, unimaginably hot, but cold compared to what it was. The star collapses, rebounds, explodes, and in that instant, in the shock wave, in the heat and pressure, nuclei fuse, creating gold, uranium, platinum, all the heavy elements forged in death, scattered into space. The forge, operating for seconds or less, creates everything necessary for life, for planets, for you. The atoms in your body, forged in stellar death, returning now to rest, to stillness, to peace. Thump, thump, heavier, as matter spirals into black holes, into neutron stars. It accelerates, heats, emits radiation. The silent scream of this in falling gas, heated to millions of degrees, releasing X-rays and gamma rays, is the sound of matter meeting its end, crossing the point of no return. But the scream is silent, in space, no medium as to carry sound, just light, just radiation, just energy. The scream expressing nothing, heard by no one, meaning nothing, like the thoughts trying to form in your drowsy mind, expressing less and less, meaning less and less, becoming just noise, just static, just silence. Heavier, in molecular clouds, in the densest regions where stars will form, there are organic molecules, PAS, polycyclic aromatic hydrocarbons, complex carbon molecules. These molecules, the faint perfume of space, absorb ultraviolet light and re-emit it in infrared, creating a glow in the dark clouds, the perfume invisible, unsmellable in vacuum, but they're nonetheless drifting, mixing, becoming part of new stars, new planets, perhaps new life. That faint perfume of creation, of chemistry, of complexity, arising from simplicity, is like dreams, arising from the chemistry of sleep, from neurons, firing, creating something from nothing. Heavier, heavier. Some binary stars orbit so close, their surfaces touch, contact binaries, where two stars share an atmosphere, orbit each other in hours, the slow pirouette, slow only compared to thought, not to other stellar processes, creates a peanut-shaped system, neither star-independent, but merged, combined, into one system. The dance so close, so intimate, that separation is impossible. They'll either merge completely, eventually, or continue in this contact forever, like body and mind, separate, but not, touching, inseparable, in sleep, everything, merging, boundaries dissolving, until you can't tell what's you and what's dream. Thump, thump on super-Earths, planets larger than Earth but smaller than Neptune, with deep oceans. The sky reflects in the water, creating a mirrored sky. On a calm day, on such a world, if there were days, the ocean would reflect clouds, stars, moons, perfectly, creating a sense of floating between two skies, between earth and heaven, between the mirror, perfect, seamless, above and below, the same, like the state you're in now, between waking and sleeping, where both are the same, where neither exists, just floating between mirrors, heavier, heavier, everything reflected, everything doubled, then fading. Some star ejected from their galaxies by gravitational interactions, by supernova explosions, by encounters with black holes, travel through intergalactic space, alone. The lonely vigil of these hypervelocity stars, moving faster than escape velocity, taking them out of the galaxy, into the void between galaxies, is a journey with no return. They'll travel for billions of years through nearly empty space, growing more and more isolated. Eventually, their galaxy of origin will be too far away to see, and they'll be truly alone in the dark between everything, like a thought escaping from your mind, drifting into nothing, never to return, heavier, heavier, gone. When a supernova explodes, the shock wave travels outward, compressing the interstellar medium, triggering new star formation. The soft bruise of this shock wave, marked by glowing gas, by regions of compression, spreads across light years. Like dropping a stone in water, the ripple spreads forever, growing fainter, but never quite stopping. That soft bruise, that mark left behind by violence, becomes, over time, beautiful. A ring, a shell of glowing gas, the mark of ending, becoming, the cause of beginning, everything, cycling, everything, returning, like consciousness, ending each night to begin again each morning, but for now, ending heavier. Thump, thump. Dark matter flowing through space forms streams, rivers of invisible mass flowing along the cosmic web. The hidden rivers of these dark matter streams pull on galaxies, affect their motion, but remain invisible, undetectable. We know they're there only through their effects, like knowing wind. Only by seeing leaves move, the streams flow and have been flowing since the universe was young, ancient, constant, invisible, like the streams of unconscious thought in your sleeping mind, flowing, affecting your dreams, but invisible, unremembered, heavier. In the Kuiper belt, some objects are shaped oddly, tilted strangely. Their surfaces, cliffs of water ice, methane ice, towering thousands of feet high. The frostbitten cliffs of these distant worlds, never seeing sunlight, not real sunlight, only starlight, stand eternal, unchanging, sublime in their isolation. The cliffs, carved perhaps by ancient impacts or by outgassing or by tidal forces, remain frozen, no erosion, no weather to speak of, just standing forever, like monuments to nothing, like thoughts frozen at the edge of sleep, standing meaningless, but somehow important, heavier. Some quasars, quiet now, dormant, will wake again when new material falls into their central black holes. The slow awakening of these dormant quasars over millions of years as gas slowly accumulates and finally begins falling inward, reignites the engine of radiation, of jets, of brightness. But for now, dormant, sleeping, quiet, like you, will wake eventually. But for now, sleeping, quiet, the quasar dreams, perhaps of the matter it will consume, of the light it will emit. But for now, nothing. Just darkness. Just waiting. Heavier, heavier. Thump, thump. When a galaxy passes too close to another, a larger one, tidal forces can strip away its outer stars, its gas, leaving behind only the core. The quiet morning of this stripped galactic core, a galaxy reduced, diminished, stripped of its ability to form new stars, continues to orbit, a ghost of what it was, everything taken by tidal forces, by gravity, by violence made slow. The core, all that remains, orbiting in silence, mourning, perhaps, or simply being without memory, without longing, just existing, diminished, quiet, like consciousness, diminished, stripped, reduced to its core, which is nothing, or everything, or sleep, heavier, exoplanets, planets orbiting other stars, are rich in iron, their cores enormous, their crusts metallic. The trembling crust of these iron-rich worlds, responding to their star's magnetic field, to tidal forces from other planets creates, if there were anyone to hear it, a low hum, a vibration, felt more than heard, the planet trembling constantly, like a bell, continuously struck, but so gently, so subtly, that the vibration is almost nothing, almost stillness, almost silence, like your body trembling at the edge of sleep, muscles releasing, relaxing, trembling with the effort of letting go until finally, they stop and there's only stillness, only silence, only sleep. Thump, thump, thump. The universe keeps turning, and the silent vastness of space will hold us, and we'll keep drifting, floating together through the mysteries, 100 space mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the hidden world, drifting in the void that astronomers swear should exist, but can't quite prove. The faint cosmic murmur that behaves like a star but refuses to shine like one. The invisible tension stretching space so fiercely that it's quietly reshaping the universe itself. And we'll keep drifting, floating together through the mysteries, heavier, heavier, thump, thump, into the calm, the quiet, the dark. Drifting, always drifting through space, through sleep, through the endless night. And we'll keep drifting, floating together through the mysteries, 100 universe mysteries, looping softly, endlessly through the night. Tonight we'll drift through the instant the universe sparked from nothing and rewrote reality, the secret cosmic scaffolding that shapes every galaxy you've ever seen, the hidden forces guiding the universe toward a fate no one can yet predict. There's nothing you need to do now. Just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into universe. In the beginning, there was darkness, perfect, absolute, complete, and then something happened. Something that defies explanation. 13.8 billion years ago, the universe began, not in a place, because there was no place, not at a time, because there was no time, just a beginning. Feel your chest rising, falling, like the universe itself, breathing, expanding, contracting with each breath you take. That first moment, that cosmic dawn, wasn't an explosion into space. It was space itself, being born, unfolding like a flower, but in every direction at once. The fabric of reality, weaving itself from pure mathematics, pure energy, pure possibility. Let your eyelids grow heavy, heavier, but They're being pulled by something ancient, something cosmic, something that knows you need to rest. Imagine that first fraction of a second, a trillionth of a trillionth of a trillionth of a second. In that impossible instant, the universe was smaller than an atom, hotter than anything, denser than anything, filled with pure energy, no particles, no matter, just raw, undifferentiated potential. Your breath slowing now. Thump, thump. Your heart finding its rhythm, the rhythm of cosmic time, of deep time, of endless time. And then it expanded, not into anything, because there was no into. It created space as it went, stretching, growing, cooling. In the first second, the universe grew from smaller than a proton to larger than our solar system. Imagine that. All of existence doubling and doubling and doubling again, faster than light, because it wasn't moving through space. It was space itself, expanding. Sink deeper into the pillow, into the mattress. Let gravity hold you. The same gravity that holds galaxies together. The same force that was born in those first moments. Within the first 3 minutes, the universe had cooled enough for something remarkable to happen. The first atoms began to form. Hydrogen, simple, elegant, one proton, one electron, the most abundant element in the cosmos, and helium, slightly more complex, 2 protons, 2 neutrons, 2 electrons. These atoms, forged in the cooling fire of the Big Bang, would one day become stars, planets, oceans. You, your breath barely noticeable now, soft, shallow, gentle, like cosmic wind through empty space. Think about those hydrogen atoms floating in the darkness. The universe was still opaque then, filled with plasma. Light couldn't travel, couldn't escape, trapped in an infinite fog. For 300,000 years, the cosmos was blind, invisible to itself, just energy and matter mixed together, cooling, waiting, your muscles releasing, one by one, starting at your scalp, melting down, your forehead smoothing, temples softening, eyebrows releasing, eyelids heavy, so heavy. And then the universe became transparent. As it cooled below 3,000 degrees, electrons and protons combined, formed neutral atoms, and light, for the first time, could travel freely. This moment, called recombination, was the universe's first dawn. The cosmic microwave background, that afterglow, still fills space today, stretched by expansion, cooled to just 3 degrees above absolute zero, but still there, still traveling, still carrying information from that ancient moment. Eyes closed now, or closing. Doesn't matter. Just let them rest. Let them surrender to the darkness, to the peace, to the deep, endless, quiet. The expansion, it never stopped. Even now, tonight, as you lie here, feeling your body heavy against the mattress, the universe is stretching. Galaxies are drifting apart, pulled by forces we're only beginning to understand. Space itself, growing, like a breath that never ends. an exhalation lasting billions of years, your jaw releasing, teeth no longer touching, tongue resting soft in the bottom of your mouth, everything letting go, everything surrendering. This expansion, it's not like an explosion, it's more like raisin bread rising, the raisins, the galaxies moving apart, not because they're flying through the dough, but because the dough itself, the fabric of space, is expanding every point, moving away from every other point. The universe has no center, no edge. Every location is the center. From its own perspective, heavier, heavier, your body sinking, merging with the bed, becoming part of the room, part of the building, part of the earth, part of space. Between galaxies, there is silence, deep, profound, unbroken, absolute. These voids, these cosmic deserts, stretch for hundreds of millions of light years. If you could stand in one, in the middle of nowhere, you might see a handful of distant galaxies, faint smudges on the edge of darkness, but mostly just emptiness, just space, expanding forever. Breathe in, slowly, counting to 4. 1, 2, 3, 4. Breathe out, slower still, counting to 6. 1, 2, 3, 4, 5, 6. Each exhale, taking you deeper. Imagine drifting through one of these voids. No stars, no planets, no dust, nothing. Just you and space and time, flowing like a river. You wouldn't feel motion. There's nothing to move past, just existence, pure, simple, empty. The universe at its most fundamental, space, time, and silence. Your shoulders melting down into the bed, chest softening, ribs expanding, contracting, expanding. The rhythm of breath, the rhythm of the cosmos, the same rhythm. But these voids aren't truly empty. They're filled with something invisible, something mysterious, something we call dark matter. It doesn't emit light, doesn't absorb light, doesn't interact with light at all. We only know it's there because of its gravity, its pull. It's influenced on everything we can see. Thump, thump, your heartbeat, slow, steady, calm, like a pulsar, like the tick of cosmic time. Dark matter is everywhere, threading through galaxies like invisible scaffolding, holding them together. Without it, galaxies would fly apart. The stars orbit too fast. The math doesn't work unless there's more mass than we can see. 5 times more. 5 times as much dark matter as ordinary matter. The stuff we're made of, the stuff we can touch and see, is the minority, the exception. We live in a universe dominated by shadows. Let your attention drift like dust through space. Nothing to hold on to, nothing to do, no effort, no struggle, just being. This dark matter forms structures, vast cosmic webs, filaments stretching across billions of light years, connecting galaxy clusters, creating highways through space, rivers of invisible mass. Along these filaments, galaxies form, trapped in gravitational wells like dewdrops on a spider's web. The largest structures in the universe are made of something we cannot see, cannot touch, cannot understand, only infer. Your legs heavy now, thighs sinking, calves relaxing, feet going limp, toes uncurling, everything releasing, releasing to releasing. Computer simulations show us what the dark matter web looks like. It's beautiful, elegant, complex, like neural networks, like blood vessels, like mycelium spreading through soil. The universe has structure, has pattern, and dark matter is the architect, the hidden hand, shaping everything, guiding the formation of galaxies, of clusters, of superclusters, of the entire cosmic web, drifting, floating, your mind like a feather on still water, barely touching, barely there. And there's something else, something even stranger, something that makes up 70% of the universe. We call it dark energy, but we don't know what it is, only what it does. It pushes galaxies apart, accelerates the expansion, makes space grow faster and faster and faster. Your breathing barely noticeable now, soft, shallow, gentle, almost not breathing, almost not there. In the 1990s, astronomers discovered something shocking. The expansion of the universe isn't slowing down like everyone thought. It's speeding up, getting faster. This shouldn't be possible. Gravity should be slowing it down, pulling everything back together, but instead, something is pushing. Something is counteracting gravity on the largest scales. Something fills the vacuum, the empty space, with energy, with pressure, negative pressure, pushing outward forever, arms resting, palms open, fingers uncurled, everything letting go, every cell, every atom, every thought. This dark energy is a mystery, one of the deepest mysteries in all of physics. We can measure its effects, we can see what it does, but we don't know what it is. A property of space itself, a quantum field, a cosmological constant, Einstein's greatest blunder. That turned out to be real. Space has weight, space has energy, and that energy is pulling the universe apart. Your mind drifting now through the cosmos, weightless, free, untethered from your body, from your thoughts, from everything. The universe is 70% dark energy, 25% dark matter, and only 5% ordinary matter, atoms, light, stars, planets, you. Everything we've ever known, everything we've ever seen is just 5%. The rest is shadow, is mystery, is darkness. We live in a universe we barely understand, swimming in invisible oceans, guided by unseen hands. Thump, thump, thump. So slow now, so calm, so peaceful. Imagine the universe as a cosmic ocean. Dark energy is the water, vast, dominant, everywhere. Dark matter is the current, invisible, moving things, shaping things. And ordinary matter is the foam on the waves, visible but insignificant, a tiny fraction dancing on the surface, of something much deeper, much larger, much more mysterious, sinking deeper, past thought, past awareness, just sensation, dissolving, fading, becoming less. Between the stars, there are clouds, interstellar clouds, molecular clouds, giant, dark, cold, made mostly of hydrogen, with traces of other elements, carbon monoxide, water, ammonia, methanol, complex organic molecules floating in the darkness. These clouds can be hundreds of light years across, contain enough mass to make millions of stars, your body barely there now, just warmth, just weight, just breath, nothing more, nothing less. These clouds are the birthplaces of stars. They drift through the galaxy, cold, just 10 degrees above absolute zero, so cold that atoms move slowly, stick together, form molecules, form dust. The clouds grow darker, denser, more opaque, blocking starlight, creating dark patches against the glow of the Milky Way. Let go of the last threads of thought, let them drift away like smoke, like mist, like starlight fading into dawn. Inside these clouds, gravity is working, slowly, patiently, pulling gas inward. The cloud begins to collapse, not all at once, but in regions, in pockets, where density is slightly higher. These regions contract, heat up, spin faster, conservation of angular momentum, like a figure skater pulling in their arms. Everything soft now, everything quiet, everything still, no movement, no sound, just the deep, endless peace over millions of years. These collapsing regions, called protostars, grow hotter, denser, more massive. The pressure builds, the temperature rises, 1 million degrees, 5 million, 10 million, and then, at 15 million degrees, something magical happens. Hydrogen nuclei, protons, overcome their electromagnetic repulsion, fuse together, release energy. Nuclear fusion begins, your thoughts scattering like stars across the dark, each one fading, going out, leaving only emptiness. A star is born, not with violence, but with light, gentle light, at first, growing stronger. The protostar becomes a star, begins its life on the main sequence, burning hydrogen, converting it to helium, mass into energy. E equals mc squared, Einstein's equation, playing out in stellar cores across the universe, floating now in the dark, in the deep, in the endless. No up, no down, no here, no there. Our sun formed this way 4.5 billion years ago from a molecular cloud that collapsed, that fragmented, that formed hundreds of stars, our siblings, now scattered across the galaxy, lost to us forever. But once, we were part of the same cloud, the same collapse, the same moment of stellar birth, barely breathing, barely there, just drifting through the cosmic dark. Ancient stars, the first stars, formed differently. The universe was younger then, only had hydrogen and helium, no heavy elements, no carbon, no oxygen, no iron, nothing heavier. These first stars, called Population 3 stars, were massive, hundreds of times the mass of the Sun. They burned bright, burned hot, burned fast, your consciousness to dimming like a distant star, fading, cooling, going dark. These ancient giants lived only a few million years. Then they exploded, supernovae, the first supernovae, scattering heavy elements into space, carbon, oxygen, neon, silicon, iron, created in their cores, in their final moments, blown outward, seeding the universe with the ingredients of planets, of life, of you, melting, dissolving into the night, into the void, into the endless. Every atom in your body, except hydrogen, was made inside a star. Carbon, the basis of life, forged in stellar cores. Oxygen, that you breathe, created in dying stars. Iron, in your blood, made in supernova explosions. You are, quite literally, made of stars, star stuff, contemplating stars. As Carl Sagan said, we are a way for the universe to know itself, heavier, softer, deeper, quieter, further, gone. The life cycle of a star depends on its mass. Small stars, your red dwarfs, burn slowly, live trillions of years, longer than the current age of the universe. Stars like our Sun live about 10 billion years. We're halfway through, 5 billion years left before the Sun swells into a red giant. Massive stars die young in just millions of years. Thump, 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 your heart like a distant drum, echoing, fading, almost gone. When a star like our Sun dies, it swells, becomes a red giant, engulfs inner planets, maybe Earth too. Then it sheds its outer layers, gently, creating a planetary nebula, beautiful, colourful, shells of glowing gas, expanding outward, revealing the core, hot, dense, white, a white dwarf, Earth-sized, but massive as the Sun. A teaspoon would weigh tons. Your mind, a whisper now, almost gone, almost forgotten. This white dwarf will cool, slowly, over billions of years, glowing red, then infrared, eventually going dark, becoming a black dwarf, a cold, dead remnant. But the universe isn't old enough yet for any black dwarfs to exist. Every white dwarf still glows, still cools, still waits, drifting past thought into pure rest, into nothing, into everything. Massive stars die differently. When fusion stops in their cores, nothing holds them up against gravity. The core collapses in less than a second, from Earth size to city size. The temperature spikes 10 billion degrees, 100 billion degrees. The outer layers rebound, explode outward, supernova, bright as a galaxy, for weeks, barely here, barely anywhere, just floating in the space between. What's left depends on mass. If the core is small enough, it becomes a neutron star, unimaginably dense. A sugar cube would weigh 1 billion tons, made entirely of neutrons, protons and electrons, crushed together into neutrons. a city-sized ball of nuclear matter spinning, sometimes hundreds of times per second, your body forgotten, your mind fading, only darkness remains, only peace, only rest. If the core is too massive, even neutrons cannot resist. Gravity wins completely. The star collapses into a point, a singularity, creating a black hole, a region of space-time so curved, so warped, that nothing, not even light, can escape. The ultimate end for massive stars, and the beginning of something even more mysterious. But that's a journey for later, for the next part of our drift through the mysteries. And we continue drifting, floating through the cosmic dark, your breath like stellar wind, your heartbeat like a pulsar, your consciousness dissolving into the fabric of space, of time, of the universe itself. Black holes. The name sounds ominous, dark, frightening, but really, they're just gravity, taken to its logical extreme. Space curved so sharply that it curves back on itself, creating a trap from which nothing returns. Your eyelids, heavy as neutron stars, dense, immovable, settled, still. Imagine space-time as a rubber sheet. A star creates a dip, a gentle curve. A black hole creates a pit, infinitely deep. Anything that falls in slides down and down and down, past a point called the event horizon, the point of no return, beyond which the future points only inward, only down, always toward the singularity. You're breathing, so slow now, like the orbital decay of a distant planet, inevitable, gentle, eternal. At the event horizon, time behaves strangely. From the outside, anyone falling in appears to slow down, freeze, never quite crossing, suspended forever at the edge. But from their perspective, they fall through. In finite time, no barrier, no wall, just crossing into a region where escape is impossible, where all paths lead inward, sinking deeper into the mattress, and your body is a collapsed star, dense, heavy, still, inside a black hole. Space and time trade roles. The singularity isn't a place in space, it's a moment in time, your future, unavoidable, like tomorrow. You can't avoid going there any more than you can avoid tomorrow arriving. The mathematics are beautiful and terrifying and strange. Thump, thump, your heart beating in slow motion like time near the event horizon. Around every black hole there's an accretion disk, matter spiraling inward, gas, dust, sometimes entire stars orbiting, falling, heating up from friction, from compression, glowing, bright, hotter than the surface of any star. X-rays, gamma rays pouring out from the brightest objects in the universe, powered by the darkest. Your thoughts spiraling, slowing, stretching like light, red-shifted into darkness. The matter doesn't fall straight in. It has angular momentum, rotation, so it spirals slowly, taking years sometimes centuries, to complete its final death spiral, each orbit slightly smaller, slightly faster, until finally it crosses the event horizon and vanishes from the universe forever. Let everything go, every muscle, every tension, every thought, pulled by gravity into stillness. Some black holes spin incredibly fast, dragging space-time around with them, creating a region called the ergosphere, where nothing can stand still, where space itself is rotating, pulled by the black hole's angular momentum. This is called frame dragging, the rotation of mass twisting the fabric of reality, your consciousness spiraling down into the event horizon of sleep, deep, dreamless sleep. Supermassive black holes live at the centers of most galaxies, including ours, millions, sometimes billions of times the mass of the Sun, Sagittarius A star, at the center of the Milky Way, 4 million solar masses, 26,000 light years away, quiet now, but once it fed, it blazed, it consumed, floating, drifting through the dark, your body orbiting the center of sleep. Galaxies are islands, island universes, collections of stars, hundreds of billions, sometimes trillions, bound together by gravity, by their shared history, by the dark matter halos that surround them and hold them together. Your breath, like the slow rotation of a spiral arm, barely moving, almost still. Our galaxy, the Milky Way, is a spiral, barred spiral with elegant arms curving out from a central bar of stars. We live 2/3 of the way from the center in a minor arm called the Orion Spur, a quiet neighborhood between major arms, safe, stable, perfect for life, heavier, softer, your body merging with the bed, no boundaries, no separation. The Milky Way rotates, everything orbits. The galactic center, our sun, takes 225 million years to complete one orbit, one galactic year. The last time we were here, dinosaurs hadn't evolved yet. The next time, who knows what will exist? Your heartbeat, the pulse of galactic time, slow, patient, eternal. Spiral arms aren't fixed structures, they're density waves, regions where stars bunch up, traffic jams in space. Stars move through the arms like cars, through congestion, slowing down, then speeding up. The pattern persists, but the stars flow through it, drifting through thought, through sensation, through being, becoming less and less and less. These arms are star factories. The compression triggers collapse of molecular clouds. New stars form in clusters, lighting up the spiral arms, blue and bright, young stars, massive stars that won't live long. By the time they orbit out of the arm, they've already died. Your mind, like a molecular cloud, diffuse, dark, cold, collapsing into sleep. Between the arms, older stars, red, yellow, quieter. These are survivors, long-lived, stable. The spiral pattern creates waves of birth and death. Young stars in the arms, old stars between. The galaxy is not a static thing. It breathes, it lives, it evolves. Let go of the last fragments of awareness dissolving into cosmic dust. Dark energy pulls the universe apart on the larger scales, but on smaller scales, gravity wins. Galaxies cluster together, drawn by their mutual mass, creating groups, clusters, superclusters, vast structures containing thousands of galaxies. Your body, a galaxy, your cells, stars, all bound together, all orbiting the center of you. The Milky Way is part of the local group, a small cluster, about 50 galaxies, dominated by two large spirals, us and Andromeda. The rest are dwarf galaxies, small, faint, orbiting the giants. Thump, 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 slower, quieter, almost stopped. Andromeda is approaching us, not expanding away, but falling toward us at 110 kilometers per second. In about 4 billion years, we'll collide. But don't worry, the stars are so far apart, they'll pass through each other like ghosts. The galaxies will merge, form a new galaxy, an elliptical, called Milkomeda. Your thoughts colliding, merging, becoming. One thought, one feeling, sleep. When galaxies collide, the stars don't touch. Space is too empty, too vast, but the gas, the dust, they collide. Shock, heat, compress, triggering, starbursts, waves of star formation. The galaxies pass through, return, orbit, eventually merge into one larger, more massive, more evolved, sinking into the gravity well of deep, dreamless peace. The shapes of galaxies tell stories. Spirals are young, dynamic, still forming stars. Ellipticals are old, mature, formed from mergers. Their stars orbit randomly, no disk, no pattern, just a swarm of ancient stars, slowly orbiting your awareness, shapeless now, formless, like an elliptical galaxy, random, fading, old. Dwarf galaxies are everywhere, orbiting larger galaxies, small, containing millions, sometimes billions, of stars, but faint, hard to see. The Milky Way has dozens, maybe hundreds, of dwarf satellites orbiting in the halo, being slowly torn apart by tidal forces. Your consciousness torn apart by the tides of sleep, fragmenting, dissolving, fading. The cosmic web is the largest structure in the universe. Filaments of dark matter and galaxies stretching across billions of light years, connecting galaxy clusters like threads in a vast tapestry. Between the filaments are voids, empty regions where almost nothing exists, floating along the filaments of sleep, traveling through darkness to nowhere. If you could see the universe from outside, you'd see this web, foam-like, cellular, with dense regions and empty regions, matter clustered along filaments, galaxies like lights on cosmic highways, and voids, dark, empty, expanding, forever. Your body, the mattress, the room, the earth, all dissolving into the web, into the pattern. This structure emerged from quantum fluctuations in the early universe, tiny variations in density, amplified by gravity over billions of years. The dense regions got denser, the empty regions got emptier, until the web formed the scaffolding on which all structure hangs, heavier, heavier, your body like dark matter, invisible but present, pulling everything down. Gravity is the weakest force at small scales, but the strongest at large scales. It shapes everything from planets to galaxies to the entire universe. It curves space, slows time, binds matter, creates structure. Without gravity, there would be no stars, no planets, no us. Your heartbeat, the tick of gravitational time, pulling you down, down, down. Einstein showed us gravity isn't a force, it's geometry. Mass tells space how to curve, space tells mass how to move. A dance, elegant, mathematical, perfect, playing out across the cosmos, in every orbit, every fall, every attraction. Let the mathematics, the equations, the beauty wash over you, meaningless but calming, like rain on a roof near massive objects. Time slows, clocks tick more slowly. This isn't an illusion, it's real, measurable. GPS satellites have to account for it, or they drift out of sync. With earthbound clocks, time itself is relative, flexible, curved by mass. Your thoughts slowing, time stretching, each second lasting forever. Light follows the curves of space-time around massive objects. Light bends, creating gravitational lensing. Einstein rings multiple images of distant galaxies, distorted, magnified by the gravity of foreground clusters. The universe acts as a lens, showing us what we couldn't otherwise see. Your perception bending, warping, reality shifting as you sink deeper. Rogue planets wander the galaxy, billions of them ejected from their home systems by gravitational interactions. Three-body problems, unstable orbits, kicked out into the dark, alone, forever, freezing, drifting through the void, with no sun to warm them. Your body, a rogue planet, drifting through the solar system. You have sleep, cold, dark, alone, but peaceful. These worlds are truly alone. Light years from the nearest star, surfaces frozen solid, atmospheres collapsed into ice on the ground. But deep below, there might be warmth, radioactive decay, tidal heating. If they have moons, subsurface oceans could exist, alive, perhaps in the dark, drifting through your own dark ocean, deep, warm, safe. Neutron stars are strange objects, city-sized, but massive as the sun, spinning rapidly, some hundreds of times per second. Their magnetic fields, trillions of times stronger than Earth's, create beams of radiation from their poles. As they spin, we see pulses, regular as clockwork. We call them pulsars. Your breath, a pulsar, regular, steady, marking time. In the darkness, the material of a neutron star is unlike anything on Earth. Neutronium, pure nuclear matter. A teaspoon would weigh 1 billion tons. The protons and electrons crush together into neutrons, packed so tightly that the star is essentially one giant atomic nucleus, city-sized, heavy, so heavy your body denses. A neutron star, immovable. Still, some neutron stars have even stronger magnetic fields, magnetars, with fields so strong they warp atoms, strip electrons, create empty space around them. Occasionally, they flare, starquakes, releasing energy enough to disrupt radio communications on Earth from thousands of light years away. Your muscles locked, frozen by the magnetic fields of sleep, unable to move, don't want to move. Binary systems are common. Two stars orbiting each other, bound by gravity, dancing for millions of years. Sometimes they're so close that they touch, sharing atmospheres, mass flowing from one to the other. A cosmic waltz, your heartbeat and breath dancing together in rhythm, in harmony. When two neutron stars orbit, they emit gravitational waves, ripples in space-time, carrying away energy. The orbit shrinks slowly over millions of years. Eventually, they merge, creating a kilonova and possibly a black hole. We've detected these waves, felt the vibrations of space-time itself, your body emitting waves of relaxation, ripples of peace spreading outward into the room, into space, into everything. The universe is full of echoes, gravitational waves from colliding black holes, from merging neutron stars, from the Big Bang itself. We can listen now to the symphony of space-time, vibrating, ringing like a bell, struck billions of years ago. Listen to the silence between your breaths, the space where the universe speaks. Stellar nurseries glow in infrared, hidden behind walls of dust. Inside, stars are born by the thousands, protostars accumulating mass from the surrounding cloud, growing, heating until fusion ignites your thoughts like protostars, forming in the darkness of your mind, then fading before they're born. The pillars of creation in the Eagle Nebula are towers of gas, light years tall. Inside, stars are forming, eating away at their cocoons, emerging into the light. But the pillars are already gone, destroyed by a supernova thousands of years ago. We just haven't seen it yet. The light hasn't reached us. Everything you see is the past. Light takes time to travel. Nothing happens now. Everything is memory. Even the screen in front of you, even your hand. You see them as they were nanoseconds ago. The past is all we have. Your present moment already passed. By the time you notice it, let it go. Let it all be past, be memory, be gone. Interstellar clouds collapse slowly under their own weight. Gravity, patient, relentless, pulling. Over millions of years, the cloud contracts, heats, spins faster, fragments into smaller clouds, each becoming a star or planet or nothing. Your awareness fragmenting, each thought becoming smaller, dimmer, until nothing remains. Some clouds don't collapse. They drift through the galaxy forever, too diffuse for gravity to win, just floating, dark, cold, invisible, except when silhouetted against bright stars. Barnard 68, a dark cloud, so dense no stars shine. Through it, a hole in space, but really just dust and gas and darkness. Your mind, like Barnard 68, dark, dense, no light, shining through, just peace. Ancient quasars shine from the early universe, powered by supermassive black holes, consuming matter at incredible rates. They shine brighter than entire galaxies, visible across the universe, beacons from cosmic dawn. Your thoughts, like quasars, once bright, now distant, fading, red-shifted into darkness. These quasars show us that supermassive black holes formed early, somehow, within 1 billion years of the Big Bang. We don't know. How? Did they form from smaller black holes merging, or did they form directly from collapsing clouds of gas? It's a mystery that haunts cosmologists. Let mysteries remain mysteries. No need to solve them. No need to know. Just wonder and let go. The cosmic microwave background bathes everything in faint radiation. 3 degrees Kelvin above absolute zero. The afterglow of the Big Bang, stretched by expansion, cooled by time. It's everywhere, uniform, almost, with tiny variations, 1 part in 100,000. Your body heat radiating away, cooling, approaching equilibrium, with the room, with space, with everything. These tiny variations are seeds of everything. Regions slightly denser became galaxies, clusters, superclusters. Regions slightly emptier became voids. All structure traces back to these ripples in the cosmic microwave background. Quantum fluctuations inflated to cosmic size by the expansion of space. Your breath creating ripples in the air, tiny variations in pressure, spreading out, fading, becoming nothing. Maps of the CMB show us the universe at 300,000 years old, the oldest light we can see. Before this, the universe was opaque. No light escaped, just plasma, hot, dense, glowing, but invisible to us now. Close your eyes See the darkness. That's what the universe looked like before light could travel. Just darkness and heat and waiting. The observable universe has a limit, not because space ends, but because light hasn't had time to reach us. From farther away, the light travel distance is 46 billion light years in every direction. Beyond that, we cannot see, cannot know, only imagine. Beyond the edge of your awareness, what exists in the parts of your mind you cannot reach: dreams, memories, forgotten, lost, beyond the horizon of consciousness. Perhaps the universe is infinite, extending forever, beyond what we can see, with infinite galaxies, infinite stars, infinite planets. Somewhere in that infinity, another you, another Earth, another everything, infinite possibilities playing out forever. Your mind, infinite, containing universes, thoughts, dreams, all dissolving now into nothing. The heat death of the universe is the likely end. In trillions of years, stars will stop forming, galaxies will go dark, black holes will evaporate. Only photons will remain, stretched by expansion to infinite wavelengths, and the universe will reach maximum entropy, final equilibrium. Nothing will ever change again. Your body reaching equilibrium with the bed, no movement, no change, perfect stillness, perfect peace. But that's so far away, trillions upon trillions of years. For now, the universe is young, dynamic, alive. Stars are born, galaxies merge, black holes grow. Everything is still happening. And you are here now, in this moment, drifting through mysteries, held by gravity, rocked by the rhythm of cosmic time. Thump, thump, heart, the universe, beating together as one. And still, we drift deeper into the cosmic ocean, where time moves like honey and space folds like silk, your body sinking through layers of reality, of consciousness, of the universe itself. Your breath, so faint now, almost invisible, like the thin atmosphere of distant worlds, barely there, barely moving, just existing. Let's float now through realms we haven't yet explored, through the hidden corners of the cosmos, where strange things happen, where the universe reveals its secrets in whispers, in shadows, in the spaces between everything. The Oort cloud surrounds our solar system, a vast sphere of icy bodies, trillions of them, stretching halfway to the nearest star, 1 light year from the sun. This is where comets are born, disturbed by passing stars, by gravitational tides. They fall toward the sun, taking millions of years to complete their journey. Your thoughts, like comets in the Oort cloud, frozen, distant, waiting in the dark. Occasionally, one falls toward consciousness, then fades back into the void. Imagine the darkness out there at the edge of the solar system. No sunlight reaches you, just starlight, cold, faint. The sun, just another star, barely brighter than the others. You drift in absolute darkness for billions of years, unchanging, unmoving, frozen in time, heavier, heavier, your body like an icy comet, frozen solid in the darkness of sleep. Kuiper Belt objects orbit beyond Neptune, Pluto, Eris, Makemake, Haumea, strange worlds made of ice and rock, with thin atmospheres that freeze and fall as snow. When they're far from the sun, these are remnants of planetary formation, leftovers that never became planets. Your thoughts are remnants too, fragments that never became complete ideas, just pieces floating in the dark. Some of these objects are binary, two worlds orbiting each other, locked together by gravity, dancing through the outer solar system for billions of years, never separating, never touching, just orbiting forever in the cold. Your heartbeat and breath, binary stars orbiting around each other, locked in rhythm, slowing together into stillness. The heliopause is where the solar wind meets interstellar space, where the sun's influence ends and the galaxy begins. Voyager 1 crossed it in 2012, the first human-made object to enter interstellar space, still sending faint signals back to Earth from the edge of everything we've ever known. You're crossing your own heliopause, the boundary between waking and sleeping, between consciousness and dreams, leaving behind everything. You know, beyond the heliopause, space is different, filled with interstellar wind, magnetic fields from other stars, cosmic rays from distant supernovae, the local interstellar cloud, a pocket of slightly denser gas that our solar system is passing through. It will take tens of thousands of years to cross, passing through clouds of thought, pockets of awareness, taking forever to cross, each moment stretching into eternity. Stars move through the galaxy on complex orbits. They bob up and down through the galactic disk. Every 30 million years, our sun crosses the midplane, where density is highest, where encounters with molecular clouds are more common. Some think these crossings might trigger mass extinctions on Earth by disturbing the Oort cloud, sending comets raining inward. Everything moves, nothing is still. Even in sleep, your body crosses mid-planes, between states, between moments, between existences. The galactic habitable zone is a ring where conditions are just right for life, not too close to the galactic center, where supernovae are common, radiation is intense, not too far. In the outer regions, where heavy elements are rare, We orbit in the middle of this zone. Lucky, again, you orbit in your own habitable zone, between awake and asleep, where rest is possible, where dreams can form, where consciousness can finally let go. Hypervelocity stars are racing out of the galaxy, moving at thousands of kilometers per second, fast enough to escape the Milky Way's gravity. They were flung out by encounters with a supermassive black hole at the galactic center. 3 body interactions that sent them flying into intergalactic space. Your thoughts, hypervelocity, racing, slowing, escaping the gravity of awareness, flying into the intergalactic void of sleep. These runaway stars will wander forever between galaxies, never part of any system, just drifting through the void for trillions of years alone, but free, unbound by anything. Freedom in the darkness, no obligations, no connections, just floating through nothing. Stellar streams wrap around galaxies, trails of stars from tidally disrupted dwarf galaxies, stretched into long ribbons by gravitational forces. The Sagittarius stream encircles the Milky Way several times, evidence of a small galaxy being slowly consumed, digested by our own. Your thoughts stretched into streams, ribbons of awareness wrapping around the galaxy of your mind, being consumed by sleep, slowly, gently, completely. Globular clusters are ancient collections of stars, hundreds of thousands, packed into a sphere just a few light years across. They orbit galaxies in the halo far above and below the disk. These stars are old, nearly as old as the universe, formed in the first billion years after the Big Bang. Ancient, so ancient, your body remembering sleep from the beginning of time, cellular memory pulling you down, down into primordial rest. Inside globular clusters, stars are packed so densely that collisions are possible. Blue stragglers form this way, 2 old stars colliding, merging, creating something that looks young but isn't, just reborn from collision, from chaos, creating new light. Your thoughts colliding, merging, creating brief flashes of awareness, then darkness, returning, always returning. The thick disk of the Milky Way lies between the thin disk and the halo made of older stars, with different orbits, different chemistry, a separate population that formed when the galaxy was younger, more chaotic, still settling into its current form. Layers in your mind, thick disk of memories, thin disk of present thoughts, halo of dreams, all orbiting the center of consciousness that's slowly going dark. Stellar metallicity tells us a star's age. Old stars have less heavy elements because the universe hadn't made many. Yet, young stars are metal-rich, born from clouds, enriched by generations of previous stars. We are third generation, at least, made from the ashes of ancient suns. You are made of countless ancestors, countless lives, all compressed into this moment, this body, this breath that's fading into nothing. Open clusters are younger than globular clusters, loosely bound, a few thousand stars born together from the same molecular cloud, the Pleiades, the Seven Sisters, beautiful, blue, young. These clusters gradually disperse over hundreds of millions of years, stars drifting apart, going their separate ways. Your thoughts, an open cluster, gradually dispersing, each one drifting into darkness, losing contact with the others until nothing remains but empty space. The Gould Belt is a ring of young stars and star-forming regions, tilted relative to the galactic disk, about 3,000 light-years across. We're inside it, born from a supernova shockwave about 30 million years ago that compressed molecular clouds, triggered waves of star formation, including, perhaps, our sun, everything connected, every event rippling forward through time, your birth connected to ancient causes, your sleep tonight connected to every sleep you've ever heard. Bok globules are dark clouds silhouetted against bright nebulae, dense, cold, the size of the solar system. These are collapsing, forming stars inside, hidden from view. We can see them only as dark spots against glowing backgrounds, wombs of stars. Your mind, a Bok globule, dark, dense, collapsing into nothing, something forming inside, but you'll never know what. Only darkness, visible. Herbig-Haro objects are jets from newborn stars, young stellar objects still accumulating mass, fire jets of material from their poles. These jets slam into surrounding gas, create shock waves, glowing regions of ionized gas, evidence of birth, of violence that creates new life. Your breath, like jets from a young star, slowing, weakening, the violence of waking, subsiding into the calm of sleep. T-Tauri stars are pre-main sequence stars, not yet hot enough for fusion, but glowing from gravitational contraction, variable, unpredictable, sometimes flaring, sometimes dimming. They have strong stellar winds that blow away surrounding gas, eventually revealing the young star beneath your consciousness, variable, flickering, sometimes bright, mostly dim, the winds of sleep, blowing away the last traces of awareness. Protoplanetary disks surround young stars, flat, rotating, made of gas and dust. This is where planets form. Dust grains stick together, grow larger, become pebbles, boulders, planetesimals, protoplanets, eventually planets. The process takes millions of years, slow, patient, inevitable. Your thoughts, like dust grains in a disk, sticking together, then falling apart, building toward something, then forgetting. What? In these disks, there are gaps, cleared by, forming planets. Their gravity sweeps out regions of the disk, creating rings, spaces, evidence of worlds we cannot yet see, only infer from absence, from shadow. Gaps in your awareness, growing larger, regions swept clean by the gravity of sleep, evidence of dreams forming in the darkness, invisible but present. Hot Jupiters are giant planets orbiting very close to their stars, closer than Mercury to our sun. They shouldn't be there. Gas giants should form far out where it's cold, but somehow these migrated inward through the Sisk or were scattered by other planets into close orbits. Now they're tidally locked, one side always facing the star, day side, thousands of degrees, night side, slightly cooler, but still hellish. Your body tidally locked to the bed, one side against the mattress, warm, the other against air, cooler. But you don't notice, don't care, just existing. Super Earths are planets, larger than Earth, but smaller than Neptune. We don't have one in our solar system, as they're common around other stars, rocky, some with thick atmospheres, some with oceans, some completely covered in water. Water worlds with no land, just endless oceans, hundreds of kilometers deep. Your mind, a water world, nothing solid anywhere, just liquid thought, flowing, merging, dissolving into itself. Mini Neptunes are smaller versions of Neptune, ice giants with thick atmospheres of hydrogen, helium, maybe water, methane, ammonia. We're not sure because we can't see through their clouds. They're mysteries, common but unknown. Mystery is comfortable, not knowing is peaceful. Let go of the need to understand, to know, just accept the darkness, the unknown. Circumbinary planets orbit two stars at once, like Tatooine from Star Wars. These systems are real, planets forming in disks around binary stars, orbiting both, seeing two suns rise and set at different times, creating complex patterns of light and shadow. Your consciousness orbiting two centers, awake and asleep, circling both, drawn to both, until one wins and you fall completely into darkness. Rogue planets ejected from their home systems are completely dark. No starlight warms them, just the faint heat from their formation, radioactive decay, tidal heating, if they have moons. Some might have subsurface oceans kept liquid by internal heat, alone in eternal night. but perhaps not dead, alone in the darkness of your room, but not dead, just sleeping. Internal warmth sustaining you through the night. Free-floating planets might outnumber stars in the galaxy, billions, trillions, wandering alone through interstellar space, never orbiting anything, just drifting on trajectories set billions of years ago when they were cast out into the dark, your thoughts free-floating, untethered, drifting through the interstellar space of your mind, no longer orbiting anything, just moving through nothing. Planetary migration changed our solar system. Jupiter might have migrated inward, then back out. Saturn, Neptune, Uranus, all moved from where they formed this migration. Scattered smaller bodies created the Kuiper Belt, the Oort cloud, maybe sent comets raining inward, delivering water to Earth, making life possible. Everything moves, everything changes. Even in sleep, you migrate through states, through dreams, through the night. Nothing stays where it begins. The late heavy bombardment, about 4 billion years ago, comets and asteroids rained down on the inner solar system, cratering the moon, the Earth, Mars, Mercury, perhaps triggered by planetary migration, by orbital resonances that destabilized the outer solar system, sending debris everywhere. Thoughts bombarding your consciousness like asteroids, like comets, impacts, creating craters in awareness, until finally the bombardment stops and there's only silence. Orbital resonances are patterns in motion. When orbital periods have simple ratios 2:1, 3:2, 5:3, these resonances can be stable, like Neptune and Pluto, or unstable, causing ejections, collisions, chaos. The universe loves patterns, seeks harmony. Even in orbital motion, your breath and heartbeat, seeking resonance, finding patterns. 2 breaths for 3 heartbeats, 3 breaths for 5, until they slow so much the pattern dissolves. Lagrange points are stable positions in orbital systems where gravitational forces balance perfectly. Objects placed there stay there relative to the 2 bodies, L1, between them L2, beyond L3, on the opposite side, L4 and L5, 60 degrees ahead and behind in the orbit. These points collect dust, asteroids, even satellites. You put there, finding your own Lagrange point between waking and sleeping, a stable position where you can rest forever, balanced between 2 worlds. Troy asteroids live at Jupiter's L4 and L5, thousands of them trapped there by orbital mechanics named after heroes of the War for Troy, Greek camp, Troy camp, forever opposing, forever balanced, never meeting. Your thoughts, Troy asteroids, trapped at stable points in your mind, never moving, never changing, just existing, in balance, in stillness. The Titius-Bode law is a pattern in planetary orbits. Each planet is roughly twice as far from the Sun as the previous. It works, mostly, until you get to Neptune. Then it breaks. Maybe it's coincidence. Maybe it tells us something about how planets form. We don't know, but patterns emerge. Even in chaos, patterns in the darkness, behind your eyelids, swirls, spirals, fractals, emerging, dissolving, meaningless, but beautiful. Asteroid belts mark boundaries between regions of the solar system, the main belt between Mars and Jupiter. Millions of rocky bodies that never formed a planet because Jupiter's gravity stirred them up, prevented accretion. They remain fragments forever, fragments of thought floating in the belt between consciousness and unconsciousness, never forming anything complete, just pieces drifting, series. The largest object in the asteroid belt is a dwarf planet, round, differentiated, with an icy mantle, maybe an ocean. Beneath the surface, bright spots. In a Huna Mons crater might be cryovolcanoes, erupting water and ammonia instead of lava. A tiny world with hidden complexity in the simplest parts of you, cells, atoms, quantum fields, layers upon layers, but on the surface, just stillness, just sleep. Vesta, another large asteroid, has a giant crater covering much of its southern hemisphere. An impact so violent it nearly shattered the entire body, ejected thousands of fragments into space. Some fell to Earth as meteorites. We can study pieces of Vesta in laboratories, touch a world we've barely visited. Pieces of you scattered through memory, through experience, through time, fragments that once were whole, now separated, lost, forgotten. Near-Earth asteroids cross Earth's orbit, potentially hazardous. We track them, watch them, make sure they won't hit, but someday one will, maybe in 1,000,000 years, maybe tomorrow. The universe doesn't care about us. We're just here, briefly, watching, waiting. Don't wait, don't watch, just sleep. Let tomorrow worry about tomorrow. Tonight is for rest. Meteor showers happen when Earth passes through debris streams left by comets. Tiny particles, dust grains, hit the atmosphere at thousands of kilometers per second, vaporize, create streaks of light, shooting stars, wishes made on burning dust. Your thoughts, like shooting stars, burning up on entry into sleep, bright for a moment, then gone forever. Meteorites that reach the ground are messengers from space. Most are fragments of asteroids. Some are from Mars, ejected by impacts, travelled through space for millions of years, then fell to Earth. Pieces of another world arriving here by chance. You are a meteorite too, consciousness, arriving here in this body by chance, by physics, by the mechanics of the universe. And soon you'll return to space, to sleep, to the void. The Chicxulub impact, 66 million years ago, ended the dinosaurs. An asteroid, 10 kilometers across, struck what is now Mexico with the energy of billions of nuclear bombs, created a crater 200 kilometers wide, threw dust into the atmosphere, blocked the sun for years. Most species died, but some survived, including our ancestors, tiny mammals that inherited the earth. Catastrophe creates opportunity. Death enables life. Everything is connected in cycles of destruction and creation, and now you cycle too into sleep, into death of consciousness that enables the rebirth of morning. Impact craters cover planets, moons, asteroids, records of violence, of collisions, of chaos from billions of years of bombardment. Each crater tells a story of an object that traveled through space for millions of years, only to end in a moment of impact, of annihilation. Your day ending in a moment of impact, with sleep, all that motion, all that energy ending in stillness, in silence, in peace. The moon is slowly drifting away from Earth, about 4 centimeters per year. Tidal forces transfer angular momentum from Earth's rotation to the moon's orbit. Eventually, billions of years from now, the moon will be so far that Earth will be tidally locked, one side always, facing the moon. Days will last 50 Earth days, but we'll be gone. By then, long gone. Everything drifts apart. Eventually, even things that seem permanent, bound, forever, slowly separating into the darkness, alone. But tonight, the moon is still there, pulling the tides, pulling your thoughts into rhythm with the ocean, the universe, the eternal cycle of ebb and flow. Tidal locking is common in the universe. Mercury is tidally locked to the sun in a 3-to-2 resonance. Most moons are tidally locked to their planets. One face always visible, the other forever hidden in darkness. The far side of the moon we never saw until we sent spacecraft around it. The far side of your mind, forever hidden, even from you, unconscious. Dreams, memories, buried. You'll never see that side while awake, only in sleep, only when you stop looking. Libration is a wobble in the moon's motion. Lets us see slightly more than half. From Earth, 59% instead of 50. The moon nods, shakes, rotates slightly, more than its orbital motion. An imperfect tidal lock. Most locks aren't perfect. Most orbits aren't circular. Everything in the universe is slightly off, imperfect, but functional, like you. like sleep, like everything. You don't need to be perfect to rest, to sleep, to drift. Just let go of perfection, of control, of everything. The Earth's rotation is slowing. Tidal friction from the moon breaks us. Gradually, days are getting longer by about 2 milliseconds per century, imperceptible but real. Eventually, if Earth survives long enough, days will be 50 hours long, but the sun will die first, expand into a red giant, engulf Earth. None of this matters to you tonight. Time slowing, your perception of duration stretching. Seconds become minutes, minutes become forever. You have all the time in the universe to sleep. No rush, no deadline, just endless time. And we keep drifting through these mysteries, or your body, heavy as a planet, your mind, vast as space, your consciousness, fading like ancient starlight, stretched, red-shifted into nothing. Thump, thump, your heart, the moon, pulling tides in your blood, in your thoughts, in your being. Everything is connected. Everything is one, and you are dissolving into that oneness, that unity, that cosmic peace. Cosmic radiation murmurs constantly through space. High energy particles, protons, electrons, atomic nuclei, accelerated by supernova shocks, by black holes, by processes we don't fully understand. They rain down on Earth, millions, every second, passing through you, through everything, invisible, unstoppable, your body, permeable, like space itself, everything passing through, nothing holding on, just flow. Some of these particles come from outside our galaxy, extragalactic cosmic rays, traveling for millions of years across the void between galaxies until they strike Earth's atmosphere, creating showers of secondary particles, evidence of distant violence, arriving here as whispers. Listen to the whispers of the universe, speaking through the silence between your thoughts. Tidal forces stretch galaxies as they pass each other. Gravity stronger on the near side than the far side, creating tails, streams of stars, gas, dust, pulled out into space, bridges between galaxies, evidence of cosmic encounters billions of years ago. Your body stretched by the tidal forces of sleep, lengthening, thinning, dissolving into the bed, into the room. The antennae galaxies show this beautifully. Two spirals colliding, merging, long tails of stars pulled out by tides, starbursts where gas clouds collide, compress, form millions of new stars in a brief, brilliant flowering before settling into a new form. Your thoughts colliding, merging, creating brief, brilliant moments, then fading, settling into stillness. Gamma ray bursts are the brightest events in the universe. For a few seconds, they outshine everything, even all the stars in the observable universe, combined. Then they fade forever. We see one every day, somewhere in the sky. Flashes behind your eyelids, brief, brilliant. Then darkness, returning, always returning. These bursts come from collapsing massive stars or colliding neutron stars, jets of matter moving at 99.9% the speed of light, beaming energy into space. If one happened too close to Earth, it could strip our atmosphere, end life. But space is vast, and we are small and lucky, so far safe here in the darkness of your room, protected by distance, by chance, by the vastness of space. Galaxy clusters are the largest gravitationally bound structures in the universe. Thousands of galaxies held together by dark matter. By their mutual gravity, between the galaxies, hot gas glows with X-rays, millions of degrees more mass than all the stars combined. Your body, a cluster of cells bound together by forces you don't control, don't need to control, just existing, just being. When clusters collide, the galaxies pass through, mostly untouched, but the gas collides, creates shock waves, bull shocks, like sonic booms in space. The bullet cluster shows this. Two clusters passed through each other. The gas stayed behind, glowing, but the dark matter and galaxies kept going. Proof that dark matter is real, separate from ordinary matter. Your thoughts passing through each other, colliding but not touching, just moving through the space of your mind. Gravitational waves were predicted by Einstein in 1916, but not detected until 2015. LIGO heard them. Ripples in space-time from two black holes colliding 1.3 billion light-years away. The waves compressed and stretched space itself by less than the width of a proton. But we heard them. We felt space-time ring. Your body ringing, vibrating at frequencies too low to hear the hum of existence, of being. These waves travel at light speed through the universe, passing through everything, planets, stars, galaxies. Nothing stops them, nothing disturbs them. They carry information about the events that created them. A new way of seeing the universe, not with light, but with gravity itself. Let the waves of sleep pass through you, carry information from deep inside to nowhere, to everywhere. Dwarf galaxies are ancient, some of the oldest structures in the universe. Small, faint, metal poor, their stars, formed early when the universe had less heavy elements. They orbit larger galaxies, being slowly torn apart by tidal forces fed to the giants. Your awareness, ancient, being torn apart, fed to the darkness, scattered across the void. The Milky Way is eating the Sagittarius dwarf right now. Slowly, over hundreds of millions of years, streams of stars from the dwarf wrap around our galaxy, being absorbed, becoming part of us. Cosmic cannibalism is common, natural, the way galaxies grow, growing, expanding, your consciousness, absorbing everything, then contracting, shrinking into nothing. Planets orbit dying stars long after the star has faded. These worlds are frozen, dark, no sunlight reaches them, just starlight from distant stars and the faint glow of the cooling white dwarf. They orbit for billions of years, waiting for nothing, just existing in the cold. Your thoughts orbiting the dying star of awareness, cold, distant, barely there. Some exoplanets are made of ice, water ice, methane ice, ammonia ice, far from their stars, beyond the frost line where water can freeze. These worlds might have subsurface oceans kept liquid by tidal heating or radioactive decay, hidden seas in the dark, perhaps with life deep inside you, hidden places, warm, dark, safe, where life continues, even as the surface sleeps. Cosmic dust is everywhere, tiny grains, silicates, carbon created in stellar atmospheres, supernova explosions, ejected into space. This dust blocks light, makes nebulae dark, but it also glows in infrared, absorbing starlight, re-emitting it as heat. The universe is dusty. Everywhere you look, your thoughts, like dust, tiny, scattered, floating through the void of your mind, settling on nothing. Gravitational lensing shows hidden paths through the universe, light from distant galaxies bent around, foreground clusters creating arcs, rings, multiple images, Einstein rings, perfect circles. When alignment is just right, the universe acts as telescope, magnifying what we couldn't otherwise see. Your perception bent, warped by the gravity of sleep, showing you things that aren't there, dreams forming at the edges. Pulsars are cosmic lighthouses, spinning neutron stars with beams of radiation from their magnetic poles. As they spin, the beam sweeps across Earth. We see pulses. Some pulses spin hundreds of times per second. Millisecond pulses, more regular than atomic clocks, the most precise, natural clocks in the universe. Your heartbeat, a pulsar, slowing, marking time in the darkness. Thump, thump, thump. The fastest pulsar spins 716 times per second. Imagine a city-sized object, massive as the sun, spinning that fast, the surface moving at 20% light speed. If it spun any faster, it would fly apart. Centrifugal force, overwhelming, even nuclear, strong force, spinning in your mind, thoughts rotating, faster, then slower, then still. Neutron stars cool slowly over billions of years. They start incredibly hot, billions of degrees inside the core, but they radiate, heat away, cooling, dimming. Eventually, they'll become black dwarfs, cold, dark, invisible, remnants of stars. But the universe isn't old enough for this yet. Your body heat radiating into the room, cooling, approaching the temperature of everything around you. Equilibrium, peace, wormholes are theoretical solutions to Einstein's equations, tunnels through space-time, connecting distant regions of the universe, or even different universes, but they're unstable, would collapse instantly unless held open by exotic matter with negative mass, which probably doesn't exist. Tunnels in your mind, connecting memories, dreams, collapsing as you try to follow them, disappearing into nothing. Still, it's beautiful to imagine shortcuts through space, doorways to distant stars, to other times, to parallel worlds. Science fiction loves wormholes, and maybe in some universe they exist, but probably not ours. Let go of the need to travel, to move, to go anywhere. Just be here now. Sinking. Supermassive black holes might be connected. Some theories suggest through quantum entanglement, through shared properties, correlations across vast distances. When one spins up, does the other feel it? We don't know, but it's possible that black holes are linked in ways we can't detect, can't understand. Everything is connected. Your breath, the room, the earth, the galaxy, the universe, all one thing, all breathing together. Space-time can fold near massive objects, creating regions where time moves differently, where space curves sharply. Near black holes, time almost stops at the event horizon, an infinite moment, stretched forever. Your sense of time dissolving. Minutes could be hours, hours could be seconds. Time losing meaning as you drift deeper inside black holes. The equations say space and time switch roles. The singularity becomes your future, not a place, but a moment you will reach, must reach, cannot avoid, like death, like sleep, inevitable, final. The future is sleep, unavoidable, welcome, coming, now. Dark galaxies might exist, made entirely of dark matter, no stars, no gas, no light, just invisible mass, creating gravitational effects we could detect if we knew where to look. Ghost galaxies, drifting through the cosmos, unseen, unseeable. Your body, a dark galaxy, invisible to yourself, now, just sensation, without form, without boundary. The cosmic web weaves constantly. Dark matter flows along filaments like rivers, carrying galaxies into clusters, into superclusters. The larger structures follow these paths laid down billions of years ago by quantum fluctuations made cosmic by inflation, flowing along neural pathways of sleep, following ancient roots into darkness. Primordial sound waves in the early universe created the patterns we see in the cosmic microwave background, baryon acoustic oscillations, pressure waves in the hot plasma. Before recombination, these ripples froze when the universe became transparent, and they set the scale for cosmic structure. Today, sound waves of breath creating ripples in the air, in the universe, in consciousness, spreading, fading, gone. Intergalactic plasma fills the space between galaxy clusters, hot, ionized, invisible to optical telescopes, but glowing in X-rays. This gas contains more mass than all the stars in the cluster combined. The missing baryonic matter found hiding in plain sight. Your thoughts, like plasma, ionized, broken apart into constituent pieces, no longer coherent, just fragments, floating. Planetary rings are delicate, made of billions of small particles, ice, rock, dust, orbiting in thin disks. They tilt, wobble, presets, under gravitational influence of moons. The rings of Saturn are temporary, cosmically speaking. They might be only a few 100 million years old, and they'll be gone. In another few 100 million, everything is temporary. Your thoughts, your worries, yourself, all temporary, all dissolving. Soon, brown dwarfs are neither stars nor planets, failed stars, not massive enough to fuse hydrogen. They glow dimly from leftover heat, from formation, gradually cooling over billions of years, fading into darkness, never quite alive, never quite dead, just existing between waking and sleeping. You hover in the space between states, not here, not there, just between. Space-time curves around every mass, creating wells, inclines, geodesics, the paths that free objects follow. You think you're sitting still, but you're falling through space-time along a geodesic into the future, 1 second per second, always falling into sleep, one breath at a time, one heartbeat at a time, always falling. Exomoons must exist around exoplanets. We've barely detected any, but statistics demand them. Thousands, millions, perhaps some with thick atmospheres, liquid water, maybe life orbiting giant planets around distant stars, hidden places in the universe, in your mind, where things exist undetected, unnoticed, waiting to be discovered or not. Galactic cores balance precariously between gravity and motion. The supermassive black hole at the center, surrounded by dense clusters of stars orbiting at thousands of kilometers per second. One mistake, one collision, and stars fall into a black hole, but it's stable for now, for billions of years. Your mind balanced between awareness and sleep, tipping now toward darkness. The cosmic microwave background shimmers with information, temperature variations, polarization patterns, revealing the geometry of space, the density of matter, the strength of dark energy, all encoded in light from the infant universe. Everything is encoded in patterns, in rhythms, in waves. Your breath, your heartbeat, carrying information about you into the darkness. Interstellar travelers from Earth, Voyager 1, Voyager 2, Pioneer 10, Pioneer 11, New Horizons, all leaving the solar system, drifting into interstellar space. They'll wander for billions of years, long after humanity is gone, or carrying messages or golden records, plaques from a dead civilization. Your thoughts, travelers leaving the solar system of your mind, drifting into the interstellar darkness. Cosmic inflation solved many problems in cosmology. Why the universe is so flat, so uniform, why we don't see magnetic monopoles in a fraction of a second. Space expanded exponentially by a factor of at least 10 to the 26, smoothing out all irregularities as creating the universe we see today, expanding into sleep, your consciousness inflating, then collapsing into a single point of nothing. Nebulae collapse under their own weight, but the process isn't silent. It's accompanied by outflows, jets, stellar winds from forming stars. These winds push against surrounding gas, creating bubbles, cavities, shaping the nebula as stars are born. Your breath shaping the space around you, creating bubbles of calm in the darkness. Dying stars fade slowly, red giants cooling, shrinking, losing mass in stellar winds, eventually shedding their outer layers, leaving behind a hot core, a white dwarf that will cool for trillions of years, slowly, gradually, forgetting it was ever a star, forgetting what you were before sleep, before darkness, before this moment, just fading into nothing. Cosmic topology is the study of the universe's shape. Is it flat, curved, closed, open? Does it loop back on itself like a torus or a sphere? We think it's flat, but at scales larger than we can see. Who knows? Maybe the universe is shaped like a dodecahedron or something even stranger. The shape of your awareness changing, folding, curving into impossible geometries. Energy fields permeate everything. Quantum fields fill all of space. The electron field, the quark field, the photon field, the Higgs field, particles are just excitations of these fields, waves in an invisible ocean that extends throughout the universe. You are a wave in the field of consciousness, rising, falling, spreading, dissipating into the field. Ancient light from distant stars travels for billions of years, crossing the void undisturbed until it reaches a telescope, enters a detector, and is absorbed, destroyed. Its journey finally complete. Information delivered from a star that died billions of years ago. Your journey into sleep nearly complete. Just a little further. Expanding voids push galaxies to their edges. Space itself growing in the emptiest regions faster than anywhere else, creating bubbles in the cosmic web, growing, merging. Eventually, most of space will be void, empty, dark, with galaxies clustered in distant islands. Your mind expanding, creating voids, emptying, thoughts falling away, leaving only space. Planetary nebulae drift outward from dying stars, glowing shells of gas, red, green, blue, lit by ultraviolet from the hot white dwarf at the center. Beautiful, ephemeral, lasting thousands of years before dispersing into interstellar space, becoming part of clouds that will form new stars, new planets, new life. Your thoughts dispersing into the interstellar medium of sleep, becoming raw material for dreams. Dust orbits stars, planets everywhere. Quietly, the dust in your room settles on surfaces in your lungs. The dust in space settles into planets, into you. Stardust, quite literally. Everything is dust, was dust, will be dust. Again, dust to dust, consciousness to unconsciousness, being to unbeing, settling finally into rest. Universal entropy increases always. The second law of thermodynamics. Order becomes disorder, energy spreads out. Eventually, the universe will reach maximum entropy, heat death. Nothing will ever change again. Perfect equilibrium, perfect stillness, perfect stillness. Now, in your body, in your mind, in this moment, nothing changing, nothing moving, just being. Primordial black holes, if they exist, formed in the first second after the Big Bang, from density fluctuations in the early universe. Some could be smaller than atoms, others massive as stars, drifting, invisible, ancient, since the beginning of time. Ancient sleep, since the beginning of life, calling you back to the source, to the start, to the darkness before birth. Magnetic filaments thread through the galaxy, invisible lines of force guiding charged particles is creating structure in the interstellar medium. Us can't see them directly, but we see their effects in radio waves in cosmic rays, in the alignment of dust grains, invisible but present, always invisible threads connecting everything, you, the bed, the earth, the stars, all connected by forces you can't see, can't feel, but they're there, holding everything together. Galaxies merge slowly over hundreds of millions of years. They approach, pass through, orbit, return, pass through again, eventually settling into a new configuration. All their stars mixed, their gas consumed in starbursts, their black holes merged into one, larger, more massive. The universe grows through mergers, through collisions, through chaos, becoming order, your thoughts merging, colliding, becoming one thought, one feeling. Sleep, sleep, sleep. The eternal calm of the sleeping universe pervades everything between the violence, between births, between deaths. There is mostly peace, mostly silence. The universe spends most of its time doing nothing, being nothing, resting in the dark between moments of creation and destruction. You resting in the dark between moments of waking and sleeping, in the space between everything. Thump, thump, your heart barely beating, the cosmos breathing through you, stars forming in your chest, galaxies spinning in your mind, black holes opening behind your eyes. You are the universe experiencing itself, knowing itself, now forgetting itself, dissolving back into the cosmic dark. The universe keeps turning through endless night, stars being born and dying, galaxies dancing through space, and you, part of it all, floating through mysteries, 100 universe mysteries, looping softly, endlessly through the night, and we'll keep drifting, floating together through the mysteries. The instant the universe sparked from nothing, the secret cosmic scaffolding, the hidden forces guiding everything toward a fate no one can predict. There's nothing you need to do now, and just let your body sink heavier, heavier. Feel the mattress holding you, every muscle softening when your heartbeat slowing. Thump, thump, matching the rhythm of space itself. Shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. The universe keeps turning, the cosmos unfolding in quiet, endless layers, and we'll keep drifting, floating together through the mysteries. 100 universe mysteries, looping softly, endlessly through the night, and we'll keep drifting, floating together through the mysteries forever. And we'll keep drifting, floating together through the mysteries. 100 wall of fire mysteries, looping softly, endlessly through the night, Tonight we'll drift through the blazing boundary where the horizon begins to melt, the hidden currents stirring behind the planet's burning veil, the ancient powers driving the wall of fire ever higher. There's nothing you need to do now, just let your body sink, heavier, heavier. Feel the mattress holding you, every muscle softening, your heartbeat slowing, thump, thump, matching the rhythm of space itself, shoulders melting down, jaw releasing, each breath pulling you deeper, deeper into the calm, the quiet, the dark. If this helps you rest, tap subscribe, comment, and hit like, so others can find this calm too, but only if your eyes are still open. Otherwise, just drift. Now, let's drift into Wall of Fire. Imagine, if you will, a curtain shifting, always shifting, beneath your feet. A curtain made of flames, not the flames you can see, but the ones that dance so far below, in the darkness, where light has never been. This is the Wall of Fire, the glowing edge where the planet's mantle meets something softer, something that wants to rise, always rising like your breath, in and out, slow, slower. The Wall of Fire doesn't burn like fire burns, it glows with the patience of stone, heated beyond imagining, pressed by the weight of continents, of oceans, of everything above. This boundary, this shimmering line, exists where solid becomes liquid, where the rigid crust of Earth floats on something molten, something that moves like honey, like dreams, slow, so slow. Feel your eyelids growing heavy, heavier as we descend together, down through the rock, through layers of time compressed into stone. The temperature rises 1 degree, then another and another, until we reach that threshold, that magical place where minerals begin to soften, to flow, to become the slow drift of molten rivers, winding through passages no eye has ever seen. These rivers, they don't rush, they creep, over centuries, over millennia, carrying heat from the planet's core upward, always upward, toward the surface, just toward you. But they move so slowly, you could watch for a lifetime and see nothing change, just the whisper, the gentle whisper of subterranean heat, rising, falling, breathing. The Wall of Fire marks the border, the soft border, between crust and fire, between the world you know and the world that churns below. It's not a sharp line, not a wall you could touch. It's a zone, a gradient, where everything transitions from hard to soft, from cold to hot, from still to flowing, like the boundary between waking and sleeping, where you are now, drifting between. Beneath your sleeping body, if you could sink down through your bed, through the floor, through basement and bedrock and ancient sediments, you would find, eventually, the quiet pulse of rising magma. Not violent, not explosive, just rising, like bubbles in thick syrup, barely moving, but always moving. Thump, thump, like your heartbeat, slowing now, matching the rhythm. There are buried chambers, hidden chambers beneath continents, vast pockets where molten rock collects, pools, waits. These chambers sit just above the wall of fire, or just below it, in that transition zone, where the earth can't quite decide whether to be solid or liquid. And in these chambers, the rock glows, cherry red, orange, white, in the perfect darkness, glowing for no one, forever. Sometimes, very rarely, there's a tremble, a small tremble in far-off volcanic fields, a whisper of movement as pressure shifts, as the wall of fire breathes, adjusting itself. The tremble passes through stone, through time, barely felt, just a gentle reminder that everything is floating on something warm, something alive in its own slow way. The wall of fire enables the slow expansion of thermal waves. Heat moves through rock the way sleep moves through your body, gradually, inevitably, spreading from one place to another. These waves ripple outward from hot spots, from places where the mantle is especially warm, and they travel for thousands of miles beneath your feet, beneath oceans, invisible, silent, patient. If you could see in the dark beneath the crust, you would see a glow, a soft glow, beneath tectonic plates. The plates themselves are cold, relatively, but underneath, just underneath, the wall of fire glows, amber and gold, providing the heat, the lubrication that lets the plates slide, drift, collide, separate. All the motion of the surface begins here, in this glowing zone. There's a promise, always a promise, of a distant eruption somewhere. The wall of fire holds this promise, cradled in its heat. A promise written in pressure, in temperature, in the slow accumulation of buoyant rock that wants to rise, will rise, someday, but not tonight. Tonight everything is still, calm, quiet, just heat and time and slow movement. The air above hot ground shimmers, distorts. You've seen this on summer roads, the way distance seems to waver, to dance. This is the same, but deeper, the shimmering distortion in hot air near volcanic regions is the visible breath of the wall of fire, reaching up, touching the atmosphere, creating mirages, illusions, dreams made of heat. Deep in the rock, there are memories, silent memories of pyroclastic flows, ancient explosions captured in layers of ash, now compressed, now silent. These memories roll through geological time, slowly, the way memories roll through your mind as you drift towards sleep, less distinct now, softer, fading into the darkness, into the quiet. The wall of fire is fed by the breath of superheated stone that has been heated not by fire, but by pressure, by the weight of the world, crushing down, until atoms are forced close together, until friction becomes heat, until solid becomes soft and breathes, rises, falls, like your chest, rising, falling, slower now, so much slower. There are unseen chambers, countless chambers, fueling fire lines around the globe. places where magma waits, patient in the dark. These chambers connect through thin channels, through cracks and weaknesses, creating networks, vast networks of potential, of stored energy, all balanced, all waiting, all connected to the wall of fire, the source, the beginning. In some places, the horizon appears warped, bent, under pressure from below. Heat rising from the wall of fire creates pressure, and this pressure pushes upward on the crust ever so slightly, bending the horizon, warping the landscape, creating domes, bulges, too subtle to see, but measured, known, felt by the instruments that listen, always listening to the earth's slow movements. Ancient mountains, long eroded, leave behind drifting embers, not real embers, but the ghost of their heat, the memory of their formation. These volcanic mountains once stood tall, fed by the wall of fire, and even now, millions of years later, the rocks remember, hold warmth, just a fraction warmer than they should be. A memory in stone, in temperature, fading like your thoughts, fading now. Beneath the ocean floor, there's an undercurrent, not of water, but of rock. This undercurrent pushes plates apart at the mid-ocean ridges where new crust is born. The wall of fire provides the heat, the buoyancy that drives this current, this slow, relentless, pushing, pulling, spreading the seafloor millimeter by millimeter, year after year, decade after decade, while you sleep, while generations sleep. At the planet's center, there is a glow, a molten heart made of iron, nickel, unimaginable heat. This heart beats in geological time, thump, thump, and its warmth radiates outward through the mantle, feeding the wall of fire, keeping it alive, keeping it glowing. This is the source, the beginning of all the heat, all the movement, all the slow dance of continents and oceans. Sometimes, if you listen, with instruments sensitive enough, you can hear a soft rumble beneath sleeping valleys, valleys that look peaceful, calm, covered in grass or forest or snow. But beneath them, beneath the sediments, the rumble continues, has continued for millions of years. It's the sound of heat moving, of the wall of fire breathing, exhaling into the crust above, so soft you could sleep through it. You will sleep through it. The wall of fire follows hidden fractures, ancient scars in the planet. These fractures guide the burn, the flow, the rise of heat, like water finding the path of least resistance. Molten rock finds these fractures, these weaknesses, and flows through them, guided, channeled, creating pathways that last for eons. The fractures remember, the rock remembers, everything remembers. Down there in the heat and the dark, below the wall of fire, deeper still, there's a layer called the asthenosphere, a beautiful word, asthenosphere. Say it slowly in your mind, asthenosphere. This layer churns, not quickly, but constantly, convecting, turning like a pot of thick soup, barely simmering. The heat makes it weak, makes it flow, and this flow, this slow churn, drives everything, all the movement above, all the drifting, all the formation of mountains and valleys. The ocean floors hide a secret, a fire path, a path of heat and creation, where the wall of fire comes closest to the surface. Here, at mid-ocean ridges, the crust is thin, just a few miles thick, and below it, molten rock waits, rises, erupts gently into cold water, creating new land, new crust, expanding the sea floor. This fire path circles the globe like a seam, a glowing seam, in the darkness, beneath the waves, in places far from volcanoes, far from earthquakes. There are still geothermal towers, gentle towers of rising heat. These form where the wall of fire has a hot spot, a place where a plume of warm material rises like smoke from incense, slow, steady, invisible from above, but there, always there. The gentle rise of these towers brings warmth to the surface, creates hot springs, geysers, pools of heated water, where minerals dissolve and deposit and create strange, beautiful formations. Volcanic arcs curve across the planet's surface, chains of volcanoes following the edges of tectonic plates. These arcs dream, red-tinged dreams of eruption, of fire, but mostly they sleep, fed by the wall of fire below, where one plate slides beneath another and melts, releasing water, lowering the melting point, creating magma that rises, that feeds the volcanoes, that waits, patient, in chambers, dreaming, far off, in remote places. There's sometimes a hiss, barely audible, of shifting vents, places where gas escapes, where heat rises, where the wall of fire breathes out. This hiss has continued for thousands of years, will continue for thousands more. It's the sound of pressure equalizing, of heat finding release, of the planet exhaling, slowly, continuously, like your breath, in, out, continents. These massive rafts of rock are woven together by molten threads, threads of heat, of connection that run through the mantle, through the wall of fire, linking distant places. What happens in one location eventually affects another. Through these threads, through this network of heat and pressure, everything connected, everything flowing in slow motion, geological motion, the slowest dance. Above volcanic regions, the winds carry ash-laden memories, particles so fine they drift for years, circling the globe. These winds, these quiet drifts, are born from eruptions, fed by the wall of fire, and the ash eventually settles, becomes soil, becomes fertile ground, becomes the foundation for forests, for fields. The destruction becomes creation, given time, given enough slow, patient, drifting time. New ridges, fiery ridges, are born, so slowly at the spreading centers where plates pull apart. The wall of fire pushes up, fills the gap, creates new crust, new rock, still hot, still glowing, then cooling, darkening, becoming solid, becoming part of the seafloor. This birth, this slow birth, happens continuously, but so gradually that in a human lifetime you'd see almost nothing, just peace, stillness, the appearance of permanence. The horizon in volcanic regions shimmers with distant heat, even when no eruption occurs, even when everything seems calm. The heat is there, beneath, creating updrafts, distorting light, making the far mountains seem to waver, to float, to drift, like you're drifting now, between thoughts, between moments. The shimmer is hypnotic, endless, a dance of hot air and light and distance. The crust, solid crust, drifts above a glowing sea, not a sea of water, but a sea of softened rock, the wall of fire, and below it, the deeper mantle, all solid, technically, but flowing over geological time, like ice in a glacier, appearing frozen, but moving, always moving. And the crust above rides these currents, drifts with them, collides, separates, rises, sinks, all floating, all drifting on the glow. When a new volcanic chain is born from a hot spot, from a plume rising through the mantle, there's a breath, the breath of a newborn. The first eruptions, the first islands are the planet breathing, creating, expressing the heat from below, from the wall of fire, from even deeper. This breath might last for millions of years, creating island after island as the plate above drifts, leaving a trail, a chain, a breadcrumb path, showing the motion of the surface above the stationary plume, invisible to the eye, but real, measured, known, are rivers, rivers of mantle plumes, rising from deep, perhaps from the boundary between mantle and core. These plumes rise through the wall of fire, through the asthenosphere, toward the surface, carrying heat, creating hot spots, feeding volcanoes like Hawaii, like Yellowstone. These invisible rivers flow upward for thousands of miles through solid rock that flows like liquid. Given enough time, enough heat, enough pressure, the Pacific Ocean holds beneath its waters a wall of fire, not a wall you can see, but a ring of fire where the Pacific plate meets other plates, where subduction zones create the deepest trenches, where the wall of fire curves upward, feeding hundreds of volcanoes, creating the most active volcanic region on Earth. This underwater wall, this boundary, circles, nearly encircles, the entire Pacific. A ring of heat, of potential, of slow, building pressure. Your breath, in, out, matches the rhythm of the planet breathing. Feel your chest rising, falling, like the mantle, rising, falling in its slow convection. Everything connected, your body, the earth, both warm, both alive, both cycling, heat and energy in their own time. Let your breathing slow even more, matching the geological pace where a single breath might last 1,000 years. The wall of fire shifts position over time, not in human time, but in the deep time of geology. As plates move, as continents drift, the wall of fire adjusts, moves with them, stays beneath them, or sometimes is left behind, creating fossil heat signatures, ancient warmth trapped in old rock. The shifting position of this boundary has rewritten the map of Earth countless times, will rewrite it countless times more. Below Iceland, a unique place where a spreading ridge rises above the sea, the wall of fire is exceptionally close to the surface. You can walk there on fresh lava, still warm, still releasing heat from its recent birth. Below your feet, just a few kilometers down, the wall of fire glows, feeds the volcanism, feeds the geysers, feeds the endless creation of new land. Iceland grows, millimeter by millimeter, year by year, split down its center by the spreading, by the rise of molten rock. There are places where the wall of fire seems to disappear, where subducted plates sink deep, carrying cold rock down, disrupting the boundary. These cold slabs descending through the mantle create complexity, create variations in temperature, in heat flow, in the depth to melting. The wall of fire bends around them, adjusts, accommodates their presence like water, flowing around stones, finding its path, always finding its patient path. In your body, heat is regulated, maintained, kept constant. In the earth, heat is also regulated, but differently. The wall of fire helps maintain thermal equilibrium, balancing heat from below with heat loss above. This balance has kept Earth habitable, active, alive for 4 billion years. The regulation is automatic, self-organizing, elegant, like your body, maintaining its temperature while you sleep, while you dream, without any conscious thought. Sometimes, in deep mines, workers feel the warmth increasing with every level down, every 100 meters. The temperature rises about 3 degrees. This is the geothermal gradient, and it points always downward toward the wall of fire, toward the source of all this heat. Miners digging for gold, for diamonds, for copper, descend toward, but never reach, this glowing boundary. It remains, always deeper, always out of reach, always waiting below. The wall of fire influences the magnetic field indirectly. The heat it provides keeps the outer core molten, convecting, generating electric currents that create Earth's protective magnetic field. Without the wall of fire, without the heat engine, the core might cool, the magnetic field might fade, and solar wind would strip away the atmosphere slowly over millions of years. Everything connected, heat, magnetism, life itself, all depending on the glow far below. Let your mind drift to the seafloor 2 miles down, where sunlight never reaches. Here, at hydrothermal vents, at black smokers, the wall of fire touches the ocean. Hot water, superheated, erupts from cracks, carrying minerals, carrying heat, creating oases of life in the deep darkness. Strange creatures, tube worms, giant clams, eyeless shrimp cluster around these vents, living on the chemical energy from the planet's heat. Life powered by the wall of fire, by chemistry, by warmth from below. The rock at the wall of fire exists in a strange state, not quite solid, not quite liquid, but something in between, a crystal mush where solid grains float in, pockets of melt. This mush can flow over geological time, but appears solid if you could somehow touch it, observe it. The strange state of partially molten rock is what makes plate tectonics possible, makes the Earth dynamic instead of frozen, dead, like Mars, like the Moon. Your muscles are releasing now, all tension flowing out, like heat flowing from the core, nothing to hold, nothing to grip, just release, softness, melting into the bed, into the darkness. Feel your legs, heavy, so heavy, sinking, your arms, loose, fingers relaxed, everything, letting go, flowing, like the asthenosphere, beneath the plates, fluid, soft, at peace. The wall of fire has different names in scientific literature. The lithosphere-asthenosphere boundary, the lab, the low velocity zone, the LVZ, but whatever name, it's the same glowing transition where Earth changes character from rigid lithosphere above to flowing asthenosphere below. The names don't matter, only the reality, the heat, the transformation, the boundary that enables everything. In ancient times, people knew that Earth was warm inside. They saw volcanoes, felt earthquakes, found hot springs, but they didn't know about the wall of fire, about plate tectonics, about the mantle. These discoveries are recent, within the last century. The wall of fire existed long before. We named it, understood it, measured it. It existed when dinosaurs walked above, when the first life formed, when Earth was young, always there, glowing, patient, eternal. Some mountains, called shield volcanoes, have gentle inclines, built by thousands of fluid lava flows over millions of years. These flows come from the wall of fire, through mantle plumes, through hot spots. The lava, because it's so hot, so fluid, spreads widely, builds slowly, creates mountains like Mauna Loa, like all the Hawaiian Islands. Mountains built, one flow at a time, one eruption at a time, each fed by the inexhaustible heat of the wall of fire. The wall of fire doesn't exist at a single depth. Under oceans, it might be 50 kilometers down. Under old continents, it might be 200 kilometers down. The depth varies because temperature varies, because composition varies, because the melting point of rock depends on pressure, water content, mineral makeup, everything variable, everything complex, yet everywhere present, the boundary between hard and soft. As you breathe, notice the space between breaths, that moment of stillness when the breath has left and before the next one enters. In that space, there's peace, perfect peace. The wall of fire has spaces too, places where no melting occurs, where temperature is just below the threshold. These spaces, these gaps, are part of the boundary's nature, not uniform, not consistent, but variable, alive, breathing like you in its own slow way. Pressure, incredible pressure, exists at depth. At the wall of fire, the pressure might be 15,000 times atmospheric pressure, 20,000 times. This pressure affects everything. How minerals behave when they melt, how viscous the molten rock becomes. Pressure and temperature dance together, creating the conditions for the wall of fire, for partial melting, for the weakness that enables the dance of plates. Above, there are maps created by scientists showing variations in the wall of fire's depth. These maps use seismic waves, use heat flow measurements, use mathematical models. They reveal that beneath young ocean floor, the boundary is shallow, warm, active. Beneath old continents, it's deep, cooler, more stable. The maps show the complexity, the three-dimensional nature of this boundary. Not a simple surface, but a zone, a transition, folded, warped, varied. If you listen very carefully with your whole body, you might feel the vibration of the planet humming. This hum is real, measured by seismometers, a constant background vibration caused by ocean waves, atmospheric pressure, and deep within by the movement. At the wall of fire, by convection, by heat flow. The planet is never silent, never still, always humming, always breathing, a lullaby in frequencies too low for conscious hearing, but felt in dreams. The wall of fire helps create or deposits mineral wealth. When magma rises from this boundary, it carries dissolved metals, copper, gold, silver, zinc. These metals concentrate as the magma cools, as it interacts with surrounding rock, as fluids circulate. The wealth of civilizations, the Bronze Age, the Iron Age, all ultimately come from the wall of fire, from its heat, its chemistry, its patient work over millions of years. Your heartbeat is slowing. You can feel it. Thump, thump, thump. Slower, deeper, calmer. Each beat pushes blood through your body like the mantle pushes plates across the surface. Circulation is life, whether in your veins or in the planet's depths. The circulation continue as you drift towards sleep. Both circulations, yours and Earth's continuing in the darkness, in the quiet. The wall of fire is affected by water, even tiny amounts of water in rock lower the melting point dramatically. This is why subduction zones, where ocean crust descends, carrying water with it, are so volcanic. The water, released at depth, fluxes into the overlying mantle, lowers the melting point, creates magma that rises, builds volcanic arcs, island chains like Japan, like the Andes, all because water transforms the wall of fire in the darkness beneath you. Imagine layers upon layers of rock, sediments near the surface, then harder rocks, metamorphic, igneous, deeper still, each layer warmer than the last, each layer under more pressure, until finally you reach the transition where solid gives way to soft, where the wall of fire begins. And even there, in that heat, in that pressure, in that darkness, there is order, structure, the laws of physics governing everything. Some scientists study diamonds brought up from deep within the earth. These diamonds contain inclusions, tiny bits of trapped material from depths near the wall of fire or deeper. By studying these inclusions, scientists learn about conditions at depth, about temperature, pressure, composition. The diamonds are messengers from the deep, carrying news of the wall of fire, of the mantle, of places no human will ever visit. The wall of fire moves over geological time as the planet cools, slowly, imperceptibly cooling. The boundary might be slightly deeper now than 1 billion years ago, slightly cooler. The planet is a heat engine running down, but so slowly that billions of years remain before the engine stops, before the wall of fire cools, solidifies, dies, but not yet, not for so long that it's beyond imagining. Feel the weight of the blanket on your body. Feel its warmth, its gentle pressure, like the lithosphere resting on the asthenosphere on the wall of fire. The blanket holds you, protects you, keeps you warm, and below, far below, the wall of fire does the same for the continents, for the oceans, holding them, letting them drift, keeping everything in motion, in balance. There are computer simulations, models of mantle convection, scientist input, the laws of physics, the properties of rock, the temperature of the core, and the computer just calculates how the mantle flows, where the wall of fire forms, how plates move. These simulations match reality surprisingly well. They confirm our understanding of the heat engine, of the glowing boundary, of the slow, patient circulation that drives everything. The wall of fire existed before life, before oceans, before the atmosphere. When Earth was young, newly formed, mostly molten, there was no wall of fire, no boundary, just heat everywhere. But as the planet cooled, the surface solidified and a lid formed, and beneath that lid, the wall of fire emerged, a boundary between the solid lid and the convecting interior. It has been there ever since, evolving, adjusting, but always present. Let your thoughts slow down, become quiet, like the slow thoughts of geological time, where a thought might take 1,000,000 years to complete. Your mind drifting, formless, merging with the darkness, with the quiet. Nothing urgent, nothing pressing, just the slow drift into sleep, into dreams, into the peace that comes when you stop trying and simply let go. If you could feel it, you would sense a soft quiver, a deep earth resonance, too low for human ears, too slow for human perception, but there, always there. This resonance travels through the planet, from the wall of fire, through the mantle, through the crust, of vibration, of heat, of movement, the planet humming to itself, a lullaby in frequencies you can't hear but can feel in your bones, in your sleep, in your dreams. There is a long memory in the rock, in the crust of supervolcanoes, eruptions so vast they changed the climate, blocked the sun, created winters that lasted years. These supervolcanoes are fed by vast chambers connected to the wall of fire, chambers that fill over hundreds of thousands of years, slowly, patiently accumulating heat, magma, pressure, until one day, far in the future or far in the past, the pressure becomes too much. But that day is not today. Today there is only quiet, stillness, the slow accumulation that you will never see, never feel, only rest under fractured plains, far from the sea. There's a hot glow, a warmth that seems out of place. These plains once were volcanic, or sit above thin crust, or rest atop a mantle plume. The glow beneath them comes from the wall of fire, closer here than elsewhere, bringing heat to unexpected places, creating geothermal anomalies, hot springs in cold regions, warmth in the depths of winter, a gift from below, from the ever-burning boundary. Magma domes rise in slow motion, slower than you can imagine. These domes form when magma pushes upward, but doesn't break through, doesn't erupt, just pushes, lifts, creates a bulge in the crust above. The rise might take 10,000 years, 100,000 years, and you, lying here, in this moment, this brief moment, a part of that story, that long, slow, rising, everything, rising, your chest, the magma, the heat, all rising together, then falling, slowly, gently. The Earth's fire belt holds endless tension, not the tension of stress, but the tension of potential, of energy stored, waiting. This belt follows the wall of fire, follows the plate boundaries where heat and pressure and motion combine to create a state of readiness. But readiness that might wait for centuries, for millennia. before anything happens. If it happens at all, mostly there is just the tension, the potential, the quiet, waiting. At the surface, sometimes there's a warm shimmer, a distortion, subtle, easy to miss. This shimmer marks places where heat from the wall of fire reaches up through the crust, warming the ground, warming the air just above, creating small differences in temperature, in pressure, in the way light bends. These distortions are signatures, heat signatures, messages from below saying, we are here, we are warm, we are patient. Dormant craters dot the landscape, sleeping, some for decades, some for centuries, some for tens of thousands of years. These craters dream. If mountains can dream, they dream of the heat below, of the wall of fire that once fed them, that might someday feed them again. The dreaming heat of dormant craters is real, measured in temperature, in gas emissions, in the slow chemical changes that continue, even in sleep, even in your sleep, even now. There is a march, steady, slow, of geothermal storms, not storms of weather, but storms of heat moving through the crust. These storms are currents, circulation patterns in the rock, driven by the wall of fire. Heat rises here, cools there, sinks, rises again, completing cycles that take millions of years. These geothermal storms and shape the surface, create mountains, valleys, mineral deposits, or bodies, everything influenced by the slow storm of heat beneath shifting faults, earthquake faults. There's a glowing front, a place where the wall of fire intersects with zones of weakness. The heat here makes the rock more likely to slip, more likely to adjust. The glowing front provides the temperature that determines where earthquakes happen, how deep they reach, why some places shake while others remain still, all determined in part by the depth. To the wall of fire, to the heat, to the glow. Island chains, tropical islands, volcanic islands rest above. Ancient fire. The fire isn't ancient, not really. It's ongoing, continuous. But the islands, remember, ancient eruptions, ancient formations, their very existence, their soil, their shape, their beauty, comes from the wall of fire, from plumes that rise, from hot spots that stay fixed while the plate above drifts, creating one island, then another, a chain of creation stretching across the ocean. Volcanic arcs are widening slowly, imperceptibly, as subduction continues, as one plate slides beneath another. The arc, the chain of volcanoes, shifts, migrates, widens over millions of years. This slow widening is powered by the wall of fire, by the melting dill that occurs as the descending plate releases water, lowers the melting point, creates magma that rises, that builds new volcanoes slightly farther from the trench than the old ones. Everything moving, widening, spreading, like your consciousness, widening, spreading into sleep. Mountain roots, the deep foundations of high mountains, hold quiet pressure. These roots extend down, far down into the crust, sometimes reaching close to the wall of fire. The pressure there is immense, from the weight above and from the heat below, trying to rise. This pressure is balanced, in equilibrium, but constant. A quiet pressure that you can't feel, but that shapes continents, that determines where mountains can stand, how high they can rise. In darkness, perfect darkness, deep beneath your feet, there's a molten glow, hiding. This glow comes from a rock, heated past its melting point, just but trapped, unable to rise, unable to erupt, just glowing in the dark, for no one, forever, unless, someday, far from now, a path opens and it rises. But for now, for tonight, for this moment of your life, it simply glows, waits, exists in perfect, patient stillness. Above the burning frontier, the wall of fire, there's a gentle drift of heat, of material, of the asthenosphere, sliding, flowing, carrying, plates above it. This drift is what makes plate tectonics possible. Without the wall of fire, without this zone of weakness, of partial melting, the plates couldn't move, continents couldn't drift, the Earth's surface would be locked, frozen. But instead, there's motion, gentle, eternal drift, like your mind, drifting now toward dreams, toward rest. The wall of fire is powered by a hidden engine deep below. This engine runs on heat from the core, heat from radioactive decay, heat from the formation of the planet itself. 4.5 billion years ago, the engine that converts heat into motion, into convection, into the rise and fall of mantle material. And this motion, this circulation, keeps the wall of fire alive, keeps it glowing, keeps the planet dynamic, active, changing, even as you lie still, perfectly still. Beneath the crust, there's a molten maze, not entirely molten, but soft enough to flow. This maze consists of chambers, channels, pockets, veins, all connected or isolated, or connected then isolated, as pressure changes, as temperature shifts, as plates move above. The maze is unmapped, unknowable in detail, but real, hiding, waiting, a labyrinth of heat that no thread can guide you through. Only time, only patience, only letting go. Some fault lines glow in the dark, not with visible light, but with heat, with infrared radiation. These faults reach deep, deep enough to touch the wall of fire, and the heat rises through them, making them warmer than surrounding rock. The glow is subtle, measured by satellites, by instruments, but real, a signature of connection between surface and depth, between the world you see and the world that hides beneath. There are secret tunnels, not carved, but formed by heat, by pressure, by the way. Molten rock can force open pathways through solid stone. These tunnels carry magma from the wall of fire toward the surface. Some reach the surface, become volcanoes, dikes, sills, but others stop partway, cool, solidify, become frozen rivers of once molten rock, trapped, preserved, waiting to be found, or waiting to remain hidden forever. Heat rises, always rises, and as it does, it bends the horizon, creates mirages, distorts the view. This rising heat from the wall of fire creates pressure waves, temperature gradients that travel through the crust, the mantle, even the core. The horizon bends in response. Mountains appear to float. Distances seem wrong, but it's just heat, just the wall of fire reaching up, touching everything, changing everything, subtly, constantly, before the burn, before an eruption, before magma reaches the surface. There's quiet pressure, building pressure that takes years, decades, centuries to accumulate. This pressure comes from the wall of fire, from new magma entering chambers, pushing, expanding, lifting, but so slowly that monitoring is measured in millimeters, in microstrain, in tiny, tiny changes. The quiet pressure before the burn is almost peaceful, patient, like the pressure of sleep, pressing down on you and gently, irresistibly. Deep in the earth, there's a pulse, a rhythm, too slow to hear, too deep to feel, but there, measured, known. This deep earth pulse is the heartbeat of convection, the rise and fall of mantle material moving in patterns that take millions of years to complete one cycle. No one can hear this pulse thump, 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 but it's there, keeping time for the planet, for the wall of fire, for everything, matching your heartbeat, slow, slower, slowest. Beneath the sea, beneath the deepest trenches, beneath miles of water and miles of crust, there's a firestorm, sleeping, not sleeping like dormant, but sleeping like waiting, building, accumulating heat and pressure and magma. This firestorm might sleep for 1,000,000 years, might wake tomorrow, might never wake, but it's there, under the sea, under the sediments, under everything. A sleeping firestorm connected to the wall of fire, part of it, fed by it, dreaming with it. Ancient rock, billions of years old, contains fractures, glowing fractures, where newer magma has intruded. These fractures cut through the old stone, bringing heat, bringing minerals, bringing change. The glow comes from the wall of fire, from events, perhaps millions of years ago, when magma forced its way up into the ancient rock and cooled there, leaving a frozen record, a glowing memory in the stone. Tomorrow's land is being shaped right now. beneath your feet by a molten surge rising from the wall of fire. This surge moves so slowly you'll never see it, never feel it, never know, but it's there, pushing up, creating, slowly creating new mountains, new islands, new crust. The land of tomorrow begins today, in the heat, in the depth, in the darkness, where molten rock dreams of sunlight, dreams of air, dreams of the surface. A heat wave, invisible, silent, drifts below your feet, right now, always. This heat wave is not like summer heat. It's the heat of the planet's interior, moving upward through the wall of fire, through the asthenosphere, through the lithosphere, approaching but never quite reaching the surface, dissipating, spreading, warming, everything, just slightly. The heat wave, drifting below, is part of the reason the planet lives, breathes, moves. In the mantle, there are plumes, rising plumes, like smoke from a fire, but made of rock, hot rock. These plumes whisper, ready to rise, rising now, rising for millennia, approaching the wall of fire, passing through it, continuing upward toward the crust. Some reach the surface, create hotspots, volcanoes, islands, others stall, spread sideways, cool. The whispering plume, ready to rise, is always there, somewhere, rising, patient, unstoppable. Continents, entire continents, rest on, are shaped by, were created by, a buried spark. The spark is the wall of fire, is the heat engine that drives everything. Without this spark, continents wouldn't exist, wouldn't grow, wouldn't drift, wouldn't collide and build mountains. The buried spark that lights whole continents has been burning for billions of years, will burn for billions more, long after you, long after everyone has returned to sleep, to dust. Beneath stable ground, beneath places that haven't seen volcanic activity for millions of years, there's still the slow ignition of a future eruption. Maybe, possibly. The ignition is so slow, so gradual, that it might take 10 million years to complete, or it might stop, cool, never reach the surface. But the process, the slow ignition, continues down there, in the heat, in the dark, fed by the wall of fire, fed by time, fed by pressure. The path, the ember-line path beneath drifting plates, marks the route of heat flow, of material flow. This path shifts as the plates move, but it's always there, glowing, warm, lined with embers of partially melted rock. The path determines where volcanism can occur, where heat reaches the surface, where the wall of fire's influence is strongest, and the plates above drift over this path like ships on a glowing sea, moving, always moving, millimeters per year, centimeters per decade, meters per century. Volcanic chains stretch across the ocean, across continents, fed by the molten breath. Behind them, this breath comes from the wall of fire, from the zones of subduction, where water released from the descending plate lowers the melting point, creates magma that rises, that breathes life into volcanoes. The molten breath is steady, continuous, measured in cubic kilometers of magma produced per 1,000 years, a slow exhalation that builds mountains, island by island, eruption by quiet eruption. If you could see with special eyes that see heat instead of light, you would see the continents glowing softly from below, warmer along the edges where plates meet, cooler in the ancient centers, the heat signature of the wall of fire painted across the world, invisible yet real, measured, known, a thermal portrait of the planet's interior. The wall of fire creates feedback loops. When a plate moves, it changes stress in the mantle, which changes convection patterns, which changes the wall of fire, which changes how easily the plate can move. Everything connected, everything affecting everything else in a dance so complex, so beautiful that we're only beginning to understand it. The planet regulating itself through feedback, through balance. Sometimes magma chambers form just above the wall of fire, pockets where melt accumulates, unable to rise, not enough pressure, not enough buoyancy, just yet. These chambers can exist for millions of years, slowly crystallizing, slowly cooling, or slowly growing, waiting for the right moment, the right conditions to rise, to erupt, or to simply cool in place, become plutons, granite bodies that will someday be exposed by erosion. Your jaw is completely relaxed now. Your tongue soft in your mouth, your eyes still under closed lids. No need to see, no need to move them. Everything now at rest. The muscles around your eyes, around your mouth, releasing like pressure, releasing at a volcanic vent, slowly, peacefully, no force, just gentle release. The wall of fire influences ocean circulation in subtle ways. Heat from mid-ocean ridges warms the water, creates circulation patterns, affects chemistry, affects life. The deep ocean is not uniform in temperature. Pockets of warmth exist near, spreading centers near volcanic regions. And these pockets, these thermal anomalies, create currents, affect nutrients, affect where life thrives. In the deep dark, all connected to the wall of fire, to heat rising from below. Beneath the Yellowstone caldera, one of Earth's supervolcanoes, there's a mantle plume, a column of hot rock, rising from, perhaps, the core mantle boundary. This plume passes through the wall of fire, bringing extra heat, feeding the volcano above. The plume has created a trail of volcanic remnants across the western United States as the plate drifted southwest over the stationary plume like breadcrumbs, marking the path of North America over the hot spot. The wall of fire has a sound. If you could hear in the right frequency, it would be the sound of crystals forming and melting, the sound of rock flowing, the sound of heat moving, a deep sound, profound, below human hearing, but there, always there, the planet's voice, speaking in the language of thermodynamics, of pressure, of phase changes, of voice, older than life, older than oceans. Let your attention drift down through your body to your feet. Feel them heavy, warm, relaxed. Then let your attention keep drifting down through the floor, through the earth, through rock, getting warmer, darker, deeper, until you reach, in your imagination, the wall of fire. Feel its warmth, not burning but comforting, ancient, eternal. You are held, supported by this warmth, by this boundary. You are safe. The chemistry of volcanic rocks tells stories about the wall of fire. Basalts from Hawaii have one chemistry. Andesites from subduction zones have another. Each chemistry reflects the depth of melting, the amount of melting, the presence of water or lack thereof. Scientists read these rocks like texts, learning about conditions at depth, about the wall of fire, about how the planet works. The rocks are evidence, proof, testimony. There are rare minerals that form only at high pressure, high temperature, near the wall of fire. Minerals like garnet, clinopyroxene, in certain forms. These minerals, when found at the surface, tell us they formed deep, very deep, and were brought up by tectonic processes, by erosion, by the endless cycling of rock from depth to surface and back again over hundreds of millions of years. The wall of fire is not democratic, not evenly distributed. Some places have more heat, more activity, more melting. The Pacific Ring of Fire, the East African Rift, the Mid-Atlantic Ridge, these are places where the wall of fire is most active, most productive, most alive. Other places, like the ancient centers of continents, are quiet, stable. The wall of fire, distant, deep, almost forgotten, almost, but not quite. As continents collide, as mountains rise or the crust thickens, and as it thickens, it insulates, traps heat beneath it. The wall of fire responds, adjusts its depth, adjusts its temperature, everything, seeking equilibrium, seeking balance. The collision of India into Asia, creating the Himalayas, has changed the local character of the wall of fire, buried it deeper, made it hotter, changed the flow patterns in the mantle below. Everything connected, everything responding. Your spine sinking into the mattress, vertebra by vertebra, each one releasing, settling. The natural curve of your spine, supported, relaxed, no tension, no holding, just sinking, settling, like sediments, settling onto the ocean floor, layer upon layer, year after year, century after century, each layer recording a moment in time, each breath recording this moment of rest. The wall of fire has variations, small-scale variations in temperature, in composition, in thickness. These variations create small-scale convection, little swirls, little eddies in the flowing asthenosphere. And these eddies, these small circulations, affect how stress is distributed, where earthquakes happen, how volcanoes behave. The complexity is fractal, patterns within patterns, circulation within circulation, all the way down. When oceanic crust is subducted, pulled down into the mantle, it eventually reaches the wall of fire, passes through it, continues deeper. But as it descends, it releases water, changes the melting point, creates the volcanic arcs we see at the surface. The descending slab is cold, denser than surrounding mantle, and it pulls the plate behind it down. This slab pull is one force driving plate tectonics, powered by gravity and the density contrast created by cooling. There are mathematical equations that describe the wall of fire, equations of heat transfer, of fluid dynamics, of phase equilibria. These equations balance temperature, pressure, composition. They predict where melting occurs, how much melting, how viscous the resulting material. The equations are complex, difficult to solve, but they work. They describe reality. They give us insight into processes we cannot see, cannot touch, cannot visit. The wall of fire is a unifying concept. It connects volcanism, earthquakes, mountain building, seafloor spreading, continental drift, all into one coherent system. Before we understood the wall of fire, before plate tectonics, these phenomena seemed separate, unrelated, mysterious. Now we see they're all connected, all part of one grand system, one heat engine, one process of a planet cooling while staying alive. Let your breathing become even slower, each breath longer, deeper, more relaxed. Feel the pause at the end of each exhale, that moment of complete stillness before the breath returns. In that pause, there's nothing, no thought, no sensation, just being. The wall of fire also has pauses, places where convection stalls, where nothing happens for thousands of years, just stillness in the deep. The heat flow from Earth's interior is about 47 terawatts. That's 47 trillion watts of power continuously radiating from the planet. Most of it comes through the wall of fire, through mid-ocean ridges, through volcanic regions, through hotspots. This heat is the leftover from Earth's formation and from radioactive decay inside the planet. It's been flowing for 4.5 billion years and will flow for billions more. Some rocks, called xenoliths, are chunks of the mantle brought up in volcanic eruptions. These rocks come from depths near the wall of fire. perhaps from below it. They give us direct samples, rare samples of material from depth. Scientists study them, measure their minerals, their temperature, their chemistry, learning from these gifts from the deep, brought up by volcanic violence but containing peaceful information about the world below. The wall of fire creates gradients in temperature, in pressure, in composition, and gradients drive change, drive movement, drive evolution of rock, of crust, of continents. Without gradients, everything would be uniform, static, dead. The gradients, created by and creating the wall of fire, keep Earth dynamic, interesting, alive, keep it changing, evolving, never quite the same from one epoch to the next. Your thoughts are becoming less distinct now, less formed, flowing together like the flow of the asthenosphere, where boundaries is between parcels of rock blur, merge, everything flowing together into one continuous, warm, dark, peaceful state. No separation between thoughts, between breaths, between you and sleep. Just flow, just peace. The wall of fire responds to the spin of Earth. The rotation creates forces, Coriolis forces, that affect convection patterns in the mantle. These patterns are not simple, up and down, but swirling, rotating, following the planet's spin. Everything, even in the deep mantle, even at the wall of fire, feels the rotation, adjusts to it, organizes around it. The planet, knowing itself, feeling itself, spin. There are places called triple junctions, where three plates meet, three boundaries intersect. These junctions are special, geometrically constrained. The wall of fire beneath them must accommodate three different boundary types, three different stress regimes, all meeting at one point. The complexity is fascinating, the balance delicate. These junctions migrate, evolve, change as plates shift. Everything, always changing, always adjusting. In your hands, feel them now, completely loose. Fingers slightly curled, resting. No tension, no holding, like the relaxed state of rock just above its melting point. Soft, pliable, but not liquid. Your hands have worked today, have grasped, have held, but now they rest. They can let go of everything. There's nothing to hold in sleep, in dreams. Just release, softness, peace. The wall of fire teaches us about deep time, about patience, about processes that unfold over millions of years. It teaches us that change is constant, but often imperceptible, that the earth seems stable, permanent, but is actually flowing, changing, evolving, always in slow motion. This perspective, this deep time, can be calming. Your worries, your concerns are brief, momentary in the context of geological time. Let them go. Let them drift away like ash on the wind. The boundary between lithosphere and asthenosphere, the wall of fire, is detected by seismic waves. Earthquake waves travel through the earth, and they slow down when they reach this boundary. The slowing is subtle but measurable. It tells us the rock has changed, become softer, warmer, more able to absorb energy. This slowing, this shadow in the seismic data reveals the invisible boundary, maps it, shows us where it rises, where it sinks, where it undulates. There are cycles in Earth's history, Wilson cycles, where oceans open, then close, continents separate, then collide. These cycles take hundreds of millions of years. They're driven by convection in the mantle, by the circulation that creates and maintains the wall of fire. We are living in the middle of such a cycle. The Atlantic is opening, growing wider. The Pacific is shrinking. Eventually, millions of years hence, the cycle will reverse. Continents will collide, mountains will rise, and the wall of fire will adjust, accommodate, continue. Your body is so heavy now, so relaxed, that you might not even feel it anymore. You might just be floating consciousness, drifting in darkness, no longer attached to the physical. This is the threshold between waking and sleep. This is where the wall of fire exists in the earth, the threshold between solid and flowing. Neither one nor the other, but both and neither. A transition, a becoming, a space between states. The wall of fire will outlast humanity, will outlast all life on Earth, will continue long after the sun has brightened, boiled away the oceans. It will only stop when the planet finally cools, solidifies completely, becomes like the moon, like Mars, geologically dead. But that day is so far in the future, billions of years, that it's almost infinity. For all practical purposes, the wall of fire is eternal. And so, as we drift together through these mysteries, through this warmth, through this darkness, remember you are part of this planet, part of the same heat engine, the same circulation of energy. The warmth of your body and the warmth of the wall of fire are connected, both fighting entropy, both maintaining order, both alive in their own way. And you can rest, can sleep, can trust in this ancient warmth, this ancient process that has continued for billions of years and will continue long after you wake. The wall of fire breathes beneath us, and we drift with it through the night, around the planet, circling it like a ring, like a boundary. There's a fire line, continuous, connected. This fire line is the wall of fire, manifesting at different depths, in different ways, but always there, marking the transition between rigid and soft, between cold and hot, between the lithosphere and the asthenosphere. The fire line that circles the planet is invisible, unmapped in detail, but known, felt in its effects, in earthquakes, in volcanoes, in the slow drift of everything, somewhere, right now, beneath the ocean, beneath the land, there's an eruption, building in silence, an unseen eruption that might not happen for 1,000 years, but the process has begun, magma accumulating, pressure increasing, pathways opening, slowly, so slowly. The eruption builds, in silence, in darkness, in the realm of the wall of fire, and no one knows, no one can know exactly when, or if, or where, only stood that it's happening, somewhere, always, beneath the quiet world. Every ocean holds beneath its floor a glowing frontier where new crust forms, where plates separate, where the wall of fire rises closest to the surface. This frontier runs down the center of ocean basins, marked by ridges, by rifts, by lines of underwater volcanoes. The glowing frontier underneath every ocean is the birthplace of sea floor, of new rock, cooling from molten to solid, to part of the plate that will drift away, carrying the ocean floor millimeter by millimeter away from its birthplace, before fire breaks through, before an eruption becomes visible. There's a soft trembling, micro-earthquakes, too small to feel, but recorded, measured. This trembling is magma moving, rock fracturing, pressure adjusting. The soft trembling before the fire breaks through can continue for years, for decades, a warning, a preview, or sometimes nothing. The trembling stops, the magma cools, the eruption never comes, just trembling, then quiet, then sleep. In frozen regions, under ice, under permafrost, there's sometimes a buried furnace, a source of heat from below, from the wall of fire, rising through thin crust, creating geothermal areas, hot springs, even volcanoes under ice. The buried furnace beneath frozen regions seems impossible. Ice and fire together. But the earth holds contradictions, holds everything. Cold above, heat below, separated by just a few kilometers of rock. Continents don't just sit on the mantle, they're held together by a red-hot boundary. The boundary, the wall of fire, provides the heat, the lubrication that allows continents to move, to collide, to break apart. Without this boundary, this red-hot seam holding continents together while letting them drift, the surface would be frozen, locked, unchanging. But instead, there's motion, there's change, there's the endless dance of land masses moving on. The glowing boundary, rising magma, leaves behind a quiet distortion in the rocks above. The rocks bend, warp, change their properties as heat and pressure work on them. This distortion marks the passage of magma, the approach of the wall of fire toward the surface. Even when magma doesn't erupt, doesn't break through, it leaves this mark, this quiet distortion that geologists can read like a story of heat and movement and almost eruption. There's a crack, a long crack, running through the crust in some places. This crack goes deep, down to or through the wall of fire. And in this crack, the world almost splits. Almost, but not quite. The crack marks a rift zone, a place where the crust is being pulled apart, slowly, where eventually an ocean might form, or where the rifting might stop, heal, become a fossil of ancient stress. Either way, the crack remains, reminding us that the world almost splits, but holds together, held by the strength of rock, the slow pace of geological change, beneath cratered plains, beneath landscapes marked by ancient impacts. There's sometimes a slow boil, rising heat from the wall of fire. The boil isn't rapid, isn't violent, just a gradual increase in temperature, in pressure, over millennia. The slow boil beneath cratered plains might eventually create volcanism, or might simply warm the region, create geothermal gradients that affect groundwater, mineral formation, the deep chemistry of the crust. Through stone, through solid rock, a pressure wave travels, too slow to feel, too deep to hear. This wave originates from changes in the wall of fire, from new magma arriving, from convection patterns shifting. The pressure wave, traveling through stone, takes years to move, a few kilometers, decades, to cross a continental margin, but it travels constantly, adjusting, balancing at the stress, the strain, throughout the crust, behind a thin crust just a few miles thick. In some places, there's an inferno, hidden, not raging, but present. The inferno is the wall of fire, closer here, more accessible. The thin crust above is all that separates the surface world from this hidden inferno, and in these places, heat flow is high, geothermal gradients are steep, and the potential for volcanism, for geothermal energy, for sudden change is always present, hidden behind the thin barrier. The future of Earth, a path of heat, carving the Earth's future, is already being written in the currents of the mantle, in the position of the wall of fire, in the distribution of heat below. This path will determine where continents move, where oceans form, where mountains rise over the next 100 million years. The path is being carved now, slowly, invisibly, by heat, by pressure, by the ancient engine that never stops. From the wall of fire, plumes rise, and when they reach the crust, they reshape the sky. Not physically, but they change the atmosphere through eruptions, through gas release, through particles ejected into the stratosphere. These rising plumes that reshape the sky have changed climate, altered ecosystems, even caused extinctions in the deep past, and they will do so again someday, but not tonight. Tonight the sky is clear, and you are safe and warm and drifting under sleeping mountains, mountains that haven't erupted in recorded history. There's a drifting blaze, molten rock, or partially molten, moving so slowly, accumulating, waiting. The drifting blaze under sleeping mountains is the reason. They might wake someday, but sleep for mountains can last 10,000 years, 100,000. And in the meantime, there's only the drift, the slow accumulation, the patient heat beneath the sleep. Islands rise from the sea, pushed upward by a molten undercurrent. This undercurrent flows from plumes in the mantle, passing through the wall of fire, bringing heat, bringing buoyancy, bringing rock that wants to rise. Islands form, one eruption at a time, building. Coral grows on them. Life colonizes. They become ecosystems, and beneath it all, the molten undercurrent, pushing upward, creating, sustaining, the foundation of life above. Ancient fissures, cracks in the crust that opened millions of years ago, are sometimes filled with firelight, with magma that rose, then cooled, then crystallized, leaving behind veins of different rock, mineral-rich, heat-altered. These ancient fissures, and filled with the frozen memory of firelight, are mined sometimes for metals, for gemstones, for resources that exist only because the wall of fire once touched this place, once filled it with molten potential. Beneath faulted ridges, beneath mountain ranges formed by compression, there's sometimes a secret glow. The glow comes from friction, from pressure, from the fact that the wall of fire might be closer here, or heat flow higher. This secret glow beneath faulted ridges affects the strength of rocks, the depth of earthquakes, the style of mountain building, everything connected to heat, to the presence of the wall of fire, even in places where it seems distant, cold, unrelated, remote deserts, dry landscapes, far from water, sometimes hide beneath them a simmering cauldron, a geothermal reservoir connected to the wall of fire through fractures, through thin crust, through the accidents of geology. The simmering cauldron under remote deserts holds water, superheated under pressure, ready to flash to steam if the pressure drops, if a well is drilled, if the balance is disturbed. But undisturbed, it simply simmers, has simmered for millennia. A seam, a fiery seam, threads through oceans and continents, connecting them. This seam is the global network of the wall of fire, of plate boundaries, of spreading ridges, of subduction zones, all connected in 3 dimensions through the depth of the earth. The fiery seam threading continents is why an earthquake in one place might change stress patterns thousands of miles away. Everything connected, everything part of one system. Look to the horizon of a world still forming, and you see the red glow of processes not yet complete. The Earth is not finished, not static, still forming, still changing. The horizon glows red, metaphorically, with the heat of ongoing creation, of continents colliding, of oceans opening, of mountains rising, all powered by the wall of fire, the heat engine that keeps the world dynamic, alive, never finished, always forming. Every surface, every landscape carries a heat signature, invisible to the eye, but real, measured, known. This signature tells the story of what lies beneath, how deep the wall of fire waits, how much heat flows upward. The heat signature no surface can hide is written in temperature gradients, in geothermal measurements, in the thermal glow that infrared satellites can detect. Everything revealed by heat toward the crust. From the depths, a molten tide creeps, not quickly, but inexorably. This tide responds to pressure, to temperature, to the endless circulation of the mantle. The molten tide creeping toward the crust might arrive at the surface, might not, might cool, might solidify, might remain forever in the middle of its journey. But it creeps, continues, moving, like time, like sleep, inevitable, patient. The caldera, collapsed, quiet, filled perhaps with a lake, might be awakening. The kindle, the slow kindle, shows in gas emissions, in small earthquakes, in ground deformation, measured in millimeters. The slow kindle of an awakening caldera might lead to eruption, might lead to nothing, just a stirring, then back to sleep. But the kindle has begun. The wall of fire is sending heat, is sending magma, is testing the barriers between depth and surface through tectonic scars, old wounds as a crust. A hidden spark travels. This spark is new magma, new heat, finding old pathways, old weaknesses, exploiting them, rising through them. The hidden spark, traveling through tectonic scars, connects the past to the present, uses ancient structure to create new volcanism. Everything in geology is recycled, reused, repurposed by the patient work of heat and time. In the earth, there's circulation, deep earth circulation of heat. This circulation is convection in the mantle, rising where hot, sinking where cool, creating currents that drive plate tectonics, that power the wall of fire. The circulation has continued for billions of years, will continue until the planet cools, until radioactive elements decay, until the heat finally dissipates. But that day is billions of years away. For now, the circulation continues, thump, thump, like a heartbeat, eternal. Near the core, at the boundary, between the molten outer core and the solid lower mantle, there's a boundary layer, thin, distinct, where heat transfer changes character. This layer feeds heat into the mantle, drives plumes, influences the wall of fire. Everything begins here, at the boundary between the hottest and the merely hot, where the planet's heat makes its first journey toward the surface, across the lithosphere, from the cold surface to the hot asthenosphere. There's a thermal gradient, a steady increase in temperature with depth. This gradient varies from place to place, steep in some areas, gentle in others. The thermal gradient across the lithosphere determines where the wall of fire sits, how deep it is, what temperature it reaches. It's different under oceans, under continents, under mountains, under rifts, but always there, always increasing with depth. In the mantle, convection organizes into cells, convective cells, large regions where material rises, spreads, cools, sinks, rises again. These cells are thousands of kilometers across, and they circulate over millions of years. The convective cells of the mantle are the engine, the true engine, behind everything. They organize heat flow, create the wall of fire, drive plate motion, shape the surface, all because hot material rises, cool material sinks, and the cycle continues forever. Deeper in the mantle, at high pressure, high temperature, there's a temperature curve called the adiabat, the deeper mantle's adiabat. This curve describes how temperature increases with depth in a way that reflects compression, the squeezing of rock by the weight above. The adiabat is important because it determines where melting can occur, where the wall of fire forms, where solid becomes soft, becomes molten, all determined by this curve, this relationship between depth and heat. The wall of fire exists partly because of viscosity contrast. Viscosity is resistance to flow, and at the wall of fire, the viscosity drops dramatically. Rock above flows very, very slowly, or not at all. Rock at the wall of fire flows like thick honey. The viscosity contrast just at the fire line creates a boundary, a zone of weakness that enables everything, enables drift, enables motion, enables change. Without this contrast, the earth would be frozen, still, dead. Above hotspots, above mantle plumes, there's sometimes a geoid anomaly. The geoid is the shape of Earth's gravity field, and hotspots create bumps in it, anomalies, because the hot rock is less dense, pulls less. The geoid anomaly above hotspots is measured by satellites, by careful mapping of tiny, tiny variations in gravity. These variations, invisible, unfelt, reveal the presence of heat below, of the wall of fire, of plumes rising from the deep. At the wall of fire, rock has a certain rheology, a certain way of deforming under stress. It's not purely viscous, not purely elastic, but something in between. Viscoelastic, viscoplastic, complex. The rheology of semi-molten rock determines how quickly plates can move, how stress is distributed, how earthquakes occur. Everything about the solid Earth's behavior depends on this rheology, this complex response to heat and pressure and time. At mid-ocean ridges where plates pull apart, there's heat flux, enormous heat flux, heat flowing from the mantle through the thin crust into the ocean, warming the water, creating circulation, supporting unique ecosystems. The heat flux at mid-ocean ridges is the highest anywhere on Earth, because here the wall of fire approaches closest to the surface. Here the planet breathes most strongly, exhales heat, creates new crust, renews itself. When a plume head rising from deep impacts the crust from below, it creates a volcanic province, large igneous province, covering the thousands of square kilometers with lava. The plume head impacting the crust might cause mass extinction, climate change, dramatic reorganization of ecosystems. These impacts are rare, millions of years apart, but they happen, have happened, will happen again when the wall of fire sends up its largest emissaries, its plume heads. The world changes. In certain regions, seismometers detect a shadow zone, a place where seismic waves are absorbed, slowed, distorted. This shadow zone, near the fire, the wall of fire, indicates partial melting, the presence of molten or semi-molten rock that absorbs seismic energy. The shadow in the seismic data reveals what we cannot see, what lies hidden in the depths, glowing, waiting, existing in the dark. The asthenosphere, weak layer below the lithosphere, contains within it a certain melt fraction, a percentage of molten rock mixed with solid crystals. This melt fraction within the asthenosphere is usually small, perhaps 1 to 5%, but it's enough to weaken, enough to allow flow, enough to create the wall of fire, the boundary where everything changes from rigid to soft, from locked to mobile. And so, as you lie here, drifting, sinking, into the mattress, into sleep, into the dark, remember that beneath you, far beneath, the wall of fire glows, eternal, patient, unchanged, for millions of years. It will be there tomorrow when you wake. It was there yesterday. It will be there long after you, long after everyone. The wall of fire breathes beneath us, keeps the planet alive, keeps it moving, changing, creating, and you can rest, can sleep, can let go, knowing that everything is in motion, slow motion, but motion nonetheless. The universe keeps turning. The wall of fire breathes beneath us, and we'll keep drifting, floating together through the mysteries. 100 wall of fire mysteries, looping softly, endlessly, through the night. Tonight we'll drift through the blazing boundary where the horizon begins to melt. the hidden current stirring behind the planet's burning veil, the ancient powers driving the wall of fire ever higher